Welcome to the AWS Certified Solution Architect Associate Training. Let me briefly introduce myself as an instructor. I have experience in developing the enterprise system and the cloud architecture for some major companies. And besides this course, I offer tutorial on cloud services and programming on Udemy and YouTube. I also offer courses to prepare for the other AWS certification exam and tutorial on the other cloud services like Google Cloud and Azure on Udemy. And this video course is designed for those aiming to pass the AWS Certificate Solution Architect Associate exam. It includes around 10 hours of video content that explain key points frequently tested in the exam. And we cover all the services within the exam scope. The hands-on videos are provided, allowing for the practical, real-world learning. Plus, we've included a practice question to help you prepare. I wish all students the best luck in passing the exam and continuing to enhance your skill. And thank you for joining us. Welcome to the AWS Certified Solution Architect Associate Training course. This course is organized into 4 main sections. In Chapter 1, AWS Certification Exam and Preparation, in this section, you will receive an overview of AWS certification exam and explore various study methods. Chapter 2, Introduction to each service, we cover all the services featured in the Solution Architect Associate exam, providing through the introduction to each service. Chapter 3, the practice question. This chapter will provide the statistics and the important tips related to the certification exam. And the final chapter, the summary, I'm going to introduce additional learning resources and service resources to help you preparation. So alright, let's start chapter 1. In this section, I'm going to introduce an overview of AWS, the detail of the certification exam, and how to set up AWS account. First off, let's talk about what AWS is all about. AWS, or Amazon Web Service, was founded in 2006 and has grown to become the leading cloud platform. It began its journey as a service within the Amazon.com and gradually expanded to offer services like the virtual servers and the storage, known as infrastructure as a service. Today, they now offer over 240 services and continue to grow their market share. AWS offers its services globally. As long as you have an internet connection, you can access their services. Their services are available in 245 countries and territories, with 32 regions and over 100 availability zones. And this is the cloud market share. Over the first few years, the AWS had held about a third of the global cloud market share. Since its foundation, AWS keeps top share. The AWS certification is highly recognized and is one of the most popular in IT world. And this is a comparison between cloud and on-premise solution. One of the main benefits of the cloud services is how easy it is to deploy the resources over the internet. In addition, you only pay for what you use, which usually means lower cost. But moving to the cloud is not just about saving money. The standardizing the infrastructure can also make management easier. Let me give you a quick overview of how AWS started. In the early days, AWS grew alongside Amazon.com's business. The demand in e-commerce changes with the season, like during the Christmas and Black Friday, when lots of products are bought and Amazon system get busy. To make better use of their resources, Amazon decided to rent out their extra server capacity to other companies during the off-peak times. AWS officially launched in 2006. That same year, they introduced the S3, an object storage service, and EC2, a virtual server services. Now AWS offers over 240 different services. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers. This is given by Google Cloud. All three cloud providers offer similar services. If you've had experience with Google Cloud or Microsoft Azure, this comparison chart helps you understand AWS well. And for those looking to study not only AWS, but also for other cloud services, the document can be quite handy. Next, I will talk about your AWS learning path. In this section, I will explain learning method for different certification levels. The AWS offers certification exam at 3 levels: the foundational, the associate, and professional. The foundational level is designed for beginners just starting to learn AWS. The associate level is for those with about 1 year of the practical experience, and the professional level is for those with 2 or more years of experience. And if you are a beginner preparing for foundational exam, I recommend starting with the video content that provides an overview of AWS service. The official AWS document can be overwhelming because it has a lot of information which might be too difficult for beginners. To grasp the basics, we suggest using the packaged video content from platforms like Udemy to get an overall picture. And if you already have practical experience and are already familiar with the AWS, I recommend focusing on complementing your existing knowledge. Generally, the video content contains more information than text data. It is said that the 1 minute of video content is equivalent to over 30 books in terms of information volume. However, this comparison is about the amount of information, not the knowledge you can get. Watching a 1 minute video doesn't provide the same depth of knowledge as reading 30 books. And video learning is typically a passive learning style, while text-based learning using document, the books, or practice question is more active. For advanced learner, in particular, the text-based learning tends to be more efficient. As you progress in your AWS journey, adapt your learning style to match your growing expertise and the increasing complexity of the material. When it comes to studying, there is no one-size-fits-all approach to studying. Learning style is different by person, and the time needed to pass the exam is also different by person. Easy and hard are subjective and are not universal truths. In addition, the Roma was not built in a day. Engineering skills are built over time. The IT world is rapidly evolving, so there is no end to learning. To make the most of any free time to find a suitable way to keep learning. Earlier, I told you that the way of studying differs from person to person. In this course, I will be breaking down the AWS services by category, and after that providing the practice questions. Whether you want to dive into the lecture first or tackle the question is totally up to you. and this course also includes some hands-on exercise. I'll guide you through the steps using the management console. Next, I'm going to introduce overview of the exam. And here is an overview of the AWS certification exams. As previously mentioned, AWS certification exams are offered at 3 levels: the foundational, associate, and professional. Currently, there are no prerequisites for taking these exams, which means you can take them at any time based on your experience and skills. For example, you can take a professional level exam without holding an associate certification. In addition, AWS also offers specialized certification in advanced networking, machine learning, and security. There were major changes made to the lineup 2024. The database and the data analytics exam were discontinued, and the new data engineer associate certification was added. And furthermore, the AI practitioner and the machine learning engineer associate were added. It is expected that the AWS will continue to add or discontinue certification to align with the industry trend. And here is a lineup of associate exam. As of September 2024, there are 5 different certifications available. Starting from the top left, the Sysops Administrator exam is for the operational manager. The developer exam is for developers and focusing on development tools. And the solution architect are usually tested on the wide range of services use case since they work closely with customer. Data engineers focusing mainly on data analytics tools. And lastly, the machine learning engineer tested on AI and machine learning tools. At all levels, the exam consists of either multiple choice or multiple response questions, where you will choose the correct answers from option A, B, C, and D. The associate exam has duration of 130 minutes and consists of 65 questions, and the exam fee is $150. Since the exam is lengthy, it's very challenging to keep concentration. For taking exam, I highly recommend that you practice by timing yourself and getting accustomed to the exam session. And this image shows the number of services covered in each exam. The cloud practitioner covers 124 services, associate covers 132 services, and the professional covers 158 services. The current exam guidelines have been effective since 2022, and the number of the services has increased compared to that of the previous version. At this time, AWS offers about 240 services, which means that the associate exam covers more than half of these services. According to the exam guide, the associate exam is designed for those with more than 1 year of experience. While you don't actually need to have the 1 year's experience, but I highly recommend that you study thoroughly because their exam is challenging. The exam consists of 65 questions, but only 50 of the questions will impact your score. In other words, 15 questions will not affect your score. These 15 questions are used by AWS for research purposes. Therefore, you may encounter the question about the services which do not appear in the exam guide. And the passing score is the 720 out of 1,000. The exam covers 132 different AWS services. Next, I will introduce the exam domains. In the associate exam, the domain listed here are tested according to their respective weightings. Now I will cover all the services throughout the tree in this course, so you don't need to worry about the exam weight of each topic right now. And then finally, here is the sample questions. Here is a sample question with 5 choices, A, B, C, D, and E. There are questions where you need to select 2 or 3 correct answers. About 30% of the questions are multiple response, and they tend to be more difficult because you must select all the correct answers. Next, I will introduce how to create an AWS account. And first, I will introduce the tools for developed and managing in AWS. The Management Console, or simply the console, is a tool that allows you to manipulate graphically via a web browser. It is the first page you access after creating an account, from which you can access various services. The CLI, or command line interface, is a tool to control services via the command line. You can access the AWS environment using the access key and the secret key. And there is also the Cloud Shell, which allows you to access the console once and control the CLI from your browser. You can manipulate the CLI without any setup. And SDK, the Software Development Kit, is a tool for developing the various AWS services. It provides the language-specific APIs for each service, such as Python and Go. And you can access the AWS with an access key and a secret key. And this is a step to create a root account and IAM user. And first, create a new AWS account and then set up IAM user. The IAM is a service that manages the permission of the users in AWS. I will explain it again in the next chapter. First, search AWS in your browser and go to the AWS web page. And you will see the button in the upper right corner that says Sign into the console, and click it. And if you already have an account, you can sign in from this page. To create a new account, click Create a new AWS account. Enter your email address to authenticate your email, and the verification email will then be sent to that email address. Next, enter your personal information such as your address, the credit card, and the phone number. A credit card or debit card is required for your billing, even if your billing is 0. And if you are not belong to the corporation and use AWS for personal development or just learning, I recommend you to choose the basic plan, which is free of charge plan. For developer plan and the business plan, you can get support from AWS customer engineers. And once you have completed this process, the AWS account will be created successfully. And this is a page called the Management Console, and this will be the main page when you use the AWS resources from now on. Now, I'm gonna configure IAM. The first account that created is called the root user, and it will be a powerful account like an administrator with access to your credit card. If the account is compromised, there is a security risk. Therefore, AWS recommends that you create an IAM user and sign in as an IAM user instead of using the root user. And first, type IAM in the search window above and move to the IAM dashboard. And this is the IAM dashboard. In the initial state, the root user has MFA, is marked with the red triangle. It is recommended that you install the token apps on your smart devices. And next time you sign in as a root user, authenticate with MFA. And next, create an IAM user. The next time you sign in as usual, sign in as IAM user. You should not sign in as a root user except when checking your credit account. Now click on the user in the left menu bar, then Add User. And set the username first, and check the access key and the password field for the credential types. The access key is used for the API, CLI, and SDK, and the password is used to sign in the management console. Select the Attach Existing Policy directory and choose the Administrator access. And this will give you the IAM user the privilege to accept the credit card access. And tags can be any text you like. The tags allow identification of IAM user. If you create multiple users in the future, you may set tags to identify each user. And after successfully creating a user, and be sure to save the access key and the password that displayed. You can also download this in CSV format. And when you have done setup IAM, you will return to the console again, and I will briefly introduce to the structure of the screen. From the menu bar above, you can move to various management screens, and you can return to the top page by clicking the AWS logo on your left. And click on the Services to see all the services offered by AWS by category. And you can also register frequently used services as favorite. And click on the CLI logos to open the Cloud Shell. And by doing so, you can manage the command line from within your browser as well. Click on the bell mark to view various notifications, and you can find out about the event, changes, and the incident for the services you are operating. And click on the question logo to get support. The type of support available depends on the plans. For example, the basic plans allow the ticket-based question about the fees, while technical support is available with paid plans. By clicking on the gear-shaped logo, you can edit the language, the visual mode, and so on. And this is a recently added feature. The menu bar configuration may change in the future. And next, click on the bring down where the region name is listed to navigate to AWS region. The Northern Virginia is selected by default. And basically, by selecting the region that is close to where you want to deploy your services, and you can access your resources with low latency. And also, the services deployed and the fees vary slightly by region. Since the AWS is a US company, so release generally the earliest in the US region, and then after rolled out to other regions. A document and the other information is available in English for the latest services, and is gradually being translated into other languages. And finally, you can check account information you have created from the upper right corner of the console screen. And clicking on the organization will take you to the AWS Organizations service page, where you can view the information about the organization you belong to. And from here, you can also check your service quotas and usage status and so on. And if you need to access credit information, you will need to sign out of your IAM user and sign in as a root user. In Chapter 2, I will introduce each service. And here is a list of the service categories. In this chapter, we will cover all the services appear on the Solution Architect exam. So, let's start with the management, monitoring, and governance. And here, I will introduce the multi-account management tools like AWS Organizations, logging and monitoring services like CloudWatch and CloudTrail, and resource management tools like License Manager and System Managers, as well as CloudFormation, Elastic Beanstalk, and cost management services. So let's start from AWS Organizations. AWS Organization is a service that helps you manage multiple accounts in hierarchical structure. With AWS Organizations, you can create the organizational units, OUs, to group and manage individual AWS accounts. While you can manage the account permission using the IAM, managing accounts at the organization level can be challenging. In large organizations, where there are lots of employees, the creating individual accounts and management for each person requires significant effort. With AWS Organization, you can centrally manage policy across your entire organization, making account management much more efficient. Let me introduce the main feature of AWS Organizations. You can make account creation easier using the Organizations API. The API stands for Application Programming Interface, but here, just think about the commands that help you manage AWS resources. With the Organizations API, you can create multiple user accounts at once. It takes a lot of time to manually create each account with Management Console. AWS Organization is really helpful for companies with lots of employees. With AWS Organizations, you can use consolidated billing, with which you can manage billing centrally by organizational unit. Normally, AWS bills each account, but with consolidated billing, you can handle it all at once at the organizational level. In addition, you can share the quotas and discounts across your accounts with it. A quota is basically a limit on how much of the resources you can use. With AWS Organizations, you can share these quotas with other accounts in your organizations. And you can also share free usage and discounts like reserved instances and saving plans within your organizations. The AWS offers discounts for long-term users, and I will explain the detail of discount plan again in the other chapter. The next one is SCP. The SCP, or Service Control Policy, is a policy that you assign to organizational unit. By linking SCP to this unit, you can centrally control the account within them. For example, if you want to block certain action across your organization, you can do it more easy with SCP than by setting IAM policy for each account individually. In SCPs, action denied at a higher level is also denied at a lower level. On the other hand, actions allowed at a higher level are also allowed at a lower level, or you can filter them as needed. In general, the principle of the least privilege is the key to cloud security. In an organization, the higher level roles have more privileges, while lower level roles only get the minimum they need. For example, SCP is helpful if you want to block the launch of certain EC2 instances across your organizations. You can set the parent level to allow launching the EC2 instances and the child level to block specific ones. Here's an example of HCP written in JSON format. The policy on the left allows the entire organizations to launch EC2 instances, while on the right, it blocks the specific EC2 instances from being launched. In this case, the condition key prevents the launch of the M5.large instance type. And you can see effect field say deny, which means it blocks that actions. So a lower level can still launch EC2 instances other than M5.large. And if you want to block an action that's allowed at the higher level in the lower level, you need to explicitly deny it. And you can also selectively deny by specifying the condition field. For example, you could allow an action only in a specific region or for specific resources. Or you can require multi-factor authentication (MFA) for certain actions. In this way, you can increase your security. AWS Organizations is often used alongside other services. Let me give you some example. The AWS provides the infrastructure as a code, or IAC, which lets you define the infrastructure using code. The CloudFormation is a popular IAC service. By combining the AWS organization with CloudFormation, you can create the stacks across the multiple regions and the AWS account, which minimizes the management overhead, because you don't need to set up IAM role to each user individually. I will introduce the CloudFormation in the next chapter. Second example is AWS CloudTrail. The CloudTrail is a service that lets you get the trail of what your account does. With CloudTrail, you can see what actions were taken, when they happened, and on which resources. This helps you figure out what went wrong if there is an issue. By using AWS Organizations with CloudTrail, you can get the trail of account within your organizational unit. The CloudTrail logs can be exported to S3, which is AWS storage services. And when exporting, the organization's ID is added to the prefix, making it easier to find logs within your organizational unit. In the information security, there are two basic concepts, the prevention and detection. The prevention is the process of stopping incidents before they happen, while detection is about finding them after they happen. In other words, the prevention is proactive and the detection is reactive. In AWS, the term guardrail is often used. SCPs are considered preventive guardrail. I'm here to introduce to the AWS services that handle the prevention, the protection, detection, response, and the recovery. For prevention, there is the AWS Organizations SCP, System Manager, and the Config. For protection, we have AWS Shield and the Firewall to prevent the DDoS attacks. And the detection includes the operational monitoring services like CloudWatch and CloudTrail, as well as the vulnerability detection tools like Amazon Detective, Inspector, Macie, and GuardDuty. And we'll dive into these services again in the next security chapter. And when it comes to response and recovery after the incident, AWS offers automation tools like Lambda, the CloudFormation, and the System Manager. And for reference, the NIST Cybersecurity Framework defined the 5 core functions: identification, protection, detection, response, and recovery. Next, I will introduce AWS Control Tower. And you can use AWS Control Tower with AWS Organizations to deploy a landing zone. A landing zone is a solution for setting up and governing the multiple account environment. As your company grows, management and governance of multiple accounts become more complex. The AWS Control Tower helps by automatically setting up a multi-account environment. It includes the configuration for accounts, organizational unit, IAM, networking, security, logging, compliance, and governance. In this context, the landing zone is a blueprint for initial configuration of your environment. The term originally referred to the helicopter landing zone. Similarly, in the cloud industry, a landing zone is used to describe the initial design of the safe and secure environment setup. And here is an overview of a Control Tower. The Control Tower allows you to set up organizational structure in AWS Organizations. For example, this landing zone has OUs for log archiving, auditing, and development. The log archiving unit has access to CloudTrail and Config. The CloudTrail is a service that provides a trail of account activities, and the Config is a service that tracks the history of resource changes. In other words, the log archiving account is dedicated to managing the logs account and the resources activity. Conversely, no other operations are allowed by policy. Similarly, the OUs for auditing and development can only operate on security-related services and network services, respectively. The AWS and the IT industry in general recommends the principle of the least privilege, meaning that only the minimum necessary permission should be granted. With AWS Control Tower, you can manage your organization's security policies and governance by setting up account rules in advance. Next one is AWS Service Catalog. Service Catalog is a service that provides a centralized control over the creation and management of AWS resources. And this improves the IT governance and compliance, and it can also standardize the resources usage across an organization. A service catalog allows you to create a catalog of products and enables the authorized user to deploy them. And here, the products refer to the collection of AWS resources defined in CloudFormation template. For example, you might have a simple template that sets up the S3 bucket. The administrator creates this template, and the end user deploys the resources based on it. The actual template typically includes more detailed information such as IAM policy, region, and network setting. The end user can only deploy resources they are authorized to, providing the governance and the control over the organizations. And here is the workflow for administrator. This is a reference from the official document. The administrator defines a catalog, which includes a portfolio and product. And the portfolio is a collection of multiple products. The administrator can specify the parameters such as activation setting, permissions, notification method, and region. By associating these catalogs with users and accounts in AWS organizations, the users can deploy AWS resources based on the specified template. AWS Service Catalog also supports version control. On the other hand, here is a workflow for the user side. The user can deploy AWS resources based on the products assigned to them and manage those resources. And behind the Service Catalog, the CloudFormation templates are used, allowing the resources to be launched by specifying the resources and the parameter defined in the template. For example, you can specify the type of EC2 instance, the region where it will be deployed, and other parameters. And finally, let me introduce AWS Resource Access Manager, RAM. RAM is a service that allows AWS resources to be shared across a different AWS account or within the AWS organizations. This eliminates the need to create and manage resources separately for each account. When using RAM to share resources between accounts, the resource owner simply invites other accounts to access the shared resources. You can share resources from the management console with just a few simple steps. Currently, RAM also supports global resource sharing. Next, I'm going to introduce logging and monitoring services. First, I will give you an overview of system monitoring. System monitoring is the process of monitoring a system to ensure that it is working properly. System monitoring includes the infrastructure monitoring such as servers, networks, and operating system, and the service monitoring such as software, DNS, and load balancer. It also provides a trail of who did what and when. You can take appropriate action when the problem occurs. And furthermore, it's also necessary to take a history of changes of the resource side, such as whether the resources in operation are compliant with the appropriate rules. AWS provides the following services: the CloudWatch as a system monitoring tool, the Config as a resource change management tool, and the CloudTrail as a trace management tools. So let's get started with Amazon CloudWatch. Amazon CloudWatch is an integrated operational monitoring service. It has many features and can monitor any AWS services, making it the most widely used monitoring tools. The CloudWatch monitors AWS resources and can trigger action and alert based on the changes in logs and metrics. You can find the complete overview of CloudWatch's functionality here. It collects the logs and metrics from monitored EC2 instances, raises an alert if a preset threshold is exceeded. It also sends a notification via SNS, and it can work with Lambda function to perform necessary actions. SNS, or Simple Notification Service, sends a notification via email or SMS. Lambda allows you to link services together using the functions. I will cover SNS and Lambda in more detail in later chapters. The CloudWatch logs capture application and server logs and provides the functions for analyzing the logs it collects. Logs are a record of activity and information, such as computer usage and data communications. In CloudWatch logs, the log retention periods can be specified from 1 day to unlimited, which is useful for logging purposes like auditing. And the logs can also be filtered with a standard query. For example, you can filter by specific strings to analyze how often certain errors occur. And here's a simple sample query that streams the VPC flow logs to CloudWatch logs and extract them for the specific time period and address. In practice, The logs record can number in the thousands or even tens of thousands, so be sure to filter appropriately to extract only the information you need. And VPC flow logs are traffic logs for the AWS Virtual Network Service, VPC. I will cover this in more detail in the networking chapter. And next is the CloudWatch metrics. The metrics are measurements taken over the specific time period, providing the information about system health and performance. The metrics can be automatically obtained from the various AWS services or through APIs. In addition to standard metrics like CPU usage and HTTP request, you can also create custom metrics tailored to your needs. Besides AWS resources, you can retrieve metrics for on-premise systems and other cloud services. The metrics can be collected by installing the CloudWatch Agent on Linux and Windows servers. An agent is software installed on the device such as a server or network equipment. The agent collects the data from the system and sends it to the CloudWatch. Next is CloudWatch alarms. CloudWatch alarms are triggered when the predefined thresholds are exceeded or abnormal activities are detected. Alarms can also trigger SNS notifications and actions, allowing you need to respond to incidents quickly. You can set the statistics to be monitored, the time period, the threshold for triggering the alarms, and the specific metrics to be alarmed on. Alarm state includes OK, alarm, and insufficient data. For example, you can set an alarm to trigger if CPU utilization is 80% or higher 5 or more times within an hour. Next, the CloudWatch event allows you to take a specific action based on the event on the rules. You can trigger actions on the target based on these events and rules. There are two types of event sources, the schedule and event. A schedule defines an event such as triggering the action on a certain day of the week. The event trigger action when metrics for resources exceed a certain threshold or when there are changes in the resource status. You can define the schedule using methods like late or coulomb. Examples of the late and coulomb expression are listed in this table. The target is AWS resource where the action will be executed, and the CloudWatch events are often used in conjunction with Lambda functions. You can set up one event to trigger another AWS resource to perform an action. And here I will introduce Amazon Event Bridge. In 2019, CloudWatch event was separated into its own service called Amazon Event Bridge. Functionally, Event Bridge is fully compatible with CloudWatch events and extends its capabilities. Event Bridge retains the service's name and the API that CloudWatch event used. Additionally, Event Bridge can integrate with non-AWS resources, which was not possible with the earlier version of CloudWatch events. Next, I will present an example of server management using the CloudWatch Agent. But this won't be covered on the associate level exam, so feel free to watch this as a reference. I will use an example of setting up and running a CloudWatch agent to demonstrate the implementation. And first, attach an IAM policy to the target resource. Then use the System Manager to install, configure, and start the CloudWatch agent. And finally, configure CloudWatch for monitoring. If necessary, you can adjust the CloudWatch settings during the operation as needed. And first, attaching IAM policy to the target resource. The default policies related to the CloudWatch agent includes the CloudWatch agent admin policy and the CloudWatch agent server policy. The CloudWatch agent admin policy allows SSM to put parameter, which enables the configuration file to be written during the setup. But after setup, this put parameter is no longer needed, so CloudWatch agent server policy is sufficient for operations. The Amazon SSM managed instance core grants the permission to use the core features of System Manager. It includes the permission for executing the command and sending the output to the System Manager. So let's take a look at the JSON contents to the CloudWatch agent admin policy. It's a bit long, so I've split it into the two lines. The put metric data action is needed for sending metrics, and the put log event is required for sending logs. And the put parameter refers to the writing to the configuration file. This action is used during the setup and usually not needed during the regular operations. Following the principle of the least privilege, the put parameter becomes unnecessary after the setup is complete. Next step is to use the System Manager to install, configure, and start the CloudWatch agent. You can install the Amazon CloudWatch agent from the System Manager's distributor. The agent is configured through the terminal. The many AMI, the Amazon machine images, come with the agent pre-installed. For example, the Microsoft and the Linux AMIs released after 2016 already have the agent included. However, on some servers and on-premises server, you need to install the agent from System Manager. And you can also start the CloudWatch agent by running the Amazon CloudWatch managed agent from the run command. Once the CloudWatch agent is running, it will be sending the logs and the metrics from the server. The detailed settings for the metrics and logs that the CloudWatch agent captures are defined in the agent configurations file. And here you can set the correction interval for metrics and specify where the logs files are stored. In this example, you can specify the CloudWatch logs. In the metrics section, you can define the things like disk usage, the memory usage, and more. And you can also add dimensions for each resources. And in the log section, you can specify the log storage location, log file path, and the log stream. And finally, you can filter the logs you can get and visualize them in the dashboard. After installing the agent, you can filter logs by specifying the strings like errors, warnings in CloudWatch logs. And these logs can be filtered and used as the metrics. For example, if a log contains a certain string exceeds a specific threshold, it can trigger notification to other services. And for your reference, the metrics you can get with the CloudWatch agent include those listed here. The agent allows you to get the detailed metrics such as disk, CPU, memory, and network usage. Additionally, you can get application log, system logs, and HTTP access log with the CloudWatch agent. And this is a sample of the key metrics used by CloudWatch. I will not go over all of them since there are so many, but it's helpful to be familiar with them for practical use. The course materials are available in PDF format. Next, I will introduce AWS CloudTrail. The CloudTrail is a service that records user activity and API operation as a trail. It logs details like when, who, and what. The CloudTrail captures two types of event, the management event and the data event. The management event involves the creation, modification, and the deletion of resources, while data event relates to the operation on specific AWS services. For example, creating an S3 bucket is logged as the management event, while saving an object to an S3 bucket is logged as a data event. The trail includes the information such as the event timestamp, event name, username, and the resource name, and this allows you to track who did what and when and why. And the CloudTrail insights can also be enabled to detect and display anomalous activity logs. And please note that CloudTrail Insight is a pet feature. The management events are related to the management operation on resources. The data event, on the other hand, are related to the operation on specific resources. The management events are automatically recorded, but the data event needs to be explicitly enabled for logging. The CloudTrail Insight also records the anomalous pattern of detection. This is a pet feature that require CloudTrail Insight to be activated. The CloudTrail Insight identifies unusual activity related to the API call and the error rate. Insight events related to the API calls are generated for write management APIs, while events for API error rates are generated for both write and read management APIs. The CloudTrail Insights establish the baseline based on the activity over the past 7 days. Any unusual increases in the number of API calls compared to the baseline is logged as the insight event. The trails are stored for 90 days for free of charge. But if you want to keep them for longer than 90 days, you'll need to store them in S3, which includes additional storage fees. The trails stored in S3 are encrypted using the SSE S3. If you want to specify your own encryption key, you can use KMS. And if you want to prevent the modification or deletion of trails, such as for auditing purposes, it is recommended to use the KMS encryption, S3 bucket policy, IAM policy, and the MFA delete setting. Additionally, you can create a dedicated account for storing the trails, a separate operation staff from security administrator, and use digest files to detect any tampering with the trails. Next, I will introduce AWS Config. AWS Config is a service that logs configuration changes of AWS resources and evaluates whether they comply with organizational rules. The config stands for configurations. AWS Config tracks a resource's change history and evaluates the resources based on the specified timings. It's particularly used for enhancing the security and governance. For example, you can use config to create rules that ensure SSH connection and properly configured for EC2 instance. SSH is an encryption technology that secures traffic to the EC2 instance. In this case, The config will track the EC2 instance's startup and the modification history, and if it detects the EC2 instance has been started without SSH configured, it will notify you that the rule has been violated, and it can trigger corrective actions if necessary. The AWS config allows you to set up config rules, check compliance with your rules, and receive a notification when the resource doesn't follow the rules. The config rule includes the AWS managed rules, which are predefined by AWS by default, and the customer managed rules, which are customized by user. For example, the one of the AWS managed rule is the restricted SSH, which checks whether an SSH connection is configured for EC2 instance. The number of available rules has increased every year since the service was launched, and as of now, there are over 150 rules. When an event occurs, the config checks if the resources follow the rules and records the result. For example, an EC2 instance is evaluated when it is started or modified. And rules can be evaluated continuously or on daily basis. The continuous recording logs changes as they happen, while daily recording logs changes only once a day. The continuous recording can be more expensive due to the higher the number of notifications. The config is charged based on the number of rule evaluations. And you can integrate config with System Manager to automatically fix resources that don't comply with the config rules. The System Manager's automation feature can trigger when a config rule is violated and automatically perform fixing actions. And you can use the standard query to search the log history. While CloudTrail is a service that tracks API's activity on user side, the config is primarily focused on capturing the change history on the resource side. And here is the sample JSON of the items that can be retrieved with the config and the example query. And I'd like to introduce some additional feature of AWS config. The config can manage on-premise resources as well as AWS resources. To manage on-premise resources, you need to register the target resources in System Manager. The config can also be used across multiple accounts and regions. And it will be charged for config rules, conformance packs, and configuration snapshot stored in S3. Conformance packs are a collection of rules and resources packaged together. The next one is AWS X-Ray. The X-Ray is a service that collects the data about the request and application process to detect bugs and bottlenecks. In general, the microservices are challenging to monitor due to the complex interaction between the multiple services. So X-Ray is specifically designed for monitoring microservices. It can visualize these interactions in service maps and help identify bottlenecks. You can collect metrics such as response time, response status, and more. The various metrics are sent to X-Ray as shown in the image below. The result can be visualized in the service maps and the traces. The service map displays the service latency and the total number of traces captured per minute. You can also access X-Ray through the CloudWatch console. And this is an overview of the X-Ray components. When a trace is collected by the X-Ray SDK, it is sent to the X-Ray daemon. The daemon then uploads the trace data to X-Ray in batches. The X-Ray daemon is installed in the application environment such as the EC2 instance. The daemon is managed automatically, so you don't need to manage it yourself. However, you can adjust environment variables like the sending frequency, data volume limits, and more. In X-Ray, the document that records the service or API being traced is called segment. The segments contain information such as request, response, and errors. The segment data is collected from the application via the X-Ray SDK. The segment can be modified as needed to record API requests for specific services. And next is a service for the third-party monitoring tools. The Amazon Managed Service for Grafana, or simply Amazon Managed Grafana, is a service that allows you to use the third-party log monitoring tool Grafana within your AWS environment. By connecting it with the AWS monitoring services, you can monitor your AWS resources using Grafana. Grafana, developed by Grafana Labs, is a log data visualization service that allows users to visualize data by performing a real-time query on logs. From the console, you can select a data source to create a workspace and start monitoring. It can also be integrated with SNS and other notification services to issue alerts. The Amazon Managed Service for Prometheus, or simply AMP, is designed to work with Prometheus, an open-source monitoring tool. The Prometheus is the de facto standard, especially for the container-based system like Kubernetes. When you create an AMP workspace from the console, it aggregates the metrics from the AWS resources. These aggregated metrics can then be processed and queried using the language called PromQL. The Prometheus itself doesn't store the data permanently, so it's typically used with additional storage tools. With AWS AMP, the AMP workspace is automatically stored across the multiple availability zones, ensuring the persistent data storage. You can integrate Prometheus with Grafana. This allows you to design monitoring system where you collect the necessary metrics in Prometheus using PromQL and then visualize those metrics in Grafana. While this isn't directly related to the AWS certification exam, the Grafana is often used as the dashboard because it offers better visualization tools than Prometheus. And here is an example of EC2 instance metrics calculated with PromQL. For exam purpose, the Prometheus and the Grafana are not often tested, so just keep in mind their names and the basic overview. Next, I'm going to introduce resource management services. First, let me introduce to you the AWS System Manager. System Manager is an operational hub for hybrid environment, including both AWS and on-premise resources. It was originally released as the EC2 Simple System Manager, a server management service for EC2, and was later renamed System Manager in 2014. Because of its origin, it has enhanced functionality for server management, and it's sometimes abbreviated as SSM. It offers the features for support the system operations such as the application management, change management, node management, operation management, and quick setup. To use System Manager, you need to install the SSM agent on the managed server. The SSM agent is installed by default on the latest Amazon Machine Images (AMIs) for Windows and Linux. However, for on-premises server and some operating system, you need to install the SSM agent manually. I will now present an example how to implement System Manager. In practice, you will often use the combination of System Manager features. For example, here is an information on the EC2 instance that automatically keeps the OS and the software updated by combining the State Manager, run command, and automation. Run command allows you to remotely execute a command on the multiple servers. Normally, configuring an EC2 instance requires you to connect to its directory, which can be time-consuming. With run command, you can perform system update and patching across the multiple servers at once. A document is a JSON or YAML file that performs a specific task. It defines the script and the setting used by a system manager for tasks like resource state management. The state manager is used to maintain the configuration of instance. It automatically applies the configuration regularly to ensure it stays consistent with what's defined in the document, ensuring the system configuration consistency. And automation is used to automate workflows. Apologize for small text, but here the main feature provided by System Manager. And each of these features is important, so I encourage you to review them along with the slides and the hands-on session. System Manager allows you to establish a connection to the managed server without needing to open SSH port in the security group. Run command lets you execute commands on the managed server, such as updating the SSM agent, installing agent, and the other routine operations that can be documented and run. State Manager automates the process of keeping server in predefined state. For example, it can ensure the antivirus and malware protection are configured and maintained as specified. The Patch Manager automates the process of applying the security update and patches. And the quick setup can be used to centrally manage the patching process. And the quick setup provides the recommended setting for commonly used AWS resources based on the best practice. The maintenance windows allows user to schedule maintenance time in the colon format, which can be used with the automation to automatically perform maintenance at specified times. Automation is the function to automatically execute the process defined in the document and can be used in conjunction with other functions like a run command. Inventory displays a list of software running on the server. And the parameter store is a feature to store the password and other string information. It is similar to Secret Manager, but the parameter store is free of charge. Document is where the process to be executed, such as run command or state manager tasks, are systematically stored. Ops Center is the operational feature manages the events that occur during the AWS operations and helps you to respond to them as they happen. Explorer provides the dashboard view of the Ops Centers. While System Manager is the regional service, Explorer can be used across multiple regions and accounts. Change Calendar allows you to specify the specific date and times to perform scheduled tasks. And App Config manages the application configuration information and deployment. For exam purpose, you don't need to memorize all these features, but I recommend that you focus on the important ones. In particular, automation and the parameter store are frequently mentioned in the exam test. Next, I'll introduce to the AWS License Manager. License Manager is a service that centrally manages software license from the third-party vendor like the Microsoft, SAP, Oracle, IBM across both AWS and on-premise environment. And you can use dashboard to manage license usage, monitor expiration date, and check compliance status centrally. And when you launch an EC2 instance, you can control your license through the license settings. A license manager itself is free of charge. Next, I'll introduce AWS Health. AWS Health is a dashboard that provides timely information in the event of resource changes, the failure, and more. AWS Health notification can be triggered and linked to EventBridge and AWS Organizations. For example, if there is an event like a failure in AWS Health, you can integrate with EventBridge to stop the related services or send a notification. AWS Personal Health Dashboard displays real-time information about the failure of AWS resources used by the user. It shows the events from the past 90 days. The dashboard includes a section for open issue, scheduled changes, and other notifications. The Service Health Dashboard displays the public event logs for the past 7 days. And you can see an overview of AWS Health from the top of the console screen. This allows you to quickly detect any failure or notification for the service you are using. AWS Trusted Advisor analyzes your architecture and provides recommendations based on the AWS best practice. It offers the guideline in the area of the cost optimization, performance, security, fault tolerance, and service quotas, which are key pillars of the well-architected framework. And here is an example of the recommendation provided by the Trusted Advisor. For example, under the cost optimization, you might receive the suggestion or in the EC2 pricing plans, identification of unauthorized instance, and detection of unassociated IP addresses. And here, I'm going to introduce the well-architected framework, which serves as the fundamental design philosophy for AWS. The well-architected framework provides a set of best practice and the guideline for using AWS. It's built around the pillars of operational excellence, security, reliability, performance efficiency, and cost optimization and sustainability. The framework is essential for the effective development and operation of AWS architecture. Next, I'm going to introduce deployment tools. The AWS CloudFormation is an infrastructure as a code IAC service. IAC allows you to define infrastructure configuration as a code. For example, to start an EC2 instance from the console, it requires manual steps in your browser. If you need to launch multiple servers, it takes a lot of time and effort. Additionally, if you want to launch a server in a different environment with the same setting as an existing one, it's more convenient to document the configuration. IAC offers benefit in terms of the reproducibility. With CloudFormation, you can describe the resource configuration in the template using the JSON or YAML. For example, here is a sample template for creating an EC2 instance. Let me introduce the components of CloudFormation. The CloudFormation consists of the template, the stacks, and the target resources to be deployed. A template is a JSON or YAML file that describes the resources specs and configuration. And from this template, a unit called the stack is created, and which is responsible for the actually creating, the modifying, and deleting the resources. A stack can include multiple resources. For example, when you create an EC2 instance, you can include a network, load balancer, auto-scaling in a single stack. You can use also the stack set with AWS Organization, allowing you to create, modify, and delete the stack across the multiple accounts, which is particularly useful in collaborative deployment. And stacks can also have parent-child hierarchy. And starting on the next page, I will introduce each component. And firstly, I'm going to introduce template. And this is an example of a YAML template. In the resource section, you define the configuration of the AWS resources. In this example, an EC2 instance and a VPC are included. In the parameter section, define the value that will be used when the template is executed. For example, you can specify the machine type of the EC2 instance. In the mapping section, define the details like a region where the resources will be deployed. Next, I'm going to introduce change set. Change set offers a preview feature that you can understand the impact on resources before execution. You can understand the changes on the resources before actual execution. And here is the flow for the change set. You can either create a new template or directly edit an existing the template and preview the impact on the environment. And if everything looks good, execute the deployment. And if there are issues, modify the template before deploying. Next, I'm going to introduce drift detection. Drift detection is a feature that identifies the differences between the template and the actual resources. It's particularly useful for seeing what changes have been made to resources after they've been created by CloudFormation and then manually modified. You can perform the drift detection from the console or the CLI. Additionally, you can work with AWS Config to set up the management rules that automatically run drift detection as part of a config rule. This allows you to configure notification and corrective action if any differences are detected during the drift detections. And here is an image of the drift detections. The actual state of the resources is shown alongside the expected values. And the blue part highlights that indicates the differences, and the red highlights that indicates the deletions, and the green highlights that indicates addition. In this way, you can understand what differences there are between template and the deployment. Next, I will explain the error handling. If the error happens during the deployment, you must stop the deployment process, and the system needs to be restored to its original state. This process is called rollback. The CloudFormation monitors the status of stack creation, and it can take action if there is an issue. You can also set up the CloudWatch alarm for each rollback trigger you create. To handle the failure, you can retry the deployment, update the template, or roll back the process. The retry is a process to retry the deployment again without changing the template. This process is useful when the cause of failure is not about a template issue, such as access right, networking problem, or dependency problem. after resolving the problem and then retry from the point of the failure. And the update is to fix the template before retrying to create a stack. It will restart from the last point of failure. And the rollback is the process to restore the stack to its last known good state. And lastly, I will introduce the policies you can configure in the CloudFormation. A stack policy is a policy that controls resources within the stack during the update. It helps prevent an unintentional update by allowing or denying the spec actions. When a stack policy is set, all resources are protected by default. If certain action needs to be permitted, they must be explicitly allowed. The example here shows the policy that prohibits updates to the database. By default, all actions are denied, so the first statement allows updates to all resources. The second statement specifically prohibits the update to the database. Next, I will introduce SAM, the serverless application model. The cloud computing is classified into three categories: SaaS, PaaS, and IaaS. SaaS, the software as a service, provides the software over the internet. The PaaS, the platform as a service, offers the platform and middleware over the internet. And the IaaS, infrastructure as a service, provides the infrastructure such as servers and networks over the internet. And the serverless refers to the services that don't require server management. In the cloud industry, the serverless are mainstream because the cloud provider handles the physical servers. You can focus on the deployment system without worrying about the infrastructure. You don't need to manage the tasks like the physical server, the virtual machine, the scaling, or maintenance because the cloud provider automates them. AWS offers the framework called SAM, SAM, for building the serverless services. With SAM, you can easily build the serverless application. SAM uses the CloudFormation-based templates, so you can build a serverless application in much the same way as you would with the CloudFormation. But some templates are much simpler because it doesn't require the infrastructure layer. And this is a comparison between SAM template and the CloudFormation template for deploying the serverless application with Lambda, API Gateway, and DynamoDB. The CloudFormation template has over 200 lines of code, while the SAM template has only 23 lines. The SAM template is simpler and more abstract. When a SAM template is to deploy in CloudFormation, it's converted into CloudFormation template. The exam guide mentions the serverless application repository, SAR, but doesn't explicitly mention the serverless application model. Since the SAR is typically used in conjunction with the SAM, it will not be tested alone. And this topic is covered more in depth in the Developer Associate exam, so for the Solution Architect exam, it's enough to be familiar with the overview. AWS Proton is a service that automates the deployment of serverless and the container-based applications. While CloudFormation allows you to define any resource, Proton is specifically designed for modern applications. The Proton is built on the CloudFormation template. Resources are deployed using the template called the service template or environment template. And here is an example of environment template and the service template. The environment template on the left defines the VPC and subnet, while the service template on the right defines the EC2 instance. Amazon Elastic Beanstalk is a PaaS service that makes it easy to deploy infrastructure. With Elastic Beanstalk, you can automatically build an infrastructure simply by uploading your code. The tasks like capacity provisioning, load balancing, the scaling, and the monitoring are free managed by AWS. You can deploy the resources with the command line tools called the EBCLI. You can build a multiple environment for your application. For example, you can have separate deployment and production environment. When using Elastic Beanstalk, you can configure your environment by customizing the config file, and this is similar to the CloudFormation initialization file in the CloudFormation. And you can customize the Git repository, source files, environment variable by EB extensions. So I'm going to introduce the deployment option available in Elastic Beanstalk. The all at once is the simplest method. It deploys all the instances at the same time. The benefit is that deployment time is short, but if there is an error, the entire system goes down. The rolling deployment is a method that deploys on portion of the instances first. Once the initial deployment is succeeded, it then deploys on the remaining instances. The benefit is that the system doesn't completely stop during the process, but it will take longer compared to all at once. Rolling with additional batch is similar to the rolling deployment, but with an additional steps. It deploys on a portion of your existing instance first, then it will deploy new instances. This method takes more time since new instances are being created, but it minimizes the risk by not affecting the current instances until the new ones are verified. Immutable deployment creates new instances for the deployment. If the deployment is successful, it switches to the new instances and deletes the old ones. This method is easy to roll back if needed, and has a lower risk of failure. And finally, there is the blue-green deployment. It maintains existing system while creating a new environment. After the deployment, you can switch traffic to the new environment. This method is much safer because it allows for complete rollback if needed. So it is the most expensive way because of running two environments at once. Next, let me introduce the Elastic Beanstalk environment. In addition to the standard web server environment, Elastic Beanstalk also offers the worker environment, which are useful for asynchronous processing. The worker environment consists of an autoscaling group, an SQS queue, and a daemon that listens to the SQS queue and processes the task. The worker environment receives a task messages sent to the SQS queue from the web server environment and processes these tasks. The worker environment are particularly used for handling the time-consuming tasks. For example, the big data processing can be handled in the worker environment, thereby offloading on the web server environment. The Elastic Beanstalk is a PaaS service that simplifies the process of building the applications, while CloudFormation is an infrastructure as code IAC service that covers all AWS resources. Since Elastic Beanstalk and CloudFormation are designed for different purposes, even if they manage the same resource, the templates are very different. And here's a template for a simple web application. Elastic Beanstalk focusing on the application layer. The CloudFormation, on the other hand, that covers not only the application layer, but also the infrastructure layer. So finally, in this chapter, I'm going to introduce cost management tools. And firstly, AWS Budget is a budget management and usage monitoring service. With AWS Budget, you can set up alerts that notify you when your spending exceeds your budget threshold. You can also monitor your spending against your budget on the dashboard. The budget can be set for cost, usage, reservation, and saving plans. For example, you can create a budget based on the EC2 instance running hours and capacity. And you can also specify tags and resources to filter only the specific information. The next one is AWS Cost Explorer. The Cost Explorer allows you to visualize the cost and usage of your resources. While AWS Budget focuses on the budget, Cost Explorer focuses on the cost usage. The Cost Explorer offers the filtering, the visualization, and the cost forecasting capabilities. And you can filter by various categories such as resources, regions, accounts, and tags. And this makes it easy to see how much cost is being incurred by a particular account. And you can also forecast the future cost by including the future date. And the Cost Explorer also allows you to monitor the usage of reservation such as EC2 instance. And if you are going to use instances over a year, it's better for you to consider reservation options. AWS Cost Explorer will likely to be the most commonly used tools for managing AWS cost. For example, if you are working on AWS hands-on training, you can use Cost Explorer to track your spending. AWS Cost and Usage Report is a reporting service that compiles the detailed and extensive data on AWS cost. The report can be exported in the CSV format and provides a comprehensive summary of detailed items such as resources, accounts, and region. You can score the report in S3 bucket where they are organized by date. And you can use Amazon Athena to analyze the report. Amazon Athena is an analytical tool that is particularly useful for analyzing data stored in S3. And here's a sample of how to define a CSV report in Athena. You can also use S3 select to specify an object and extract data. Next, I will introduce saving plans. Saving plans are a type of pricing plan that offer a discount for committing to usage for 1 or 3 years. There are 3 types of plans available: the compute saving plans, EC2 instance saving plans, and the Amazon SageMaker saving plans. Amazon SageMaker is a machine learning service provided by AWS. You can receive a discount by selecting an upfront payment option. The larger the upfront payment, the greater the discount rate. EC2 instance saving plans offer a discount specifically for EC2 instance, and the compute saving plans provide a discount not only for EC2, but also for other compute services like Fargate and Lambda. The discount rate is higher with EC2 instance saving plans. However, these plans are limited to specific instance family and region. And if there is a possibility that your instance family or size might change in the future, it's better to choose the computing saving plans. And you can purchase saving plans from the Cost Explorer console. When buying the saving plans, you specify the plan type, the commitment period, the payment option, and the start date. For EC2, you also have the option to purchase the reserved instances. The differences between the saving plans and the reserved instances are summarized in this table. The saving plans are more flexible because you only need to specify the commitment period, the payment option, and the hourly usage to receive the discount. On the other hand, the reserved instances require you to specify the instance size, the availability zone, platform, and the tenancy. And if you have already purchased the reserved instance, it will be applied first, followed by the saving plans. This ensures that your existing reserved instances are fully utilized. And finally, I will introduce the tags. The tags are metadata used to identify and organize AWS resources. The metadata generally refer to the data about the data, such as attribute, the creation date, and so on. The metadata classify the resources but doesn't affect their functionality. The tags consist of the keys and values. In the cost management services we've discussed so far, you can filter by tags. And here is an example of common tagging patterns. Tags allow you to categorize AWS resources by department, the project, environment, and so on. For example, by tagging resources according to the company department, you can create a cost report for each department. And here are some tips regarding the AWS service names. Some AWS services start with Amazon, while others start with AWS. Although there are no strict rules, but in general, the naming trends to follow these pattern. The services start with the Amazon are often standalone services. For example, Amazon S3 is used for the direct storage services, and Amazon EC2 provides virtual machines. On the other hand, the services start with AWS often integrate with multiple services. For example, AWS IAM is used to manage the access to AWS resources and typically used in conjunction with other services. As of now, the list product on the official AWS website shows a 50% ratio of each. And for simplicity, I've abbreviated Amazon or AWS in this course. For example, I may refer to Amazon S3 simply as S3. Next, I'm going to introduce security, identity, and compliance services. In this chapter, I will introduce IAM, encryption services such as key management system, data security, authentication and authorization, network security, and compliance services. And first, let's talk about the IAM. The IAM is one of the most important services in AWS and appear frequently in exam. IAM, or Identity and Access Management, is a service that manages access permission for AWS resources and accounts that access them. With IAM, you can control fine-grained access, which enhances security across your AWS account. When you create an AWS account, a root user is created, but typically you sign in as IAM user. An IAM user has specific permission to perform certain action on specific resources. IAM also allows you to set permissions on resources as well as users. and this allows for security design such as the laws of least privilege. Let me introduce the element of IAM. The IAM consists of the components such as IAM policy, users, the groups, and the roles. I will explain each of these elements on the following pages. Now first, let's talk about IAM user. An IAM user is an identity defined in IAM. There are two authentication methods for IAM users, ID and password, and access key and secret key. The ID and password are used to log into the console, while key pairs are used to authenticate applications and APIs. To enhance security, you can enable MFA, the multi-factor authentication. While IDs and passwords are stored information, the key pairs are more vulnerable to exposure, so it's recommended to set up the additional layer of authentication. When storing the key pairs, follow the principle of the least privilege, avoid hard-coding key pairs, and instead use environment variables. And you should also restrict IP addresses for users who have access to key pair, rotate the key pair regularly, and periodically check the key pair usage. Next, an IAM group is a collection of IAM users. You can assign the permission to an IAM group, which then applies to all users in the group. And this approach simplifies access management and minimizes the risk of both the over-privileging and under-privileging. As your organization grows and the number of IAM users increases, the managing individual users can become time-consuming. It's recommended to organize IAM group according to the appropriate roles or teams. The root user is the account holder who signs in using the email address and password set up when the AWS account was created. Root users have very powerful privilege. Unless restricted by the SCP in AWS Organizations, the root user can perform any action on the AWS account. Therefore, it is generally recommended to delegate the privilege to the IAM user and sign in as an IAM user instead. Only the root user can perform specific tasks such as configuring the AWS account, managing the billing setting, and suspending the account. The privileges of the root user have been updated several times in the past. For example, as of now, the root user can delegate the support plan changes to an IAM user. And please refer to the official document for the latest update. An IAM policy is a set of rules that defines what actions are permitted on which resources. There are several ways to classify IAM policy. The one classification is based on the attachment target, identity-based policy, which are attached to entities like users and groups, and the resource-based policy, which are attached to directory to resources. Another classification is by customization method, inline policy and managed policy. Inline policy are directly embedded into an IAM entity, and it's used when you want to assign specific permission to a particular entity. When the entity is deleted, the inline policy is also deleted. And there are two types of managed policy: AWS managed policy, which are predefined by AWS, and the customer managed policy, which are customized by and created by users. In general, AWS managed policy are easier to manage and recommended over inline policy. The IAM policies are written in JSON format. The structure of IAM policy is outlined here. The current policy version is 2012 October 17. For reference, the previous version was released on October 17th, 2008. The current version allows for more functionality compared to the older one. The statement can contain multiple conditions. Since an IAM policy may define several permissions, there are often multiple blocks of curly bracket under the statement field. The SID is any identifier you choose. For example, in this policy, EC2 full access is used to identify the policy as one that allows all action on the EC2 instance. And for effect, you can specify allow or denied. And in action, you define the specific operation. Each resource has its own set of actions that can be described in detail. In this example, as the asterisk is used, the meaning any action is allowed. And conversely, if the effect is denied with an asterisk, it means all actions are denied. The resource field indicates the resource being acted upon. You can also add a specific condition under the condition field. The term ARN stands for the Amazon resource name, which uniquely identifies the AWS resource. The string equal is used to match a specific string, so in this case, it ensures only a particular IAM user can perform the actions. This JSON format is often appeared in the exam. Additionally, the policies for S3 packet and the KMS key can be written in JSON in similar manner. And you can set the detailed conditions with the condition field. The table here summarizes some common patterns. The string equal check if the strings are an exact match. For example, it can verify if the resource name or tag's name matches. The similar condition include the string like or not equals. The numeric equal check if the number exact match. The similar condition includes numeric not equal and numeric greater than. The bool represents the Boolean value and defines the binary condition of the either true or false. For example, a condition might be only valid when encrypted communication is enabled. The ARN equal check if the ARN matches, and the date equal checks if the date matches. In every exam, there will likely be a 2 or 3 questions that require you to read and understand the JSON of these policies. The IAM policy can be attached to resources as well as identity, and this is called the resource-based policies. I'd like to introduce a couple of patterns that are commonly used. When integrating the services, it is necessary to set the policy properly. If you forget to set the policy, you will encounter authorization errors, and the service will not be available. And this is especially common with the S3 bucket policy with CloudFront origin, and the execution policy for Lambda and SQS. Since Lambda and SQS are services that always work with other services, it's necessary to grant policy. In practice, the authorization or error often happen because policies are not properly configured, so it's important to keep them in mind. And here is a list of policies associated with IAM. In addition to the identity-based policy, the resource-based policy, there are also permission boundary, the SCP, and the session policy set in AWS STS. And you can define these policies in JSON format as well as IAM policy. Now, I will introduce cross-account setting. The image shows an example of executing an action from the application on the EC2 instances to an S3 bucket. On the left side is the cross-account setup, and on the right side is the single account setup. In the scenario, the identity executing the action and the resource receiving the action in a separate account. In such case, the only actions that are allowed by both the identities policy and the resource policy are valid. This means that the policies must satisfy the AND condition. In this example, only the getObject action is valid. In contrast, for a single account, any actions allowed by either the identities policy or the resources policy are valid, which follows the OR conditions. In a cross-account setup, if you want to allow a specific action, you must explicitly allow in both identities and the resource policy, and conversely, for a single account, if you want to deny specific action, you must explicitly state deny. And next, I will introduce the permission boundaries. The permission boundary is a policy that is added on the top of the existing policy to apply further limit. In this image, the yellow area represents the policy, and the blue area represents the permission boundary. As a result, only the permission within the overlapping the green area are allowed. The permission boundaries are useful when you want to limit the action of the particular IAM user. In this example, by adding the permission boundary that allows or denies a specific action to IAM identity with the administrator right, only these actions specified in the boundary will be allowed. The permission boundaries are applied to IAM identities to ensure they only have the minimum necessary permission, which is important for the governance and security. The permission boundaries are applied to individual IAM user and are roles to limit their permissions. The permission boundaries in IAM and SCP in the AWS organization are quite similar. The SCPs are used in the organization hierarchy to limit the sum of the permission inherited from the parent level. For example, the parent level may allow launching all EC2 instances, but the child level might not be able to launch certain EC2 instances. The JSON format works the same way. Next, I will introduce the switching roles. A switch role allows an IAM user to switch from one IAM role to another. A single IAM identity can take on the multiple roles to perform various tasks. And you can also set up the cross-account switch roles, where an IAM user in one account can assume an IAM role in another account. To grant a role from another account, the user requests authorization, and the other account grants the necessary permission, and once granted, the user can access the resources of the other account based on the assigned permissions. Next, I'll introduce AWS STS. The STS, the Security Token Service, is a service that provides a temporary access to AWS resources. While IAM grants to permanent credential, STS issues temporary credential with the expiration time ranging from a few minutes to several hours. And once the credential expires, the access is no longer available. For security reasons, these credentials are dynamically generated and not stored with the user. The temporary credential, like access keys, secret access key, and session tokens, can be obtained through the assume role action in AWS STS using IAM roles. When providing the access to the external users, manually creating IAM users and assign the policy to each one, increases the operational overhead. Moreover, the granting of long-term permission to temporary users poses a security risk. A session and access data can be stored in service like DynamoDB, and when a request for credential is made from a role, the STS issues and grants the temporary credentials. And I will explain the temporary authentication using STS between different accounts. In this example, account A is trying to access a resource in account B, and this is a command to get a temporary credential, and here assume the role named my role. And this will return a response here. The credential field contains the temporary access key ID and the secret access key and session token. And with the credentials, account A can access the resource. And you can also set an expiration time for the credential. And once the expired, the credential will no longer be available. The IAM roles are created to be assumed by a user, a service, or AWS account. In this example, if a user in account A wants to access a resource in the account B, the role is created in account B. The trust policy for the role specifies account A, allowing the user in account A to assume the role. Although the role existing in the account B, it is assumed by the user in account A. And when accessing the resources in account B from account A, includes a temporary credential obtained earlier in the CLI environment variables. Next, let's talk about the confused deputy problem as an example of complicated permission issue. A confused deputy problem is a security issue where an entity without permission to get another entity with higher privilege to perform an action on their behalf. For example, the account A has an IAM role called the example role, which it shares with an IAM user from a corporation. The company's IAM user assumes the example role and access account A's resources. And however, another user from account B somehow assumes the same example role and gets account A's resources accessed on their behalf. And this is the confused deputy problem. Now I will explain how to avoid or minimize the impact of a confused deputy problem. And first, follow the principle of the least privilege by allowing only the minimum necessary actions for the minimum necessary account. And this reduces the impact if a proxy problem occurs. And you can also reduce the potential risk by setting access expiration in STS. And additionally, by using an external ID when granting an IAM role, you can prevent unauthorized third parties from assuming the role without knowing the external ID. On the next page, I will show you a specific example of how to implement this workaround using the external IDs. When setting up the example role, set the external ID in the condition field, and provide the example role from account A to corporation. The corporation's user will include the external ID when sending an access request. Only when this external ID matches access will be granted. If another account that doesn't know the external ID accesses the account A, the request will be denied because the external ID does not match it. And this external ID acts like a password. I will show you how to implement it from the next page. And first, create an example role on account A, and here is a sample example role. And this trust policy allows the assume role request from the corporations. And this permission is only granted if the external ID matches the 1, 2, 3, 4, 5, the condition that the string equals external ID 1, 2, 3, 4, 5 is included in the condition field. When the corporation user access account A, they use a command like this to assume this role to obtain temporary credential. And with this command, the corporation user assumes the example role and obtain the temporary credential to access account A's resources. The external ID is set at the end of the command. And it is important and commonly used technique to put the external ID in the condition field to restrict the access. Next, I'll introduce IAM Access Analyzer. The Access Analyzer is a tool that helps validate trust relationships and policies for external resources. It checks whether any permission set in the policy allow access to external entities. And this tool can validate resources like S3 bucket, IAM roles, KM's key, and Lambda functions. And here is an example of S3 bucket policy flagged by IAM Access Analyzer. The policy allows any user to read the object in the S3 bucket by having an asterisk in the principal field. IAM Access Analyzer will alert you about the bucket with such a policy. In addition to this, IAM Access Analyzer can verify whether IAM policies are properly written and follow the AWS best practices. It can also generate the suitable IAM policies based on the access activity recorded in AWS CloudTrail logs. And lastly, I will introduce the policy evaluation logic. And with this, you can review the various policies in a unified manner. As explained earlier, there are different types of policies. The policies also include the explicit and the implicit permission, which help determine the final effective actions. If there is an explicit deny, the action will be denied. If SCP, the service control policy, is in place, and there is a no allow specified, the action will be implicitly denied. Following this process, evaluate whether a resource-based policy and identity-based policy, and whether a permission boundary is defined, and whether there is a session policy in place. All of these factors are considered in the overall policy evaluations. Next, I'm going to introduce encryption services. In this chapter, I will introduce the encryption tools KMS, the Cloud HSM, and Secret Manager for encryption against the data at rest, and the Certificate Manager for the managing encryption against the data in transit. And firstly, I'm going to introduce the encryption in the cloud environment. In the cloud environment, where the sensitive data are stored online, the encryption is an important measure for protecting the data from malware and ransomware. The encryption is the process of converting the digital data into a string of the character unreadable by unauthorized user. Since the cloud is online, it's necessary to encrypt both the data at rest and the data in transit. Encryption is the process of transforming the plain text into an unreadable cipher. It uses the cryptographic keys and algorithms. The converted data can be reverted to its original form using the decryption key, a process known as reversible encryption. In contrast, irreversible encryption is known as hashing. It generates a hash value that cannot be reversed. The hashing is commonly used in the digital signature. There are a symmetric encryption and an asymmetric encryption method. The symmetric encryption is the method where the same key encrypts and decrypts the data. This method is fast and efficient for encrypting the large amount of data. However, there is a security risk to share the keys between the sender and the recipient. Asymmetric encryption, or also known as the public key encryption, involves two keys, a public key for encryption and a private key for decryption. The public key is shared between the sender and the recipient. However, only the owner of the private key can decrypt the data. The hybrid encryption combines the strengths for both symmetric and asymmetric encryptions. The recipients share the public key in advance. The sender encrypts the data using the symmetric key. In addition to the encrypted data, the symmetric key is encrypted using the recipient's public key. The sender sends both encrypted data and encrypts the common key. The recipient decrypts the common key first, and the recipient then uses the decrypted symmetric key to decrypt the encrypted data. The history of the cryptography is very long, with advancement in the computing science. It is important to use the latest and most secure way of encryptions. AWS offers secure method compliant with the standard like FIPS. So let me introduce AWS KMS. The KMS Key Management Service is a service that helps you create and manage the cryptographic keys. It supports the creation and management of HMAC keys, symmetric key and asymmetric keys. And you can control access to these keys using the key policy and the IAM policy. With KMS, you can manage the entire key lifecycle from creation to deletion all in one place. And the KMS also offers automatic key rotations, which reduces the security risk of using the same key for an extended period. KMS has key rotation feature. It recommends to rotate the key regularly, as using the same key for a long time increases the risk of exposure. And by default, key material is rotated at once a year. Even after rotation, the old key material is retained, so any data encrypted with the old key can still be decrypted. The properties like IDs, ARN, and policy remain unchanged. And if you need to rotate the key more frequently, you can manually generate new key material to encrypt the data. And here I will explain the keys and the key materials. A key is a logical entity for data encryption and digital signature. It's associated with the metadata such as the unique key ID, ARN, the creation date, and the description. And the key material, on the other hand, refers to the binary representation of the encryption key itself. The key material is actually used for the encryption and the decryption. When importing the external key material into KMS, The user is responsible for the generating and backing up the key materials. KMS doesn't support the backup or rotation of external keys. And let me explain the life cycle of the key. A key's life cycle refers to the serial of the event from the creation to deletion. The customer master keys, CMKs, can be activated, deactivated, and deleted. And once a key is deleted completely, it cannot be recovered forever. Keys should not be immediately deleted. Instead, they are first logically deleted and then physically deleted after a waiting period of 7 to 30 days. And during this period, you can reactivate the key if needed. Logical deletions mean the keys appear to be deleted, but the data still exists. And during the waiting period before the physical deletion, any use of the key can be tracked through CloudWatch and CloudTrail, allowing you to detect compromises. And it's best practice to deactivate the key before deleting, rather than deleting them immediately. The KMS supports BYOK, the Bring Your Own Key, which allows you to import external keys into KMS. But BYOK has some limitations. It doesn't support automatic key rotation, so you need to manually regenerate the keys when necessary. Additionally, you must back up your keys, as automatic recovery is not available in case of failure. The BYOK also does not support logical deletions. The keys are deleted immediately upon expiration. And here is the procedure for importing the BYOK. The first download the public key from the KMS, then encrypt your key material using that public key, and upload the encrypted key material to AWS. The KMS allows you to control access to your CMKs by setting key policies. A key policy is a resource-based policy that defines permissions for who can access and manage the key. The key policies are written in JSON format, as shown here. In this example, the action field has an asterisk after KMS, which means which allow all the possible cooperation on KMS. And by specifying the action in your key policy, you can limit the scope to privileges. On the left side is the example of actions for key administrator. The administrator can manage the tasks like key rotation, key creation, activation, deactivation, deletion, and scheduling. On the right side is the example of key user actions. Key user can perform the tasks such as encrypting, decrypting, and generating data keys using the KMS. The KMS supports encryption for many AWS services, and the encryption method differ depending on the services. Then I will explain a few common examples. The AWS System Manager's parameter store is used to centrally manage the system parameter and access keys. It stores the various strings, both sensitive and non-sensitive ones. And by default, AWS managed KMS keys can be used for encryptions. And the AWS Secret Manager is a service for sensitive information such as password. The secrets are encrypted with a KMS key. The encryption is also supported for the database services with different services using the different encryption method. It supports encryption by cluster, the table, and the data itself. and EBS and S3 also support encryption. In particular, S3 offers both server-side and client-side encryption options. And I will introduce S3's encryption in more detail in the storage chapter. And finally, I will explain the pricing. There are two types of the CMKs, the customer-managed CMKs and the AWS-managed CMKs. For customer-managed CMKs, there are charges for key storage and the number of the request. And for AWS-managed CMK, there is no storage charges. And let me explain the differences between Cloud HSM and the KMS. The Cloud HSM is a hardware security module using a physical hardware with anti-tampering features. It's primarily used for the compliance purposes. And the KMS is a free managed key management service that integrates with many services. It offers a fine-grained control over key management, and you can also upload the pre-encrypted data to AWS using the customer-managed keys. Next, I will introduce the AWS Secret Manager. A Secret Manager is a centralized service that manages the lifecycle of secrets such as database credential and the password. It supports the periodic secret rotation, which is handled by Lambda functions. It recommends not to embed the password directly in the application, but to store them in the Secret Manager. Updating the password within the application may require code changes, which can affect operations. And here I will explain the differences between the Secret Manager and the System Manager, the parameter store. The parameter store is used to store a wide range of strings, including the system parameter and secret, and it's free to use. It also integrates with the many AWS services. On the other hand, the Secret Manager has the automatic rotation feature, and it is designed for the securely managing the secret. And these topics often appeared in the exam test, so please make sure to learn the different use cases. Next, I will introduce AWS Certificate Manager, or simply ACM. The ACM supports encryption for data in transit. It's a service that helps to create and store and update the certificates. And you can import and register the certificates for CloudFront, Elastic Load Balancer, and the API Gateway. The CloudFront is a CDN service, and the Elastic Load Balancer is a load balancer. Now I will explain these services in the networking chapter, and API Gateway will be introduced in the application integration chapter. The ACM acts as the private certification authority, which is capable of issuing the certificate. Since ACM is a private CA, if you need a certificate from the public authority, you will need to get one issued by external certification authority. And however, you can still store and manage the certificate issued by external CAs in ACM. While KMS is a service for encrypting the data at rest, ACM is used for encrypting the data in transit. And this is the scope of ACM encryption. The image shows a certificate is installed on the ELB. By deploying the certificates on the ELB, the ACM can encrypt the communication between the client and the ELB using the SSL encryption. The ACM does not encrypt the communication to the backend server. And if you want to encrypt the communication from the ELB to the backend server, you will need to install a certificate on the backend as well. The ACM provides the domain validated certificate. The domain validation confirms the certificate authority has validated that the certificate applicant has administrative control over the domain. The domain validated certificates are less expensive, but do not verify the extent of the organizations. And if you need the organizational validation or extended validation, you will need to obtain them from the third-party provider. And you can import the certificate issued by external provider into ACM. However, ACM doesn't support automatic rotation for external certificates, so you will need to rotate them manually. Next, I'm going to introduce data security services. The Amazon Macie detects the sensitive information in data stored in S3 bucket. It uses a machine learning technique to identify the pattern in sensitive information. And you can easily enable Amazon Macie through your console, and once activated, it continuously monitors your data. The data detected by the Macie can be encrypted with KMS, and you can trigger a CloudWatch event as a detection. The Macie is capable of detecting the personal health information and the personally identifiable information PII, and it also helps you comply with the regulations such as GDPR, PCI DSS, and the HIPAA. And I will explain how to comply with PCI DSS. The Amazon Macie can detect the sensitive credit card data, but it cannot encrypt or mask data by itself. In other words, Amazon Macie itself is not PCI DSS compliant. To achieve PCI DSS compliance, you need to encrypt your S3 bucket to mask the credit card information. The Amazon Guard Duty is a service that analyzes the storage and logging services to detect the potential threat. It supports logs such as CloudTrail, S3, VPC flow logs, and the DNS query logs. Like Amazon Macie, you can enable it directly from the console. Detected threats can be linked to the CloudWatch event and integrated with the event bridge to trigger necessary actions. The Amazon's Guard Duty threat detection includes the identifying the compromised credential from S3, unusual data access patterns, and suspicious logins, and the malicious API calls. When used together with Amazon Detective, it can analyze the security event with the context metadata and the resource information to help identify the root cause. The Guard Duty can also scan EBS for suspicious malware behavior. It integrates with Security Hub and Event Bridge to send threat information to operational tools for further actions. And finally, let me introduce to the Amazon Detective. The Amazon Detective is a service that automatically collects logs data from various AWS services and uses machine learning technique and statistical analysis to investigate potential security issues. It integrates with the Guard Duty, Security Hub, CloudTrail logs, and VPC flow logs. The use cases include when a user accesses your system from the unusual IP address through the Guard Duty, and when multiple abnormal EC2 instances are launched, and an increase in failed API calls. The pricing for Amazon Detective is based on the amount of logs data it captures from the CloudTrail, VPC flow log, a guard duty, and other sources. Next, I'm going to introduce authentication and authorizations. Firstly, I'm going to introduce the authentication and the authorization, which are two essential security processes. The authentication is the process of confirming the identity, who you are, often done through the things like knowledge factor, the possession factor, and the inherence factor. The authorizations occur after authentication, and it's a process of giving the permissions to access resources. The Amazon Cognito is a service that provides a secure user authentication and user management for web and mobile applications. It supports sign up and sign in capability, identity storage, and identity federations. The identity storage allows you to manage user and authentication information, which is done through a feature called the user pool in Cognito. The identity federation refers to the ability to authenticate and grant access to AWS resources using the external social identity provider. The image shows a typical authentication and authorization process using the identity provider, IDP, and the service provider, SP. The client sends an access request to the service provider, and the service provider redirects the users to the identity provider. The user provides the authentication details such as a user ID and password to the IDP. And at this point, you can add additional authentication like the multi-factor authentication. And if authentication is successful, the IDP generates the assertion, which includes the details about the client's privileges. The assertion is provided by the form of Samuel or OpenID Connect. The IDP sends the assertion to the service provider, and the client is redirected to the service provider. The service provider verifies the assertion and grants the client access. The authentication and authorization flow involves the technical details, while these are not covered in the associate level exam, but I believe it's important to understand from the practical standpoint, so I will include it. And let me explain some common use cases for Amazon Cognito. The Cognito provides both authentication and authorization capabilities. You can issue the authentication tokens using the Cognito user pools. And the Cognito identity pools can be used to grant access to necessary resources by specifying the authorization rules. Additionally, the Cognito can integrate with third-party identity providers, IDPs. So let me explain the main element of the Amazon Cognito. The Cognito user pool acts as the directory service that manages the user IDs and password, and as identity provider that issues the user credential. It supports the sign up and sign in using usernames and password, along with the common authentication features like password recovery and token-based authentication. And you can also trigger AWS Lambda function during the sign up and sign in event. For example, user attributes from the user pool can be passed to the Lambda function, and event logs can be stored in S3. The Cognito identity pool is responsible for granting the authorization to AWS resources. The user pool handles the authentication, while the identity pool handles the authorization. While you can use IAM and STS for temporary credential, if you want to handle the both authentication and authorization entirely with Cognito, you use the Cognito identity pools. Additionally, the Cognito can integrate with the third-party identity providers like Facebook, Google, and Amazon. And this is a process for authentication and application and API using the user pool. The client attempts to connect to the application, and at this point, a sign-in request is made to the Cognito user pool. The client is then redirected to the IDP. The IDP can be third-party director services. And if needed, additional authentication is performed by user pool. The authentication response is returned from the client. Once the authentication is complete, the client can sign into the application using a token or exchange data with the API. And let me explain the setup of the Cognito user pool and a simple authentication process. You can create the Cognito user pool from the management console. When the user pool is created, a user pool ID is generated, which is then set as the environment variable in your authentication code. And this is the JavaScript user authentication code. The onSuccess function handles the process for successful authentication. When onSuccess is called, the JWT token is obtained for accesses. The JWT token is issued when the user logs in for the first time, and it is automatically attached to the subsequent request. And if authentication fails, the onFailure function is called. Next, this is the authorization process using the Cognito identity pools. The identity pool assigns the AWS credential to the client. And first, during the authentication process, the client or application is authenticated. And this can be done using a third-party IDP or the Cognito user pool. Next, a request for authorization token and a request to the AWS STS for a role. The AWS STS is a service that provides temporary credentials. And finally, the credentials are issued from the Cognito identity pool, allowing the client to access AWS resources. When using both the Cognito user pool and the Cognito identity pool together, authentication is handled by the user pool, and the authorization is handled by the identity pool. And let me explain the configuration of the Cognito identity pool. You can create the identity from the management console too. Next, configure the IDP settings. And you can use the Cognito user pool ID as your IDP or choose a third-party IDP. And after that, specify the identity pool ID. In the login object, provide a token to authenticate the federated user and enter the Cognito user pool ID. And if the authentication is successful, the user will be able to access the AWS resources. Now, define the required actions for the AWS resource. And here is another feature Cognito offers, token-based authentications. With token-based authentications, the user provides a username and password when signing in for the first time. Once the authentication server verifies the user's identity, it issues a unique authentication token. The user then uses this token for access, which is typically included in the HTTP request header. For enhanced security, you can configure a password policy or enable multi-factor authentication (MFA). The Cognito also supports password changes in case of a forgotten password, as well as the verification of email address and phone number. Additionally, the Cognito can block users if their passwords have been compromised on other websites. Let me explain the Samuel. The Samuel is an XML-based open standard used for authentication and authorization across different domains, primarily for single sign-on. The Samuel consists of the following elements: the assertion, the protocol, and the bindings. Assertions are XML formatted documents that contain authentication and authorization information, and the protocol defines how to request Samuel response and assertions, while bindings specify how Samuel protocol messages are transmitted. A common use case is when a user authenticates on the enterprise internal network identity provider and uses those credentials to log into the external cloud service provider through the SSO. For example, if an enterprise uses AWS, it can send authentication information from its internal Active Directory to AWS as a Samuel assertion, allowing the user to log into the AWS Management Console with single sign-on. The AWS supports single sign-on through a service called AWS Identity Center, which I will discuss later. And for now, please remember the terms identity provider and service provider. Next, I will introduce directory services. The directory services are systems that centrally manage and control access to a company's IT resources. Among them, the Microsoft Active Directory is widely regarded as the industry standard, and you can deploy Active Directory not only on premises but also in Azure, the cloud service by Microsoft. The Active Directory offers the following functions: the authentication and authorization, directory services, the policy management, and support for LDAP and the Kerberos authentication. Starting on the next page, I will introduce the directory services available on the AWS. The services related to the directory service include the AD connector, the simple AD, and the AWS managed Microsoft AD. The AD connector is a directory gateway that redirects the directory to request from the AWS IAM to your on-premise Active Directory. It is installed within your AWS vPC. A simple AD is a managed directory service that uses the Samba for Active Directory. It allows you to set up the new Active Directory within AWS. AWS managed Microsoft AD also lets you set up the Active Directory in the AWS, but it is designed for the larger environment supporting more than the 5,000 users. If you need the full functionality of the Active Directory, the managed AD is the recommended options. And this is a table that summarizes the 3 directory services. Again, the AD connector is a gateway services that connects to an existing on-premise Active Directory. The simple AD is a directory services suitable for smaller organizations. The AWS managed Microsoft AD provides the full-featured Active Directory in AWS. And this is the single sign-on flow using the ADFS, the Active Directory Federation Services. The flow allows the user to authenticate with Active Directory and use their credential to access AWS services. And first, the user connects to the authentication endpoint using the browser. The ADFS redirects the user to Active Directory, where Windows Active Directory authenticates the user. The necessary credential is sent to the user, and the user sends the credential to AWS Single Sign-On. And once the credentials are verified, the user is redirected to the AWS console. And at this point, the specific resources and the specific permissions are assigned based on the required access. And this is the image of the integration between AD connector and the managed Microsoft AD and the AD server. The AD connector acts as the authentication proxy to the on-premise Active Directory, querying it every time an authentication request is made. And this allows users to access the appropriate resources based on the credential in the on-premise Active Directory. The managed Microsoft AD enables two-way communication, allowing it to work in both directions. As a full-featured directory services, the managed Microsoft AD synchronizes the authentication information for both AWS and the on-premise environment. And for reference, let me introduce Microsoft Entra ID and Active Directory. The Microsoft Entra is a suite of services related by the Microsoft in 2022. And in 2023, the Azure Active Directory was renamed to Microsoft Entra ID. The Azure Active Directory is a service that provides Active Directory on Azure, the Microsoft Cloud Platform. The Microsoft Entra is a collection of products that integrates Microsoft Identity and Access Management. In addition to Microsoft Entra ID, it includes Entra Permission Management and Entra Verified ID. And for reference, Azure's services include both services prefixed with Azure and services prefixed with Microsoft. The services prefixed with the Microsoft are deployed by Microsoft, and the services with the prefixed with Azure are specific to Azure Cloud. According to the Microsoft official website, although the name has changed, most of the product features remain the same. Existing Azure AD's user can continue using the services without any changes. Azure AD has simply been integrated into the Entra ID and renamed. Let me explain the differences between Entra ID and the ADDF organizations. On the left, we have Entra ID in Azure, and on the right is the on-premise Active Directory Domain Service, ADDS. In Entra ID, the organizations are structured as tenants within the Azure environment. When you create an account in Azure, the single tenant is automatically created. And within the tenant, you can create the subscriptions and the resource group, and it's possible to have multiple tenants. And in ADDS, an organization is called Forest. Within the Forest, you can configure domains. The domains can have the parent and the child relationship, establishing the trust between each domain. The group of domain with the parent-child relationship is called a domain tree, as opposed to a forest. And let me explain how user information is synchronized from Entra ID to ADDS. After a user is created in Entra ID, their information can be synchronized to the domain services when they change their password. And this process generates the password hash required for Kerberos and NTLM authentication. As the synchronization is one way, meaning there is no reverse synchronization from ADDS to Entra ID. And this process is similar to the AWS AD connector. Additionally, the synchronization from ADDS to Entra ID is possible using a feature called Entra Connect. And this synchronization includes the user account, the group, membership, and the hash value needed for credential. The Microsoft products are not in the scope of AWS exam, but I have included them because of their practical importance. Next, I will talk about the single sign-on. The AWS IAM Identity Center is a service that provides a single sign-on for the AWS, and it replaced the service called the AWS SSO in 2022. It centralizes the account management within the AWS Organizations and enables single sign-on access. And this includes the identity store, allowing you to manage the multiple identity in one place. It can also integrate with the third-party identity source such as Active Directory, the Microsoft Entra ID, and the Okta. The SSO integrated with the Cognito and STS, and you can use IAM Identity Center in conjunction with other services as well. Let me introduce the integration between ADFS and the AWS IAM Identity Center. It has Samuel compatibility, so you don't need to do any additional coding. And you can map Active Directory security groups to IAM roles, linking information from both streams. By using existing services like directory services and Samuel, you can minimize the need for deployment overhead. Next, I'm gonna introduce network security. First, let me provide an overview of the AWS Firewall services. A firewall is a service that provides a network control to protect the system's security. The AWS offers the services that correspond to both the application layer and the network layer of the OSI reference model. The network layer's firewall includes the network ACL, which controls the traffic at the subnet level within the VPC, and the security group, which controls traffic at the resource level. Since network ACLs and the security groups are associated with VPC, so I will cover them in the network chapter. The firewall that operates at the application layer is AWS WAF. The WAF is designed to protect the web application by monitoring and controlling HTTP and HTTPS traffic. And the Route 53 Resolver DNS firewall operates mainly at the application layer and is used to prevent the access to inappropriate sites by controlling the DNS query response. The Route 53 is a DNS service, and which I will introduce in the network chapter as well. The AWS Network Firewall operates at both application and the network layers. It controls traffic at the session and packet level and provides a domain and URL level control. And it includes the intrusion detections and the prevention system, IDS and IPS. And the AWS Shield protects the resources from the DDoS attacks by and mainly operate at the network and the transport layer. AWS Firewall Manager centrally manages all these firewall services. Another way to classify firewall is as stateful and stateless firewall. The stateful firewall keeps track of the state of previous connections and automatically allow packets that belong to previously allowed traffic. And this allows the firewall to maintain context for the traffic, and where the context refers to the session state and the previous traffic patterns. The stateful firewall provides more advanced future traffic filtering based on the context. And the stateless firewall, on the other hand, evaluates each packet individually without considering the previous state or sessions. They apply predefined allow or deny rules to each packet, such as rules based on the IP address or protocol. Because they do not track traffic context, stateless firewalls are generally faster. And in terms of AWS services, the security groups and the WAFs are classified as the stateful firewall, while network ACL are classified as the stateless firewall. The AWS network firewall supports both stateless and stateful rules. AWS WAF is a web application firewall. It protects the web applications from common web-based attacks. The WAF monitors the HTTP and HTTPS traffic and allows or blocks it based on the rules. And it also tracks the allows and blocks the traffic. The WAF recognizes the common attack patterns, so you can easily start using the services by attaching it to your resources. And you can also set up custom rules. And these are the elements monitored by WAF. Since WAF operates at the application level, it controls traffic based on the HTTP request, and it supports the detection of common attack patterns, the HTTP header, and the IP addresses, request size, and the request pattern, and the rate-based control, and geo-blocking. And for reference, the SQL injection is a technique where the malicious SQL code is inserted to manipulate data from the web application. And the cross-site scripting, XSS, is another technique that forces user to execute malicious script. AWS WAF has a default set of rules based on the common attack patterns, including the baseline rules, the IP evaluation rules, and the bot control rules. The baseline rules protect against the common threats such as the vulnerability listed by OWASP, SQL injection, and the OS-level security risk. The IP evaluation rules protect against the IP addresses identified by the Amazon as bot, and the bot control rules block the resources from the bot. Since AWS WAF is a managed firewall, you can easily attach it to your resources and control traffic. AWS Network Firewall is a VPC-based stateful network firewall, and you can also create a stateless rules for it. It's free managed and automatically scaled based on the traffic volume. It also supports high availability by deploying the endpoints across the multiple AZ. And you can set the customized rules that cannot be set with security groups and the network ACL. And by creating a network firewall, you add an extra layer of security. For example, you can block access to unauthorized domain using the domain list, block malicious IP addresses, and perform the signature-based threat detections. And this is a simple network diagram for multi-AZ setup with network firewall. The network firewall is associated with the subnet, and this subnet is dedicated to the network firewall endpoint. By configuring the ingress rule of the internet gateway to route traffic to the network firewall endpoint, you can ensure that all incoming traffic passes through the network firewall. The traffic coming through the internet gateway is then routed through the network firewall before reaching the public subnet where the EC2 instance is located. A network firewall supports both stateless and stateful rules. And first, the traffic is evaluated based on the priority of the stateless rules set by the user. And depending on these stateless rules, the traffic is either allowed, denied, or forwarded to evaluated by the stateful rules. And next, the traffic is evaluated by the stateful rules based on these rules. The firewall either allows, denies, and triggers an alert. The logs generated from these actions can be sent to CloudWatch logs, S3, or Kinesis data firewalls. A denial service is an attack method that disrupts the system by sending a lot of traffic. And in a DDoS attack, a large number of compromised devices, which is called as a botnet, attempt to send a lot of traffic to the target. The AWS Shield is a service that protects AWS resources from DDoS attacks. Since the packets themselves are correct and legitimate, they cannot be blocked by standard firewall, so it requires specialized protection measures. The AWS Shield comes in two versions, the free standard version and the PET advanced version. The standard is automatically enabled for services like ELB, CloudFront, and Route 53. And the advanced version includes the features listed here and offers more secure protections. And with advanced version, you also get access to specialized technical support 24/7. AWS Firewall Manager is a service that centrally manages the firewall across the multiple accounts. The Firewall Manager supports WAF, AWS Shield Advanced, the VPC security groups, Network Firewall, Route 53's DNS Firewall, and even the third-party firewalls. It allows you to manage multiple accounts and resources from one place. When using Firewall Manager, you need to be part of AWS Organization and have AWS Config enabled. Since it works with AWS Config, it can also detect compliance with config rules. And so far, I have introduced network security, but later in the network chapter, I will cover VPCs and the security group in more detail. Let me explain AWS Audit Manager. The Audit Manager is a service that automates compliance audits for AWS resources. It helps prepare for internal and regulatory audit while reducing the compliance risks. The service provides continuous monitoring, assessment, and reporting to address complex compliance requirements. The main features of Audit Manager are as follows. It automates data collection, reducing the need for manual tasks and improving audit efficiency. The pre-built audit frameworks are aligned with common industrial standards, save you the overhead of making framework. It continuously monitors your resources and assesses the impact on compliance. And Audit Manager also supports the generation of detailed compliance reports. The Audit Manager can be enabled from the Management Console. You select the framework and work with the AWS Config the Security Hub, and other services. And you can also delegate the other AWS accounts to review and approve the assessment result. And this process results in a final report. The AWS Config is a service that continuously monitors AWS resources. It allows you to set up the config rule to alert you about the resources that deviate from these rules and take necessary actions. And Audit Manager is designed for auditing, evaluation, and reporting. And this is just for your reference, and here is a summary of industry standard. You don't need to memorize all the detail, but these maybe appear in the exam, so you recommend at least remembering the names. AWS Artifact is a service for managing security and compliance documents and agreements. The AWS Artifact has two components, the Artifact Agreement and the Artifact Report, and both are accessible from the console, and the AWS Artifact itself is free of charge. The Artifact Agreement allows you to manage the agreement within your AWS account. There are account agreements for individual agreement and the organization agreement for the organizational level agreement. The Artifact Report provides the compliance audit report, and these reports can be used to evaluate whether an organization meets compliance standard and also support third parties assessment. And these are examples of agreement that can be referenced in the Artifact Agreement. And this is not directly asked on the exam test, so just for reference. And next here are the reports that can be referenced in the Artifact Report. Although these are not directly included in the exam, but I have included them because it is good to know about the PCI DSS and the ISO and IEC as a general knowledge about information security. Next, let me introduce to the Amazon Inspector. The Amazon Inspector is a security assessment service. It scans for the software vulnerability and network exposures. With Amazon Inspector, you create an assessment template and configure your assessment target and rules. The assessment target refers to the resources that will be evaluated by Amazon Inspector, and you can assess all instances in specified region or specify the managed target using tags. A rule package is a collection of predefined evaluation criteria, which I will explain on the next page. The assessment schedule defines how frequently assessments are conducted. The rule package includes a network reachability assessment and a host assessment that checks for the vulnerability in EC2 instance. The network reachability assessment evaluates the network configuration to determine if resources are reachable. The host assessment checks for vulnerability in EC2 instances. To run the host assessment rule package, you need to install the Amazon Inspector agent. The agent sends the data to Amazon Inspector, which then evaluates the information against the rule package. The rules being evaluated are listed here. These include the common evaluation criteria such as CIS, CVE, as well as AWS security best practices. The Amazon Inspector and the AWS Systems Manager can be used together to automate the entire process from the vulnerability detection to patch applications. The Inspector agent is pre-installed on the monitored EC2 instance, and when the agent detects a vulnerability, it alerts Amazon Inspector, and this triggers a Lambda function to execute, and the run command performs the necessary actions. Then I will introduce AWS Security Hub. The AWS Security Hub is a service that automates security assessment and alerts for AWS resources. It provides a centralized view of security and compliance status. It enables compliance checks with common compliance requirements and the AWS security best practices. The Security Hub works with more than 30 AWS services, including the Guard Duty, Amazon Inspector, Amazon Meshi, and third party, as well as security service to perform security checks. And you can centrally manage your security information in the Security Hub. And these are the steps for setting up the Security Hub. To use Security Hub, you need to enable AWS Config. The result from the config rules will be aggregated into the Security Hub. And next, enable Security Hub and configure the settings. A Security Hub allows you to manage resources based on AWS security best practices and the CIS guidelines for using AWS issued by the US and the PCI DSS rules. A Security Hub can aggregate the findings from multiple regions. And it also supports multi-account usage. And you are aggregating the findings across the multiple accounts. It's recommended to use it with AWS Organizations, or you can manually invite accounts. And here I will introduce a solution for security operating in the public cloud environment. The CNAPP stands for the Cloud Native Application Protection Platform, and is an integrated concept for cybersecurity protection in public cloud environment. And this includes the CSPM, the Cloud Security Posture Management, which helps prevent the cloud configuration errors, and the CWPP, the Cloud Workload Protection Platform, which monitor and protect the multiple cloud services centrally. The AWS Security Hub functions as the CSPM service. It checks whether AWS resources comply with best practices. And finally, here is a summary of compliance services. And once again, please review the scope and the services and objective covered by each. The Amazon Inspector primarily assesses the application issues and the vulnerabilities. The AWS Artifact generates compliance reports. AWS Security Hub is dedicated to security, centralizing the security information and detecting the potential security issues. And AWS Audit Manager covers all services, and its purpose is to generate audit reports. Next, I'm going to introduce storage services. In this chapter, I will introduce the S3 for object storage and the storage gateway, the block storage for compute services, and the file storage and the disaster recovery. And firstly, I will introduce S3. The object storage is used for storing data as object. It's also known as blobs. And each object typically includes the data itself, the metadata, and the unique identifier. The object storage systems allows you to retrieve an object via HTTP and HTTPS, which is used for web-based content. The object storage is highly scalable and used for many use cases, including archiving, backing up, and storing a large amount of static data like images, audio, and video file and document. The AWS Amazon S3 is offered. The block storage is an architecture that divides data into blocks, and each with a unique identifier. And these blocks work like individual hard devices. The block storage is used in storage area network where the data is stored in volumes, also called blocks. And it offers high performance and low latency, suitable for environments like databases where rapid read and write operations are necessary. In AWS, Amazon EBS is provided. And the file storage is a hierarchical storage used for organizing data files. It's used as a regular file system, the personal computers and the servers. And this is probably the storage type you are most familiar with, as it is the most widely adopted the consumer product. It can be shared among multiple clients using the standard protocols such as NFS or SMB. And in AWS, you can use Amazon EFS. The Amazon S3 is the most popular object storage. The S3 stands for Simple Storage Service. It offers high durability and unlimited capacity. Unlike EFS or EBS, you don't need to specify capacity in advance. You are charged based on how much the storage you use. The S3 offers redundancy by replicating the object across the multiple AZ, ensuring storing the data integrity. It also supports various data protection features such as versioning, MFA authentication, and encryptions. The S3 is used in the wide range of use cases. It's commonly used for backing up logs, the snapshot of AWS services. It's also used as a data lake for storing the structured and unstructured data, as well as for hosting static content. Then in S3, the container that holds the object is called a bucket, and the S3 Glacier, the container for storing archive, is called a vault. The S3 offers a variety of storage classes, and by default, the standard class is selected. The standard class is used for frequently accessed data. The standard IA is used for less frequently accessed data. The intelligent tiering automatically moves data to lower cost storage classes based on access patterns. The one zone IA stores data in a single AZ and is less expensive due to lower redundancy. All of these storage classes provide the 11.9 durability. However, the availability varies by storage classes. And be careful not to confuse availability with durability. The data stored in S3 is physically stored in AWS data centers. The high durability means that the data itself will not be lost, but availability refers to whether the data can be accessed at all times. And the standard IA and the one zone IA have minimum storage period. Even if you delete before this period ends, you will still be charged for the minimum storage duration. And for reference, the RRS, reduced redundancy storage, is no longer recommended, but may still appear as an option in certification exam. And the next is storage classes for the S3 Glacier. Archived data that is accessed even less frequently than S3 is stored in S3 Glacier. The instant retrieval is used for data accessed about once a quarter, and the flexible retrieval is for data accessed about once a year, and deep archive is for data accessed less than once a year. And the more frequently accessed data, the higher the storage cost. Conversely, the lower the access frequency, the lower the storage cost. But the retrieval fee increases and the retrieval time are longer. And all S3 Glacier storage classes have a minimum storage duration requirement. And you can set up lifecycle management based on the data access patterns. For example, you can automatically move less frequently accessed data to cheaper storage classes or delete it altogether. Currently, the lifecycle management can be applied across all storage classes. From here, I will introduce to the security features of S3. The security features by S3 include access control, signed URL, CORS, encryption, locking, and versioning. There are three main ways to control access in S3. The IAM policies are attached to IAM user or roles to manage access control. The bucket policy controls access at the bucket level. The bucket owner can set permissions for other accounts, and by specifying an object name in the resources attribute, it's also possible to control access at the object level. The ACL, the access control list, manages access at both the bucket and the object level. For account level control, the IAM policy are commonly used, and for bucket level control, the bucket policies are typically applied. On the other hand, ACLs are an older method of access control and lack fine-grained control options, so there is generally no need to use ACLs today. The ACLs can grant read, write, and list permission to object and the bucket. On the other hand, you cannot set fine-grained permissions for other actions. For example, ACL does not support conditional access control, such as allowing access only from the specific IP addresses. Therefore, it's common to use bucket policies and the IAM policy for authorization management instead of ACLs. And here's a sample bucket policy. The JSON format is the same as that used for IAM policy. For example, you can enforce encryption by adding a condition in the condition field. And this is an example of enforcing server-side encryptions. The next, assigned URL allows you to set an expiration time for access to an object, and access is only possible via the generated URL. Only those who have the URL can access the object. However, once the URL is leaked, the third parties may be able to access the object, so it doesn't provide a complete security. Therefore, the signed URL are typically used for sharing the file for downloading. You can also create a signed URL for uploading file, not just downloading. And this is a sample of signed URL, which includes the access key ID, the signature, and the expiration time. Additionally, you can restrict the access by HTTP method or a source IP addresses. Next, let me introduce CORS, the cross-origin resource sharing. The CORS refers to the sharing of resource between the different origins. If CORS is not enabled, you will encounter a blocked by CORS policy error. And this is an example of CORS configuration. In a web application, when the index file is on the domain 1 and the CSS file is on domain 2, you need to enable resources sharing between domain 1 and domain 2. With CORS, you can allow requests from the specified domain. And next, let's talk about the data encryptions. As mentioned in the KMS chapter, S3 supports encryption for data at rest. There are two types of encryption, and server-side and client-side encryption. With a server-side encryption, the data is encrypted by AWS after being uploaded to S3. And in contrast, the client-side encryption, the data is encrypted before uploading it to S3. For server-side encryption, there are three types: SSE-S3, SSE-KMS, and SSE-C. And SSE-S3 is enabled by default, and SSE-KMS uses the KMS for encryption and decryption. And with KMS, you can choose between AWS managed keys and the customer managed keys. And SSE-C allows you to use a key provisioned by client. In this case, the key is not located in the AWS, but client locations. Make sure to remember the differences types of the key, where they are stored, and who manages the key. And for client-side encryption, CSE, since the data is encrypted on the client side before the uploading for the S3, the AWS is not involved in the encryption and the decryption. Next, I will introduce object locking. You can lock the object in S3 to prevent them from being modified, making them the read-only file. You can set the retention period for the object lock. Once this period expired, the lock is automatically lifted. To use object locking, you must enable versioning, which I will explain later. There are two retention modes for object lock. The governance mode, which allows only specific IAM user to overwrite or delete object. The compliance mode, which prevents any changes from all users, including the root account. The compliance mode is ideal for log files used in the audit. Additionally, there is a feature called the legal hold, which protects the object for legal reasons. The legal hold operates independently of the object lock's retention period. And this means that if the retention period has expired, the object remains protected as long as the legal hold is enabled. And similarly, if the legal hold is disabled, but object lock is still active, the object remains protected. The object can only be overwritten or deleted once both the object lock and the legal hold are disabled. The legal hold is useful when the duration of protection is uncertain, such as during the external audit, where the end date is not yet known. And you can also set the bold locks in S3 Glacier in a similar way. So let me introduce the versioning. By enabling the versioning, you can retrieve previous versions of the object. In other words, even if you overwrite an object, you can still access its earlier versions. Additionally, when you delete an object, it's not permanently removed. Instead, a delete marker is created. And if you remove the delete marker, the previous version of the object will reappear as the latest version. To permanently delete an object, you need to specify its version ID when deleting it. And you can enable versioning on the bucket-by-bucket basis. In object storage, every object has a key and ID. When the versioning is enabled, a put object request or upload overrides the object with the same key. However, since each version has a different ID, you can refer to each as a separate object. Next, I will introduce S3's operations. And here I will introduce batch operation, the multi-part upload, the transfer acceleration, and S3 select. In the first three, I will introduce the basic S3's operations. The getObject operation is used to retrieve an object from S3. And you can execute the getObject by specifying the bucket, object, and the condition to retrieve the desired object. Additionally, you can use the list bucket to retrieve a list of objects in the bucket. You can also specify a prefix or a size to filter and retrieve a specific object. Next, I will introduce the batch operations. The batch operations allows you to perform actions on a large number of objects at once. For example, you can copy object, invoke Lambda functions, replace object tags, delete object, replace ACL, or manage object lock retentions. In batch operations, you can create a job and specify a detail such as the type of operation, the target S3 bucket, the manifest file, account, and the regions. The manifest file is used to specify the object that the operation will be applied to. Next, I will introduce the multi-part upload. The S3's multi-part upload is a feature that allows you to efficiently upload a large object. It works by dividing the object into the multiple parts and uploading them in parallel. Once all parts are uploaded, they are reassembled into the original object. And you can also configure the settings to retry failed upload and delete incomplete multi-upload. Additionally, in multi-part upload, you can specify the parameters such as the number of parallel uploads and the threshold for splitting files. Next, let's talk about S3's transfer accelerations. The transfer acceleration is a feature that speeds up file and uploads and the transfer between regions. When it's enabled, S3 uses globally distributed edge locations to optimize the upload process. And if enabled, the endpoint will be created. I will explain more details about the edge location in the CloudFront chapter later. In short, edge locations act as a relay point equipped with AWS networking infrastructure. And lastly, let me introduce S3 Select. The S3 Select is a feature that allows you to extract a subset of data using SQL queries. It supports data formats such as CSV, JSON, and Apache Packet. And you can execute S3 Select via the CLI, SDK, or the management console. For example, if you have a large dataset, retrieving the entire object with getObject can take a long time. So S3 Select helps reduce download times by allowing you to retrieve only the necessary data. The S3 Select is no longer available to new customers in July 2024. Only existing customers can continue to use it. And for reference, let me introduce the concept of the data lake. A data lake is a storage solution for saving data in any format. It's often used in contrast to the data warehouse, where the data is processed and stored for specific purposes. The S3 is ideal for a data lake because it can store unlimited amounts of both structured and unstructured data. The S3, when used as a data lake, is commonly paired with tools like the Amazon Athena for data queries, the AWS Glue for data processing, the Redshift as a data warehouse tool, and EMR for running Hadoop and Spark in AWS environment. Next, I will introduce Storage Gateway. The AWS Storage Gateway is a service that seamlessly connects the on-premises storage with AWS storage services. You can synchronize and replicate the data from your on-premise environment to AWS, as if you are simply saving it locally, without needing to be aware of the differences between on-premise and the cloud environment. And this allows you to use the cloud as an extension of your on-premise infrastructure. Storage Gateway is used for the data backup and disaster recovery. As listed here, there are 4 types of storage gateways, and starting from the next page, I will introduce each of them. The File Gateway is a gateway service that synchronizes and transfers data using SMB or NFS protocols. SMB and NFS are protocols commonly used for file sharing. It stores data in FSx for Windows File Server or raster, which is easier for the high-performance computing environment. Additionally, the data saved to virtual image mounted with an S3 file gateway is automatically synchronized to S3 bucket. And you can also configure storage class and lifecycle management for the S3's data. The Volume Gateway is a gateway that uses the iSCSI-based volume storage. The iSCSI is a protocol for connecting the computers and the peripheral over the TCP and IP network. There are 2 types of volume gateways, cached and stored. In cache mode, all data is stored in AWS, and only frequently accessed data is cached on-premise. Since data is cached locally, application can access it with low latency. In stored mode, the data is saved on-premise and asynchronously replicated to AWS. The stored mode is commonly used for backups and disaster recovery purposes. The stored data can be integrated with AWS Backup and EBS snapshot schedules, allowing you to create snapshot as backup. And here you can see the images of the cached and stored mode. In cache mode, a cache layer is placed in the on-premise environment, while the volume storage is in AWS. In stored mode, the data is simply asynchronously replicated between on-premise and AWS, so there is no cache layer. And finally, the Tape Gateway is a service that provides a virtual tape library in AWS. You can configure the Glacier as the storage destination for tape archive. And this allows you to use existing on-premise backup software while storing the backups on AWS virtual tapes. The Tape Gateway also offers a tape retention lock feature, which has 2 modes, the compliance mode and the governance mode. In compliance mode, the tapes cannot be deleted during the specified retention period. In governance mode, only IAM authorized users can delete tapes. The governance mode is typically used for backups or audit data that must not be tampered with. Next, I will introduce the storage services for computing services. The EFS and the EBS are storage options that can be attached to computing services like EC2 instances. The internal storage of EC2 instance is volatile. If you stop the instance, the data in the internal store will be lost. If you need persistent data storage, you should use EFS or EBS. The EFS can be attached to the multiple instances across the multiple AZ, and EBS can be attached to the multiple instances by enabling the multi-attach. But due to a certain limitation, it's typically attached to a single instance. Both EFS and EBS can be detached from EC2 instances as external storage, and EFS can be used as shared file storage, while EBS can be saved as snapshots. And this table compares the differences between the EBS and EC2 instance store and the EFS. Again, the EBS is block storage and the EFS is file storage. The EC2 instance store is internal storage in EC2. The connection type for EBS and EFS is over the network, while the EC2 instance store uses local disk. And EFS and EBS can be used for the persistent storage. And in terms of redundancy, the EBS provides the redundancy within a single AZ, while the EFS offers redundancy across the multiple AZ. The EC2 instance store does not provide the redundancy. And similarly, the EBS and the EFS are scalable, but the instance store is not. As a reminder, if you need to attach storage across the multiple instances in multiple AZ, use EFS, and for single AZ, use EBS. So now let me introduce the EC2 instance store. The EC2 instance store is a storage that is attached to an EC2 instance. The lifecycle of instance store is tied to the instance it is attached to. When the instance is stopped or terminated, the data in the instance store is lost. The instance stores are typically used for the temporary data storage, such as caching or use case with the high I/O requirements. And there are different types of instance stores, including SSD, HDD, and NVMe. The capacity and the specification of the instance store vary depending on the instance type. Next, here is a list of EBS specs. The EBS is block storage, and you can choose its specs. You don't have to memorize the number listed here, and these numbers may be updated in the future. And for now, just remember the general categories such as the choice between SSD and HDD, and the specs based on the IOPS and throughput. The SSD generally offers a better performance than HDD. Additionally, the provisioned IOPS SSD is used for the workloads that require higher performance than the general purpose SSD. And also, the higher the spec, the higher the cost. The number at the end, like the GP2 and the GP3, indicates the versions, with the larger number representing the newer version. For example, GP3 is newer than GP2 and has improvements such as better scalability. The provisioned IOPS SSD supports multi-attach, and only SSD supports boot volumes. Next, let's talk about the Amazon EFS. The EFS is an NFS-based file storage service. It can be attached to EC2 instances or on-premises server. To attach it to the on-premise server, AWS Direct Connect is used. The EFS can be attached to multiple instances across multiple AZ. And it's free managed, so users don't need to worry about software update or maintenance. Additionally, its storage capacity automatically scales as needed. The NFS stands for Network File System Protocol. It's a file sharing protocol designed for Linux, and Amazon EFS is primarily used with Linux instances. But for Windows instances, FSx for Windows is used instead. The EFS offers two performance modes, the General Purpose and Max I/O. The General Purpose is easier for use cases like web delivery, the content management, and home directories. And the Max I/O mode is designed for workloads require the higher throughput such as big data analytics or media processing. In addition to the storage cost, there are also charges for provisioned throughput. The EFS has storage classes, while not as many as in S3. The EFS standard is the storage class designed for frequently accessed data, offering the high durability and availability. And EFS IA, the infrequent access, is the cost-efficient storage class for the data that is accessed less frequently, making it easier for long-term storage or data that is rarely accessed. And you can also set a lifecycle management policy to automatically transition data between these classes. For example, if a file has not been accessed for 14 days, it will automatically move from EFS standard to EFS IA. And here, I will introduce the encryption process for EBS and EFS. When creating a new EBS volume or ESS file, you can enable the encryption using KMS. However, you cannot encrypt an existing EBS volume and the EFS file system directly. And therefore, to encrypt the existing EBS and EFS, you need to follow these steps. For EBS volumes, first create a snapshot of the existing EBS volume, then encrypt the snapshot. After that, create a new EBS volume from the encrypted snapshot and reattach it to your EC2 instance. For EFS file system, you need to create a new EFS file system with encryption enabled, then copy the data from the existing EFS file system to the new one. And this process is commonly tested in certification exam, so it would be helpful to remember it here. And lastly, Amazon FSx is a free managed file storage service that supports third-party file storage systems. Currently, it supports NetApp, OpenZFS, Windows File Server, and Raster. In particular, FSx for Windows File Server and FSx for the Raster frequently appear in the exam. The Amazon EFS is used for the Linux-based systems, while FSx for Windows File Server is for Windows-based systems. And the Raster is used for high-performance computing. Next, I will introduce the disaster recovery. First, let me introduce some key metrics and terms commonly used in the disaster recovery. The disaster recovery ensures the business continuity and helps achieve the system-wide fault tolerance and high availability, even in event of the failure in the region or availability zones. The two key metrics related to recovery design are RPO, the recovery point objectives, and RTO, the recovery time objective. The RPO refers to the time between the occurrence of the failure and the last backup. In other words, it indicates how much data loss can be tolerated. For example, if backups are taken once every 24 hours, there is a possibility of losing up to 20 hours of data. The RTO refers to the time it takes to restore the operation after a failure. Generally, the shorter the RPO and RTO, the more frequently backups are needed and the faster recovery architecture must be, which can increase the cost. Disaster recovery scenario include the backup and restore, the cold standby, the pilot light, warm standby, a hot standby, the multi-site, and the active configurations. In backup and restore, the data is backed regularly, and in the event of failure, the recovery is attempted from the most recent backup. The backups are typically scheduled on a daily or weekly basis. However, since recovery from backup can take time, and this approach is suitable when longer service downtimes are acceptable. In cold standby, the data is replicated to secondary site, and if a disaster occurs, the operations are switched to the standby environment. In cold standby, the secondary site systems are powered off during the normal operation. In warm standby, a backup system is pre-configured in the standby environment, and in case of failure in the primary environment, the operations are switched over. In both cold and warm standby, the data is asynchronously replicated to standby environment. In hot standby, the same environment is set up at the secondary site, and in case of disaster, the traffic is redirected immediately to restore services without downtime. In hot standby, the standby environment is also running at all times, even during the normal operations. As for the backup and restore, the RPO and RTO get longer and the cost decrease. Conversely, as you move down, RPO and RTO shorten, but the cost tends to increase. I will introduce the AWS services related to disaster recovery. And the first S3 is widely used as a storage for backup data. Additionally, Storage Gateway is used to synchronize and replicate the data between on-premise and AWS. AWS Backup is a service that automates and schedules backups. For cold standby, you can copy an Amazon machine image, AMI, of the production environment to EC2 instance template, and in the event of failure, use CloudFormation to build the environment in the secondary site. Let me introduce an example of a backup and restore configuration. Normally, the operation runs in region A, where AMIs, snapshots, and logs are taken as backup. And these backups are replicated in advance to region B. And in the event of failure, the backups stored in region B are restored. And finally, the traffic is redirected to region B. In the backup and restore scenario, since the restoration process starts in region B after a failure occurs, the RPO and RTO tend to be longer. In warm standby scenario, a minimal standby environment is set up at the secondary site. In the event of failure, the standby environment is scaled up to become the new production environment. During the normal operation, the standby run with the minimal resources, but when promoted to production, auto-scaling can be used to add instances, and Route 53 can be used to switch routing. In a hot standby scenario, the same environment is running at both the production and the secondary side. This allows for seamless failover to secondary environment with no downtime in the event of a disaster. A Route 53's DNS failover is used to switch to the secondary side, and the Global Accelerator can be used to speed up the failover process. In cold standby, the standby environment is only activated after a failure occurs. In warm standby, the primary region, the region A, is on operation during the normal time, while the standby region, the region B, runs with the minimal resources. In hot standby, both the primary and the standby environment are always running with the same configurations. In the event of failure, the traffic is switched to region B, since the standby environment in warm standby is already running. A recovery is faster than in cold standby. And in hot standby, the Global Accelerator is often used to minimize the downtime during the traffic switch. To further reduce the downtime during the database failover, lead replica can be promoted to primary instances, or you can use DynamoDB's global table or Aurora's global database, which are designed for multi-region support. But I will introduce the lead replicas and the global tables in more detail in the database chapter. AWS Database Services provide a replication option across the multi-region, which improves the availability and enables faster disaster recovery. The AWS Backup creates and manages resource backups and automates the backup process based on the specified rules. AWS Backup supports services like EC2, database services, and storage services. And you can automate the backups by specifying the rules for frequency, time, and other settings. The backup plan can be defined in JSON format. For example, here is a sample that runs a backup every day at 12 o'clock in the colon syntax. And the start window minutes parameter specifies the window in minutes during which the backup jobs can start. And in this case, it's set to 60 minutes, meaning that backup job will start at any time within 1 hour after the 12 o'clock. The exact start time is automatically determined by AWS. The completion window minutes parameter specifies the time in minutes, allows the backup job to complete. And in this example, it's set to 10,080 minutes. 1 week, meaning the backup job is expected to complete within the 1 week of starting. Let me introduce the AWS Elastic Disaster Recovery. The AWS Elastic Disaster Recovery replicates data from on-premise to the AWS environment or other cloud source services to AWS. In addition to migration, it can also adapt the architecture based on the AWS recommended configuration. The Elastic Disaster Recovery primarily supports server replication. Then now I will explain the steps for using the Elastic Disaster Recovery. First, set up an EC2 instance through the console, then install a dedicated engine on the source server to replicate the data to AWS. The replication occurs continuously, and once complete, you can launch the recovery EC2 instance to perform the recovery. If a failure occurs in the on-premise environment, you can perform the recovery and the failback. And finally, let me introduce the definitions of RPO and RTO for disaster recovery architecture. The AWS defines the following number. The backup and the restore typically has the RPO and RTO of several hours. The pilot light aims for the several tens of minutes. The warm standby targets a few minutes, and the multi-site configuration aims for the real-time failover. The definition of RPO and RTO may vary depending on the source, but these are the numbers defined by AWS. Next, I'm going to introduce compute services. And here I will introduce EC2, autoscaling, the containers, the serverless services, and other services. And as for Elastic Load Balancer, I will present it in the network chapter. Firstly, I will introduce EC2. EC2 is a service that allows you to create virtual machines. It logically partitions the physical servers in the data center and provides them to customers. The AWS data center are designed with disaster recovery and built to maintain high availability. The power supply and the network equipment are designed to avoid a single point of failure. Additionally, by distributing the virtual machine across the multiple data center in the multi-available zone, and you can achieve even higher availability. And EC2 is a virtual server service and is one of the most popular cloud services. And compared to physical server, you can quickly set up a virtual server with just a few clicks in your browser. A wide variety of instance types are available, allowing you to choose the right one for any use case. In the cloud industry, an instance refers to a virtual server. EC2 provides a high availability of 99.99%. And the pricing is free pay-as-you-go, and you are only charged while the instance is running. And discounts are also available through the various purchasing options. EC2 is only charged when the status is running, and you are not charged when it is stopped or terminated. By the way, the terminated in EC2 means deleted, and this means once instance is terminated, it cannot be restarted, and any data stored in the instance store is lost. And if you need to restart the instance later, choose Stop instead of Terminate. And you can also create a template of the instance as an AMI, the Amazon Machine image, to user for backups or copying to other regions. So let me introduce the placement groups. A placement group is a logical grouping of the instances within the specific placement strategy. There are three types of placement group. A cluster placement group places EC2 instances within the same network segment of the same AZ, and this minimizes the network latency and achieves high network throughput. The partition placement group places EC2 instances in different partitions within the same AZ, with a maximum of 7 partitions. Since the partitions do not share the physical racks, they each have the independent power sources, ensuring the redundancy. The partition placement groups are primarily used for large-scale distributed workload. A spread placement group distributes EC2 instances across the different partitions within the same AZ. Since all the instances are isolated, this configuration is used to avoid the dependency issue. Next, let me introduce instance types. The AWS offers a wide range of EC2 instance specs to meet different users' needs, and these specs are referenced to as the instance type. Next, let me introduce instance types. The AWS offers a wide range of EC2 instance specs to meet different users' needs, and these specs are referred to as instance types. For example, in an instance type like A1.medium, the name consists of the instance family, the generation, and the instance size. The instance size varies based on the factors such as the vCPUs, the memory, and the storage. The instance families are categorized into the general purpose, the compute optimized, the memory optimized, the accelerated computing, and the storage optimized. You don't need to memorize all the family codes, but some instances families follow a pattern. For example, the compute optimized instance starts with the letter the C for compute. As a reference, let me briefly introduce the evolution of instance types. Although this is a slightly outdated data, the specs for instance types have been expanding every year. Currently, there are over 500 instance types available. Next, let me introduce bursting. The instance types that start with the letter the T, such as T2, T3, T3A, and T4G, have burst performance capabilities. And the normal condition, they operate within the baseline CPU performance, but can handle sudden spikes in load. When the CPU usage exceeds the baseline, the CPU credits are consumed, and when the usage falls below the baseline, the CPU credits are accumulated. I will show you an example of how bursting works on the next page. So let me explain how bursting works. When a burst occurs, the CPU usage exceeds the baseline by 10%. As a result, the CPU credit balance decreases. Once the burst ends, the CPU credit balance starts accumulating again. And if the CPU credit balance reaches zero, the instance can no longer burst. And in unlimited mode, the instances can continue to burst using the surplus credit. And this is similar to bank deposit balance. If you don't repay them accumulating the CPU credit within 24 hours, you will be charged. And this is an image illustrating how bursting works. The red arrow shows the sudden spike in CPU usage, triggering the burst. As the burst occurs, the CPU credit balance decreases. Once the burst ends, the CPU credit balance starts to accumulate again. Next, I will introduce the private cloud services, the dedicated host and the dedicated instances. The dedicated host allows you to run instances on dedicated physical server. Since you have control over the physical server, this is useful when there is software or hardware dependency. However, because the physical server is exclusively yours, the cost is higher. And you can apply the reserved discount for 1 or 3 years as well as discount for upfront payment. The dedicated instances also run EC2 instances on the dedicated physical server, but you cannot manage the hardware specifications. You only have the exclusive use of the physical server. The dedicated instances are helpful when you need to meet compliance requirements or avoid sharing the physical server with other customers. There are several purchasing options for EC2 instances. Reserved instances offer a discount for long-term reservation of 1 or 3 years, providing up to 72% savings. On-demand instances are default pricing option where costs vary based on your usage. And you can also make capacity reservation for the daily, weekly, or monthly scheduling. For example, this is useful for tasks like a batch processing that only runs once a month. Spot instances offer unused instances in availability zones at a discounted price, making them the most cost-effective options. However, since they can be terminated if capacity demand increases, they are not suitable for long-term use. The spot instances are ideal for temporary tasks like batch processing and frequently mentioned in AWS certification exams. The reserved instances have several pricing factors, including instance type, the region, the platform, tenancy, the term length, the payment method, and the offering classes. You can check the specific cost using the pricing calculator. The saving plans like reserved instances offer discount for long-term usage for 1 or 3 years. However, compared to saving plans, reserved instances for EC2 have more options to select, and you cannot change these settings once they are in use. There is also convertible option, which allows you to change the instance family, the platform, or tenancy during the term, but it comes with a higher price. The saving plans provide a more flexible option than reserved instances. Next, let me introduce spot instances in detail. The spot instances offer unused capacity at a discounted price, available on a per AZ basis. The availability of spot instances vary by AZ, and you cannot know in advance how many will be available. Therefore, the spot instances price fluctuates depending on the timing. When there is no more unused capacity in an AZ, the spot instance will be terminated, stopped, or hibernated. And you will receive a notification 2 minutes before the instance is interrupted, allowing you to prepare for the shutdown. However, since the notification only gives you 2 minutes of the warning, there are limited actions you can take. This makes spot instances suitable mainly for temporary tasks like the batching process. With auto-scaling, you can adjust the ratio of the on-demand and the spot instances. Increasing the portion of the spot instances reduces the cost, but sacrifices the availability. It recommends to design with the assumption that the spot instances may be interrupted. For example, regularly backing up your data or not storing any persistent data on the instances are good practice. The spot instances offer unused EC2 capacity in an auction-style format, which means their prices are dynamic. While they can be discounted by up to 90%, they are not always available at 90% discount. If there is no excess EC2 capacity, the discount ratio may be lower, and there is a higher risk of interruptions. To launch a spot instance, you create a request by specifying the item listed here. For spot allocation strategy, there is the price capacity optimized strategy that balances the cost and capacity, and the capacity optimized strategy, which focuses on minimizing the risk of the interruptions. The capacity optimized option generally offers smaller discounts. Again, the spot instances are frequently appeared in the exam. While spot instances are the most cost-effective options, it's important to remember that they also come with higher risk of the interruptions. Next, I will introduce auto-scaling. The scaling refers to the adjusting the system's performance or capacity based on the demand. The load on the server is not always constant, so it's necessary to adjust the system accordingly. Improving the performance of the single server, such as increasing its specification, is called scaling up, while increasing the number of the server to improve the overall performance is called scaling out. Conversely, the scaling down refers to the reducing the performance of the single server, and the scaling in means the reducing the number of servers. The AWS offers AWS Autoscaling, Amazon EC2 Autoscaling, and the Application Autoscaling. If you need to scale across the multiple resources, use AWS Autoscaling. If the scaling target is limited to EC2 instances, use EC2 Autoscaling. For scaling individual services, you can use the Autoscaling API or Application Autoscaling API. In autoscaling, you can set the scaling policy, including the scheduled scaling, the simple scaling policy, the step scaling policy, the target tracking scaling policy, and the predictive scaling. The scheduled scaling allows you to scale based on the desired minimum and the maximum instances according to the specific time. It supports both one-time and the recurring the scaling. The simple scaling policy triggers the scale based on the CloudWatch alarms. It includes the cooldown period, which prevents another scale operation from starting until the specified time has passed. The step scaling policy also triggers the scaling based on the CloudWatch alarms, but does so in steps. With the warm-up feature, it prevents the unnecessary instances from being launched, even if the specified cooldown time hasn't passed since the last scale out. The step scaling policy is an improved and more flexible version of simple scaling policy. The target tracking scaling policy allows you to define the metrics type and the target value for scaling. For example, if CPU usage exceeds 50%, the system will scale out. It scales out quickly but scales in gradually. The predictive scaling uses metric history and machine learning techniques to predict and adjust the number of instances. It forecasts based on the last 24 hours of data and predicts the needs for the next 48 hours. A target tracking and step scaling and the simple scaling policy are collectively known as the dynamic scaling. I will explain warm-up and cooling down. The warm-up refers to the preparation time before an added instance begins handling the traffic. During the warm-up period, the additional scaling actions are prevented. The warm-up is used in the step scaling and the target tracking scaling. The cooldown represents a set waiting period after scaling before auto-scaling takes next actions. During the cooldown period, the additional scale-out or scale-in actions are prevented. It is used in the simple scaling. At first glance, the behavior of warm-up and cool-down may seem similar. I will explain this with the example on the next page. I will explain the warm-up process of step scaling policy using an example. Let's say one EC2 instance is added when the CPU usage exceeds 60%, and two more instances are added when it exceeds 70%. The default warm-up time is set to 300 seconds. Now, Let's assume that the CPU usage spikes rapidly during this time. When CPU usage exceeds 60%, one EC2 instance is added. If CPU usage then exceeds 70%, two additional EC2 instances are added. However, even if CPU usage jumps quickly from below 60% to over 70% during the warm-up period, only two instances will be added, not three. This is because step scaling policy only adds the differences in the instance between the stages. In contrast, the cooling down in simple scaling policy, they simply set an interval between the scaling actions, while step scaling policy offers more flexibility by adding instances incrementally based on the CPU usage differences. Next, I will introduce health checks. The auto-scaling periodically performs the health checks on the target instances. It monitors the EC2 instance directory, and if the EC2 instance status is anything other than running, or if the system status is impaired, it considers the instances as unhealthy. The auto-scaling can also be combined with ELB to determine the instance's health status based on both EC2 instance checks and ELB health checks. For ELB health checks, the TCP three-way handshakes or HTTP status checks are performed. And next, I will explain lifecycle hooks. A lifecycle hook detects the lifecycle event of EC2 instances within an auto-scaling group and allows you to perform the appropriate action in response to those events. The term lifecycle here refers to the cycle from when an EC2 instance launched until it is terminated. The lifecycle hooks temporarily pause the state transition of an instance and keep it in the wait state for a specified period. During the waiting time, the users can perform any necessary actions. And here are some use cases for lifecycle hooks. First, during the scale-in event, before an instance is removed from the service, you can use the lifecycle hooks to back up data or stop the scale-in process until any ongoing tasks are completed. Conversely, before an instance is transitioned to the in-service state, meaning it becomes a part of the auto-scaling group, you could use a lifecycle hooks to install the specific software or update the configuration files. The lifecycle hooks can be integrated with the CloudWatch event or Lambda to automate actions. And this is the lifecycle flow. A heartbeat timeout refers to the amount of time and instances remain in the wait state. If the wait state exceeds the specified threshold, the system presses the default result. There are two possible default results, and abandon and continue. The abandon will terminate the instance, and the continue means to the process with the current operation. For example, during the scaling out event, the instance will continue to the in-service state, while during the scale-in event, the instance will stay in the terminate state. Next, I will introduce container. A container is a lightweight, standalone package of software that includes everything needed to run a package of software, including the code, runtime, system tool, library, and settings. The container isolates software from its environment and from other containers. To understand the container, an analogy is often made. If a physical server is a house, the virtualization technology is a rental apartment, and a container is a shared house. In a shared house, the facilities such as a kitchen and bathroom are shared by multiple residents, and each resident has their own living space, which increases the cost efficiency. The containers are more efficient by using the layers below the container engine as a common area, and using the application execution environment as the independent unit. This is an outline of AWS container services based on Docker. The AWS offers several container services, including the ECS and EKS for orchestrating the container environment, and the ECR for storing the container image, and the EC2 or Fargate as a hosting option for containers. Additionally, it supports deployment to external environment. And for reference, the orchestration refers to the comprehensive automation of tasks such as container deployment and management. You can choose container service based on the type of container engine. If you are using Docker, you would use ECS, and if you are using the Kubernetes, you would choose EKS. For deployment, you can select EC2 instance or Fargate. A Fargate is a serverless option, so you don't have to manage any underlying servers. Additionally, you can deploy ECS and EKS in on-premise environment, which is referred to as ECS Anywhere or EKS Anywhere. An EKS distro is an open-source distribution of EKS, allowing you to use in the on-premise environment or other cloud platform. In addition to EC2 and Fargate, you can deploy containers to Elastic Beanstalk, Lambda, and AWS Batch. Elastic Beanstalk is a path that automates application deployment, allowing you to easily deploy containers like with Fargate. However, it doesn't offer as much customization as EC2. And you can run containers on Lambda, but there are some limitations on execution time and resources. Lambda has a maximum execution time of 15 minutes, making it suitable for short-term tasks, but not for long-running process. The AWS Batch is a service for running job-oriented workloads and supports the execution of Docker containers. Next, I will introduce the environment where you can deploy EKS. The EKS distro, EKS Anywhere, and the EKS on the Outpost are deployed in the user's environment, meaning the on-premises, and the EKS on EC2 and the EKS on Fargate are deployed on the AWS cloud. The EKS Anywhere is an AWS provided service, so AWS takes responsibility for support. On the other hand, EKS distro is an open source distribution provided by AWS, which means the user is responsible for managing it. And you can get the EKS distro distribution on Git repository. I will now introduce the components of EKS. EKS is based on Kubernetes. This is not within the exam scope, but I'm introducing it for reference. A cluster is the largest unit that makes up a Kubernetes. It contains a control plane, the master nodes, worker nodes, and other services. A cluster can include multiple instances, allowing for scalability and improving the availability and performance. It's also possible to run it on the single instance. Kubel is a command line tool used to interact with the Kubernetes cluster. With Kubel, you can deploy, manage, and monitor resources in the cluster. You can use Kubernetes through a Cloud Shell or the CLI. A node is a server that forms part of Kubernetes. In practice, an EC2 instance operates in the background. There are two types of node. A master node which monitors and manages the entire cluster, and a worker node where the containerized applications are actually deployed. The master node is also referred to as the control plane. The control plane handles the overall management of clusters and includes the components such as the API and the scheduler. The worker nodes, or simply nodes, are essentially EC2 instances. The worker nodes run containerized application and includes a container runtime to connect with external resources. A pod is the smallest unit of the Kubernetes and that contains one or more containers. It provides a template for resources needed to run the application, enabling the portability. The pods are stateless, which means they are initiated when the container starts and disappear when the container terminates. Since they run serverless and charged only while active, they are cost-efficient. Inside the pod, there can be one or more containers. Additionally, a sidecar container can be included, which extends the functionality of the main application or serve as the supplementary role. Next, I will introduce Lambda, AWS Batch, and Amazon Lightsail. Lambda is an event-driven serverless computing service. Event-driven means the service is triggered by the specific event and doesn't run continuously. Since it's serverless, you don't need to manage the infrastructure layer, and you are only charged for the executing time of the functions. The Lambda automatically runs code in response to the event and works with the various AWS resources. A cloud service that runs the function is called FaaS, or the function as a service. It supports a variety of programming languages, including Java, Python, and Go, and it can integrate with the various AWS services, but you must assign IAM permissions for execution. Lambda supports a wide range of use cases. For example, it can be triggered by HTTP request via the API, execution function when data is uploaded to S3, or run function on a scheduled basis. To better understand the role of Lambda, I will show examples on the following pages. And here is a sample code that integrates API gateway to trigger a function with the HTTP request and retrieve data from DynamoDB. When Lambda processes an HTTP request, it is typically integrated with API gateway. An HTTP GET request is sent from the application deployed on the EC2 to API gateway. API gateway functions as the HTTP endpoint, receiving the request and passing it to the Lambda functions. The Lambda function then processes the request. When the Lambda function is triggered, it retrieves the ID from the query parameters and uses that ID to get data from DynamoDB. And if successful, it returns the fetched data in JSON format. Since Lambda is commonly used for integration between services, it is important to assign the appropriate IAM execution role. In this case, you must grant the role that allows you to operate DynamoDB. When many requests are sent concurrently, Lambda launches multiple execution environments to process them in parallel. And by default, the maximum number of the concurrent execution per region is 1000. So if more requests are sent, a throttling error will occur. If the number of requests increases and the Lambda function reaches its concurrency limit, causing it to malfunction, you will need to raise the limit. You can increase it to the tens of thousands if necessary. Next, I will introduce the Lambda layer. The Lambda layer allows you to package libraries and dependencies that can be shared across the multiple Lambda functions. By storing the commonly used components in the Lambda layer, you can reduce the size of your function deployment packages. Before Lambda layer were available, you had to upload the library and the dependency as a zip file for each Lambda function individually. You can set up versionings and alias for your Lambda functions. The versionings allow you to keep both old and new version of your code. When you update your code, a new version is created automatically. An alias helps you create a separate environment, like production, deployment, or staging. You can have the different alias for different environments to better manage your function. Lastly, I will introduce the quotas for Lambda. The Lambda is charged based on the number of function execution. To prevent unlimited charges, Lambda has a timeout setting. The default timeout is 3 seconds, and the maximum execution time per request is 900 seconds, means 15 minutes. Since the maximum time is only 15 minutes, the Lambda is not suitable for the long-running task. It's better for short jobs. The temporary storage for data is limited to 512 MB. The total size of functions and layer is 75 GB, but this can be increased by submitting a request. The default concurrent execution per region are limited to 1,000, but this can also be increased with a request. If your function hits the limit during the high traffic, you will need to raise the limit. The memory starts at 128 MB and can go up to 10,240 MB. And you can add up to 5 layers per function. AWS Batch is a service designed to run a large-scale batch processing job. The batch processing refers to executing a series of tasks together. For example, the processing the transaction data once a day. The batch processing is often scheduled for specific times and is typically run asynchronously. AWS Batch can handle the hundreds of thousands of batch jobs and is commonly used for tasks like high-performance computing and training the machine learning method. It supports compute resources like the Fargate, the Fargate Spot, and the EC2 on-demand and spot instances. There's no direct cost for AWS Batch itself. You only pay for the compute resources used, such as Fargate or EC2 instance. The AWS Batch allows you to run containerized application in the serverless environment. You are charged only while the job is running, and once the job is finished, the environment is stopped, so no extra costs are incurred. To help you understand the AWS Batch jobs better, I will explain it further with a practical example in the next section. So let me explain the process flow of the AWS Batch using a large-scale data processing, for example. First, you take a large data set and break it into smaller subsets for the processing. Each subset is then handled by the separate job. The jobs wait in the queue and executed one by one. And you can set the order of the execution, the priority, and the scheduling for the job. Once a job is executed and the processing is complete, the result is saved in the specified location. For example, the output could be stored in the S3 bucket, where the results are eventually combined. And you can use AWS Batch as the execution environment for containerized application. In data analysis, for example, you can define tasks like the data cleansing, the data transformation, and the data analysis. To containerize the application, you create the Docker file. A Docker file is a text file that defines the steps to build a container image, such as the runtime environment, installing the dependency, and specifying the command to run. After building the container image from the Docker file, you push it to a container repository like ECR. Finally, you create a job definition in the AWS Batch and specify the container image you just pushed. And you can define the container image to run the required resources and the execution command for your job. If you have multiple steps like the data cleansing, the data transformation, and the data processing, you can use AWS step functions to define and run each job in sequence. AWS Batch is suitable for scheduling the specific tasks in the serverless environment. However, for tasks that need to run regularly, it's better to use EC2 or other services instead of the AWS Batch. The Amazon Lightsail offers a low-cost, pre-packaged virtual private servers, mainly used for the smaller-scale development project. It provides an easy way to set up the servers and network needed for building applications. With EC2, you need to configure network and the virtual server yourself, but with Amazon Lightsail, you can create a private server with just a few simple steps. You can choose the specs like a Linux, Unix, or Windows server. However, if you need more detailed infrastructure customization, EC2 would be a better choice. The pricing is simple with a fixed monthly rate for each package, but since it's not pay-as-you-go, you'll still be charged even when the server is stopped. Next, I will introduce the other services, Hybrid Cloud Service and On-Premise Deployment Service. The VMware Cloud on AWS is a hybrid cloud service offered by the VMware and AWS. It allows you to extend your existing VMware vSphere environment to AWS. The VMware Cloud has the feature listed here, and it's especially useful for seamlessly integrating on-premise and the cloud environment as a hybrid cloud solutions. A hybrid cloud refers to the combined environment of both public and private cloud. By adapting the hybrid cloud, you can seamlessly migrate from your on-premise environment to AWS. And this allows you to use the AWS Cloud as the extension of your on-premise installation. For example, if your on-premise data center runs out of the capacity, you can temporarily use the VMC environment. It can also be used for failover in case of disaster or as a testing environment. The VMware is a company from California known as the pioneer in the virtualization technology. The vSphere is a VMware's flagship product and is a de facto standard for server virtualization. With the rise of cloud computing, the VMware and now offer a hybrid cloud solution with not only AWS, but also Google Cloud and Microsoft Azure. For the AWS Association exam, VMware is not typically covered. However, if you are using the VMware product in your work, it's good to know that you can continue using the VMware in the AWS. The next is AWS Outpost. AWS Outpost extends the AWS infrastructure to your on-premise environment. It involves the setting up the physical rack at your on-premise locations. The AWS manages the rack, so you don't have to worry about the operational overhead, and you can run AWS services locally with low latency. The AWS Outpost offers a full private cloud experience. However, the available services and the features are limited, and it's quite different from the typical public cloud use cases. It's mainly used when you need to run an AWS service locally due to compliance or security requirement. Next, let's talk about the AWS wavelengths. The AWS wavelengths enable data transmission within the networks of telecommunication companies that provide 5G services. And this allows you to run AWS services with low latency and high performance over 5G networks. The service is mainly used by the telecom company, so the usage is limited to the certain business. For example, in Japan, the major telecom provider KDDI offers the 5G network environment for AWS wavelengths. And lastly, AWS Compute Optimizer analyzes your usage of EC2, EBS volumes, and Lambda to check if the resources sizes are appropriate and provide a recommendation. For analysis, you need at least 30 hours of metrics over the past 14 days, and for Lambda, it requires at least 50 invocations in the last 14 days. And here's an example of how to use Compute Optimizer. It evaluates your current resources as under-provisioned, optimized, or over-provisioned based on their specs. It also gives a recommendation for the optimal instances type based on your current specs. Next, I'm going to introduce the networking and content delivery. First, I'd like to introduce an overview of the AWS network services using the typical network diagram. On the left side, the diagram shows a network connected to the Internet through the Internet gateway. On the right side, it shows the network connected to the on-premises and the VPN using the virtual gateway. The area that outlined in red presents the AWS cloud space located in each region. In each region, the VPC, the virtual private cloud, is set up. A VPC is an address space that provides a sufficient number of IP addresses to host your resources. Inside the VPC, you create a subnet which is another address space. Within the subnet is where you actually place your AWS resources. In the diagram on the left, there are both private and public subnet. The confidential data should be placed in the private subnet, which cannot be accessed directly from the Internet. On the other hand, the public subnet hosts the web server and allows access from the Internet via an Internet gateway. In the diagram on the right, the two subnets with the same configuration are placed in the different availability zones. The setup ensures that if one subnet becomes unavailable, the other subnet can continue running on the service. To allow access from the VPC, you need the gateway services. To access the Internet, you use a NAT gateway, which converts the global IP address used in the Internet space to local IP addresses used in the VPC. An Internet gateway also has NAT functionality. To connect the VPC with an on-premise site, you set up the virtual private gateway on the VPC side and the customer gateway on the on-premise data center. And each subnet has a route table that records the routing information. This allows the routing between the resources, subnet, and the VPC. Additionally, each subnet is equipped with the firewall function called a security group. So now let me introduce the various services. In this chapter, I will introduce the VPC, the gateway services, the connection services such as the VPN and the Direct Connect, the CDN and DNS and load balancer. And firstly, I'm going to introduce VPC. The VPC offers many features including the network space, the security, logging, the peering, endpoint, network interfaces, and gateways. Then I will introduce these VPC features one by one. I will introduce VPC and subnet. The VPC, the Virtual Private Cloud, is the virtual network space set up within the AWS cloud. With VPC, you can logically isolate network spaces. For example, you can separate your development environment from your production environment. And you can flexibly design the network by using IP address ranges. A subnet is a virtual address space within the VPC. You place the AWS resources inside the subnet and manage the security and network as needed. And each subnet has a virtual router, which allows you to set up the route table and the network ACLs. You can create up to 200 subnets in a single VPC and expand as needed. The subnet exists within the availability zones, and when creating a subnet, you specify the availability zone it belongs to. To connect the internet, you need the public IP address. The resources in the public subnet are assigned the public IP address and can directly access the internet through the internet gateway. The resources in the private subnet communicate with the internet via the NAT gateway. The IP addresses play an important role. They allow you to access AWS resources. Then you can use CIDR ranges. The IP addresses you can set in the VPC are limited. For IPv4, you can configure a range between the /16 and the /28, and this equal to 16 to the 65,000 and the 536 IP addresses. The first four and the last IP address in each subnet are reserved by AWS and cannot be used. And each service requires a different IP address, so you will need to assign them accordingly. You can choose any address ranges, but using the private IP address spaces from the RFC 1918 is recommended. These addresses are not routed over the internet, so they are safe for internal use and help save global IP addresses. The CIDR, the classless inter-domain routing, is a method for allocating the IP addresses and sharing the routing information on the internet. The CIDR allows IP addresses to be divided into the group called a subnet, which can each be routed individually. In CIDR notation, the IP address is followed by the slash and the number that indicates the length of the subnet mask. For example, the 192.168.1.0/24 represents a subnet with the 256 IP addresses starting from the 192.168 and 1.0. In this case, the first 24 bits represents a network part and the remaining 8 bits represents the host part. In AWS, you can set the subnet mask between the /16 to /28, which corresponds to the 16,5000 and the 536 and the 16 IP addresses. And each time the number after the slash increases by 1, the available IP addresses are halved. Although the IP addressing itself may not appear directly in the exam, it's useful to understand this concept. The AWS provides two types of the public IP addresses. The elastic IP addresses are static IP addresses that can be reused. You can associate an elastic IP with any EC2 instance within your AWS account. And even if the instance is stopped or terminated, the elastic IP address remains the same. Be mindful of the pricing for elastic IP address. When the elastic IP is associated with the instance, there is no charge. However, if it is not associated with the instance, you will be charged. And this is because the IP addresses are limited resources, so a fee is applied as a penalty when they are not in use. Additionally, if multiple elastic IPs are associated with a single instance, the charges will apply. The auto-assigned public IP addresses are automatically assigned by AWS. However, if the instance is stopped or terminated, the public IP is released. When the instance is restarted, a new public IP address is assigned. Next, I'll introduce security groups and network ACLs, which serves as the firewall function at the network layer. This is a reminder of the overall picture of AWS firewall services. The firewalls are services that control network traffic to protect the system security. For firewall at the network layer, there are the network ACL, which control traffic at the subnet level, and the security group, which control traffic at the resource level. And this is also a reminder about another firewall classification, the stateful and the stateless firewall. The stateful firewall remembers the state of previous connections and automatically allows the packets that belong to the previously permitted traffic. And this enables more advanced traffic filtering. The security group is the stateful firewall, while the network ACL are classified as the stateless firewalls. You can control traffic using the security groups and the network ACL. The security groups are set at the resource level. In practice, they are attached to the resource ENI, the Elastic Network Interface. And the network ACLs are set at the subnet levels. The security groups are stateful firewall, while network ACL the stateless firewall. The stateful means that it remembers the previous traffic and makes a dynamic decision based on it. The stateless means it doesn't remember the previous traffic, so rules must be set in advance. The security group controls traffic at the instance level, specifically at the ENY. The network ACL controls traffic at the subnet level. And by default, the security groups allow the internet traffic, and the network ACL are all traffic. The security groups and the network ACLs are often appeared on the exam test, so it's important to remember the differences. Let me introduce an example of implementing the security groups. With security groups, you can group instances and control communication between them. In this diagram, the HTTPS traffic from the internet is received by the ALB, the application load balancer. Then the HTTP traffic is sent to the security group that contains the web server. And after that, the SSH connection is made to the security group that holds the database server. The inbound and outbound routing rules are defined for each step. For security reasons, the outbound traffic from the database service is not allowed. Next, I'll introduce VPC flow logs. The VPC flow logs capture the IP traffic logs from the ENIs, the Elastic Network Interfaces. And these logs can be sent to CloudWatch Logs, S3, or Kinesis Data Firehose for storage. VPC flow logs include the information like the source and the destination IP addresses, the port, protocol, packet count, the byte count, the timestamps, and the number of reject. And this allows you to check if the security groups are set up correctly and monitor the traffic to your instances. However, the VPC flow logs only provide the metadata. They don't show the actual content of the traffic. If you need to inspect the traffic content, you'll need the third-party firewall or the similar solution. Next, I'll introduce the VPC peering. The VPC peering connects the VPC through a private network. Since it uses the AWS private network, it enables secure communication without relying on the hardware and is designed to avoid a single point of failure. And you can create the peering connections between the different accounts and the regions. The VPC peering uses the private IP addresses within the VPC, so you don't need to assign the public IP addresses. Now, let's look at the cases where VPC peering cannot be used. If the CIDR blocks of the VPCs overlap, you cannot create the peering connections. Transitive peering is not supported. For example, even if you have the peering connection from the VPC A to VPC B and from VPC B to VPC C, the VPC A cannot communicate directly with VPC C. The VPC peering cannot be combined with other networking structure like the VPN connections, the direct connects, internet gateway, NAT devices in the private subnet, or the VPC endpoint for AWS services. Next, I'll introduce the VPC endpoint. To access another VPC from within your VPC, you normally need a public IP address. You either access resources with a public IP address in the public subnet, or use NAT gateway to convert a public IP into a private IP for accessing the resources in the private subnet. The AWS Service API endpoints are on the public network. If you want to access these resources privately, without exposing your IP address to the internet, the VPC endpoints are useful. A VPC endpoint is a virtual device that offers private access from within your VPC. And generally, an endpoint refers to the physical device used for the communications. There are two types of VPC endpoint, the interface endpoint and the gateway endpoint. For example, now you're gonna access an S3 packet in another VPC from your EC2 instance. With an interface endpoint, the requesting side endpoint communicates with the service provider's endpoint. The endpoint on the requesting side is called the interface endpoint, while the endpoint on the service provider's side is called the VPC endpoint service. And these endpoints are used AWS private link to securely connect without going through the internet. In contrast, gateway endpoint accesses the service provider's VPC through a gateway endpoint. In this case, no endpoint is created on the service provider's side. The gateway endpoints are used for Amazon S3 and DynamoDB, routing directly within the VPC without exposing the IP addresses. Here's a summary of differences between the gateway and interface endpoints. The gateway endpoints support S3 and DynamoDB, and they are free of charge. To connect, you need to add a route to gateway in your route table. Since it's routed within the VPC, the IP addresses are not exposed. It's not possible to access the gateway endpoint directly from the external endpoint. You need to set up the proxy server for external accesses. The interface endpoints support many services. Since you use the private link, they are pet services. ENI and DNS are associated with the interface endpoint. The DNS is specified in your application when making a request to the services. The interface endpoint allows private communication between the ENI and the service. And this also makes it simpler to connect from the on-premises environment without using the proxy server. Next, I'll introduce ENIs. An Elastic Network Interface (ENI) is a virtual network interface in the VPC. It's equivalent to a network interface card in the physical environment. An EC2 instance is a logical partition of the physical server, and the ENI acts as the virtual network interface card for the virtual machine. By attaching the ENI to a virtual server, the server can have networking attribute like the IP address. An ENI includes attributes such as the private IP addresses, the MAC addresses, the security group, and the elastic IP addresses. Next, I'll introduce the gateway services. There are some types of gateways: Internet Gateway, the NAT Gateway, the Virtual Private Gateway, and the Customer Gateway. The Internet Gateway is a VPC component that connects the VPC to the Internet. You can configure the Internet Gateway per VPC. A VPC with an attached Internet is called a public VPC. The Internet Gateway has the ability to translate the Internet traffic to private access. Another gateway translates the private IP addresses into public IP addresses, enabling the communication from private subnet to the Internet. However, it doesn't follow the inbound traffic from the Internet to the private subnet. And if you are using IPv6 and need outbound-only communication, you would use the egress-only Internet Gateway. The Virtual Private Gateway is used to connect the VPC environment to a VPN or a direct connect, enabling the connection between an AWS and the on-premise network. And the Customer Gateway is a VPN endpoint on the on-premise side. The NAT Gateway is a gateway service for connecting to the Internet from the private subnet within the VPC. The NAT stands for the Network Address Transitions. You can create it from the console of your VPC. A similar service to NAT Gateway is NAT Instance. NAT Instance is an instance with outbound address translation capability in the public VPC. However, if you are currently using the NAT Instance, it recommends that you replace it with a NAT Gateway. The NAT Gateway has advantage in terms of availability, bandwidth. NAT Gateway is more managed and has operational advantages. And for reference, this is a summary of the NAT gateways and the NAT instance. The NAT gateway has the redundancy in each AZ and high availability. It can also expand the bandwidth up to the 100 Gbps. As a managed service, you don't need to maintain it. The NAT instances, like EC2 instances, require you to manage failover configuration and maintenance. Unless there is a specific reason, the NAT gateway is recommended. Next, let me explain AWS Transit Gateway. The Transit Gateway acts as the central hub that can connect up to the 5,000 VPC and on-premise environment. It can be associated with a Direct Connect, VPN, and peering connections. And here is an image that shows the connection to the Direct Connect, the VPN, and the VPC peering. The biggest advantage of Transit Gateway is that it simplifies your network. As the number of VPC and on-premise location grows, the network becomes more complex. The more network resources you have, the more network becomes like a spaghetti mess. By using the Transit Gateway, you can simplify your network, making the routing between locations easier and reducing the management overhead and operational mistake. To use Transit Gateway, you create an attachment to connect the VPN, VPC, and Direct Connect. You can create one attachment per subnet in each availability zone, meaning only one attachment per AZ is allowed. And these attachments support high reliability and performance. Additionally, you can create an ENI to establish the direct connections, and you can use the Transit Gateway instead of the virtual gateway to create the VPN connection with a customer gateway. The Transit Gateway is powered by AWS Hyperplane, a load balancing technology that supports horizontal scaling and multi-tenancy at the multi-terabyte per second speed. Now I will introduce some features of the Transit Gateway. The Transit Gateway Network Manager is a management tool that helps maps and visualize your private network on the geographic map. You can use it by defining your Transit Gateway and on-premise resources. With Route Analyzer, you can check if your routes are set up as expected. Network Manager allows you to centrally monitor and manage your network. Next, I'm going to introduce VPN and Direct Connect. A VPN, the Virtual Private Network, is a technology that creates a virtual private communication network over the Internet. It enables secure communication without relying on the physical connections. So let me explain the key technologies that support VPN. A VPN creates a virtual tunnel between two locations. Even without a direct connection, it enables private network between them. Encapsulation makes context less visible from externally by wrapping in another protocol, and this makes the content secret. It supports encryption protocols like SSL and IPsec, which makes the data package unreadable. The authentication systems like SSO, the single sign-on, are used to ensure that only authorized user can set the data through the VPN. Since the VPN work over the Internet, they are affected by the Internet bandwidth. For example, in the areas with heavy usage, there is a risk of slower communications. Therefore, in the mission-critical system, you should consider deploying a dedicated line connections. There are two VPN connection methods, AWS Client VPN and Site-to-Site VPN. Then I will introduce each of them on the following pages. The AWS Client VPN, a VPN service that allows individual clients to connect securely to AWS. It can scale automatically based on the number of users, adjusting flexibility to change in demand. The AWS Client VPN provides an open VPN-based VPN. The client can access AWS resources by installing the software on their devices. It's used in the use case where, for example, the remote workers access the AWS cloud. The client VPN supports Active Directory, the federation authentication, and the certificate-based authentication. And when deploying it, you can configure the VPN endpoint and use an ENI to exchange data between the client and AWS. And this allows you to manage access to both on-premises and the AWS resources. AWS Site-to-Site VPN is a VPN service that connects the on-premise data to VPN. And it supports IPsec to secure communications. It connects the customer gateway to the virtual private gateway. The AWS Global Accelerator allows you to configure an accelerated site-to-site VPN. This can improve the network performance by up to 60%. The VPN Cloud Hub allows you to establish a VPN across the multiple sites. You can connect the multiple customer gateway to a single virtual private gateway. And it's also possible to place several customer gateways within one on-premise network to configure redundant site-to-site VPN. As the number of site-to-site VPN connections increases, so will the cost. And here I will introduce the types of VPN, the Open VPN and IPsec VPN. The Open VPN works at the transport layer, and it's easy to set up, install software on your devices, making it popular for individual devices and smaller networks. And in contrast, the IPsec VPN operates at the network layer and is directly integrated with the Internet Protocol. Since it's relatively complex to set up, so it's commonly used in the corporate network. The Open VPN is categorized as a software VPN, and IPsec VPN can be categorized as both software and hardware VPN. Since the hardware VPN needs a router or a VPN server, it makes less flexibility compared to software VPN. Next, I'll introduce AWS Direct Connect. Direct Connect is a dedicated connection service. It connects your customer router to Direct Connect router using the fiber optic cable. And this allows you to connect the AWS without using an internet service provider, providing the private and the dedicated connections. The Direct Connect offers two types of connection, the dedicated connection and the hosted connections. A dedicated connection uses the physical Ethernet associated with a single account. The supported port speeds are shown here. A hosted connection are operated by the AWS Direct Connect partner. The Direct Connect partners include, for example, the telecom companies like the AT&T, Verizon, and NTT. You can select the port speed depending on the partner. I will introduce the redundancy architecture using the VPN and Direct Connect. You can use a VPN as a backup for Direct Connect. And if the Direct Connect connection fails, the VPN will serve as a fallback. It's expensive to establish two Direct Connect connections, so to use the Direct Connection primarily, with a VPN as a backup in case of failure. And it recommends to set the speed as close as possible during the normal and failover conditions. For example, configure the VPN to handle 1.25 Gbps and the Direct Connect to handle the 1 Gbps. You can choose the level of resilience for your direct connect connections. You can choose from the maximum resilience, the high resilience, and the development and testing. The maximum resilience duplicates your direct connect across the multiple locations and also within the single location. The high resilience duplicates across the multiple locations but not within the single location. And the development and testing does not provide redundancy between the locations. To use Direct Connect, you need to create the virtual interfaces, the VIF. And these are three types of virtual interfaces, the private, the public, and the transit virtual interfaces. The private virtual interface allows for the connection via the private IP address. The public virtual interface is used for accessing the public AWS services such as S3 and EC2. And a transit virtual interface is associated with a transit gateway through a direct connect gateway. The public VIF connects the public endpoint, which poses the security risk. It also provides access via public endpoint, which means it can be subject to network congestion and the effort of users' traffic. The transit gateway serves as the central hub that simplifies the management and of the multiple connections, making of the transit VIF the straightforward solution for connectivity. The public IP address is supported only by public VIF. Additionally, you can connect to the multiple VPC with private VIF and the transit VIF. To connect the multiple VPC with the private VIF, you need the VPC peering. Next, I will introduce Direct Connect Gateway. The Direct Connect gateways allow users to connect multiple VPC across the different AWS regions to their on-premise network through a single gateway. By using this gateway, the network architecture is simplified, making the data transfer between regions easier. With Direct Connect Gateway, you can establish a connection across the different regions. The VPCs connected through the Direct Connect Gateway cannot communicate directly with each other. The Direct Connect Gateway is designed to connect an on-premise network to multiple VPC, but it doesn't support routing between VPC. To enable direct communication between the VPC, you need to use a transit gateway. This allows the VPC to communicate directly with each other. Additionally, since the Direct Connect Gateway can connect up to the 20 VPC, if you need to connect more than that, the Transit Gateway is also the appropriate option. And you can also connect a single Direct Connect Gateway to multiple Transit Gateway across different regions. Next, I will explain LAG. The LAG, the Link Aggregation Group, is a logical interface that aggregates the multiple connections and treats them as single connections. With LAG, you can increase the available bandwidth, achieve redundancy, and enable load balancing across the connections. The available speeds are 100 Gbps, 10 Gbps, and 1 Gbps, but all aggregated connections must have the same speed. They also use the same Direct Connect endpoint. And finally, I will explain the pricing for Direct Connect. The Direct Connect charges are based on the port hours and the data transfer. The port hours are charged at different rates depending on the bandwidth and the connection type. The billing starts either 19 days after the connection is created or when the connection between the Direct Connect endpoint and the customer router is established, whichever comes first. For data transfer with a private VIP, the charges apply to the AWS account transferring the data. For public VIP, the charges apply to the owner of the resources being accessed. And here I will introduce the Broader Gateway Protocol, BGP. The BGP is a protocol used for exchanging routing information between different networks on the Internet. It's primarily routing the protocol that makes up the entire Internet, allowing for the detailed control over the network routing. The BGP is known as the Path Vector Protocol, where each BGP speaker maintains a list of AS paths that are reachable to them. The information is exchanged with the neighboring BGP speakers. For example, the BGP speaker 1 holds a list of AS paths to connect to the AS2. The autonomous systems AS refers to the network that forms the part of the Internet. This is managed by the Internet Service Provider or corporations. AWS Direct Connect can perform the routing between the client network and AWS using the BGP. Next, I'm going to introduce CDN and Global Accelerator. Then I will introduce to the concept of the Content Delivery Network, CDN. A CDN places a cache between the client and the origin server to offload the origin and improve the response time to the client. The AWS offers the CloudFront as its CDN service. And without the cache, requests from the client are sent directly to the origin server. Then the origin server responds directly to the client. In such cases, if a large number of the requests are sent by the client, it can lead to the high load on the origin server and a slower response to the client. By strategically placing the cache, the load on the origin can be reduced and the response times can be improved. The interaction between the client and the CDN are termed as the viewer request and the viewer response, while the interaction between the CloudFront and the origin are referred to the origin's request and the origin's response. Then I will introduce the AWS Global Infrastructure, the edge locations, and the point of presence, the POPs. As of now, there are over 600 POPs, the 400 edge locations, and the 13 region edge globally. The POPs are physical locations that transfer traffic between end user and the AWS data center. By hosting the CDN service at the edge location, you can reduce latency effectively. Since the CDN services are hosted at the edge location, these are also referred to as edge location services. And this is for your reference regarding the AWS resources and their locations. For example, RDS and EC2 are deployed within the VPC. The S3, while the global service, stores its data in specific region. The services that are located in the region are referred to as the regional services. On the other hand, the CloudFront and the Route 53, which offer the globally, are referred to as the global service. So let me introduce to the Amazon CloudFront. The Amazon CloudFront is an advanced CDN service. It delivers the cached content from the global edge locations. The CloudFront offers the fast distributed delivery, the DDoS protection using the WAF, and the AWS Shield, and the reporting features. Additionally, the pricing is based on the amount of the data transferred and the number of the requests, making it as the pay-as-you-go service. In CloudFront, it's important to control caching effectively. With compressing the content, you can optimize the communication speed and reduce cost. And it's also important to set the cache retention period. If the time to live (TTL) of the cache is too long, the outdated content remains on the CloudFront even after the update at the origin, preventing the latest content from being delivered to the client. On the other hand, if the TTL is too short, it returns in a lot of requests to the origin server. A cache hit occurs when CloudFront returns cached content in response to the client request. In CloudFront, it's important to set the appropriate cache retention period based on the request types and the cache hit rate. The CloudFront charges for the data transfer, the calls to CloudFront functions, and the requests to the Lambda functions. If you configure an AWS resources at the origin, there are no data transfer charges between the CloudFront and the origin. However, if you use an external resources as origin, the data transfer charges between the CloudFront and the origin will apply. I will introduce the security features of CloudFront. The CloudFront has SSL certificate enabled by default, which encrypts the communication between the client and the CloudFront and between the CloudFront and the origin server. The CloudFront also supports WAF and AWS Shield. The AWS Shield protects your resources from DDoS attacks. For access control, the CloudFront supports restrictions based on the geographic location and IP addresses. And if the origin is S3 bucket, you can set the S3 bucket policy to allow the request only from the OAI. If the origin is an ALV, you can configure it to allow the request only when a specific HTTP header is included. Now I will explain the detailed settings on the next page. The CloudFront also supports the signed URL and signed cookies. So I will explain how to control access when S3 bucket are the origin. And here is a sample S3 bucket policy that allows a request from an origin access identity OAI. And you set the principal to the OAI. Here, the OAI, your identity ID, will be the ID of the OAI. And this setup means only users with the CloudFront OAI can access the content in the S3 bucket, and it prevents the direct access to the data in the S3 bucket from outside sources. By routing all traffic through the CloudFront, it improves the security. So next, let's look at the example where the origin is application load balancer. The routing is possible only when the request includes a specified HTTP header. In this example, the requests are routed to the target group 1 only if they contain a custom header named X custom header with the value header value. Conversely, the requests that do not include this custom header cannot be routed to the target group. Next, I will introduce signed URL. The signed URL are used to grant access to specific users only. And here is an example of the signed URL. A signed URL consists of the CloudFront distribution, the file path, the expiration parameter, the signature parameter, and the key pair. As I mentioned in the S3 chapter, signed URL includes the expiration. and once the expiration is reached, the URL becomes invalid. Next, I will introduce the signed cookies. The signed cookies are evaluated as the CloudFront edge locations. Using the signed cookies, you can access private content only if the cookie is valid, and it's associated with the specific URL. The signed cookies include a key pair, a signature, and policy. The policy can specify the URL, the end expiration, and even a range of IP addresses. Next, I will introduce edge functions. The edge functions run at edge locations. With edge functions, you can customize how CloudFront distributes and handles HTTP requests and responses. The edge function performs actions on requests and responses passing through the CloudFront. For example, you can write code for basic authentication and authorization, or to generate HTTP responses. The purpose of the CloudFront is to reduce the load on the origin server. So, by executing the process at the CloudFront instead of origin, you can further reduce the load on the origin server. There are two types of edge functions, the CloudFront functions and the Lambda at edge. The CloudFront functions support JavaScript, while the Lambda at edge supports the Node.js and Python. Generally, the CloudFront functions are used for the simpler task, while a Lambda is used for more complex process. The CloudFront function typically handles the request coming from the viewers, and the Lambda at edge can handle the wider range of use cases, serving both viewers and the origin. And compared to regular Lambda functions, the Lambda at edge functions have shorter execution times and require less storages. And this means that Lambda at edge has less processing power than regular Lambda functions. And this is a sample of Lambda at edge. And this is sample trigger user authentication for the viewer request event. The request is executed only if the authentication header is correct. The AWS Global Accelerator is a service that improves network latency by utilizing the AWS Global Network. The Global Accelerator can improve network performance by up to 60%. By using the edge locations, you can access AWS network from the closer locations, and this reduces the number of network hops and results in the communication with lower latency. When you create a global accelerator, the two static IP addresses are assigned. You can connect without being aware of the endpoint simply by accessing the specified IP addresses. The Global Accelerator and the CloudFront are sometimes compared because they are released around the same time. Both Global Accelerator and the CloudFront utilize the AWS Global Network. The CloudFront is a CDN service that delivers a cached content from the edge locations and supports HTTP and HTTPS traffic. It allows many services, not only AWS, to be set as origins. The Global Accelerator uses AWS Global Network to reduce the number of network hops, which improves the network performance. It's a service that controls traffic but doesn't have the caching capability. And you can specify NLB, ALB, EC2, or EIP as endpoint. You can also define endpoint groups, which includes one or more endpoints. Next, I'm going to introduce Route 53. And first, I will explain the general functions of DNS, the Domain Name System. The DNS is responsible for matching domain names with IP addresses. Since IP addresses are numerical information, it's difficult for you to recognize. Then, domain names are used to access the specific resources or website. DNS responds to the client queries with the corresponding IP addresses. A DNS client sends a request to a DNS server to convert a domain name into IP addresses. A caching DNS server speeds up the response time by sorting these queries. If the caching DNS server already has the answer to the query, it returns to the IP address directory. If not, it will query a higher level DNS server. And the authoritative DNS server holds the final record for domain. And forwarder is a DNS server that transfers query to the other DNS server. The DNS queries are recursible, which means that the DNS client asks the DNS resolver for a complete answer. The resolver will repeatedly query the other DNS services until it finds the requested DNS record in response to the client request. And these are the records used by Route 53. In particular, an alias record and the AWS specific record type that can be mapped to AWS resources. When the IP address of AWS resource changes, the DNS is automatically updated. Amazon Route 53 is a DNS service. It offers a domain resolution, DNS routing, and health checking capability. And not only them, but it also offers a lot of functions such as the policy-based routing beyond ordinary DNS services. A Route 53 is an edge location service that provides a high availability and performance. I will explain how DNS queries are resolved in Route 53. First, the end user types the domain name www.example.com into their browser. The user's computer queries a DNS resolver to convert the domain name into an IP address. The DNS resolver starts by querying the DNS root name server, requesting the information about the .com top-level domain. The domain names consist of the several parts, with .com being the highest level in this example. The name resolution occurs in the order from the highest level domain, such as .com, .co.jp, or .organizations. The root name server directs to the top-level domain name server, which in case manages the .com domain. The top-level domain name server further forwards the query to the Route 53 name server, specifically to the servers managing the example.com domain. The Route 53 name server returns the IP address, the 192.0.2.44 for requested domain name www.example.com to the DNS resolver. The DNS resolver then sends this IP address back to the end user's computer. Then the user browser uses this IP address to connect to the web server. The Route 53 offers several routing policies. The simple routing policy, it maps IP address directly to the domain names on one-to-one basis. The failover routing policy, in an active-passive setup, this policy routes traffic to a solely server's IP address in the event of failure. A geolocation routing policy routes traffic based on the user's location. And the geoproximity routing policy directs the traffic to the nearest server when multiple servers are distributed across the various locations. The latency routing policy routes traffic to the location with the lowest latency. The IP-based routing policy routes traffic based on the IP addresses and user's location. The multi-value answer routing policy accesses servers almost randomly when multiple servers are distributed, and this is typically used for load balancing. As for weighted routing policy, it determines routing frequency based on the specified weight or time proportions. And these policies are often appeared on the exam test, so please keep them in mind. And geolocation routing and geoproximity routing are similar but have the slight difference in use case and settings. On the left, geolocation routing routes traffic based on the user's location. For example, the users in Tokyo are directed to resources in the Tokyo region, while users in America are directed to the resource in the North Virginia regions. There are also use cases like restricting the access to Tokyo-specific resources only to the users from Japan, and routing access from the abroad to solely server. The geoproximity routing considers the location of both the client and the resources when the routing. It routes traffic based on the proximity, meaning it directs the client to the nearest available resources. And you can improve the security with the routing policy. The multi-value answer routing policy allowed Route 53 respond to DNS query using up to 8 randomly selected healthy records. The policy doesn't return IP address that fail health checks, which ensures that routing is only to resources that are functioning correctly, thus improving the security and availability. The geolocation routing policy routes traffic based on the user's location. It can block access from the outside the service region, thereby preventing the unauthorized access and the potential attacks from the outside the service area. And finally, I will introduce the Route 53 resolver. Route 53 resolver resolves DNS query within a VPC. It also functions as a forwarder, transferring the DNS query to name servers. For publicly available domains on the Internet, it performs the recursive query to the public name servers. You can configure hybrid DNS access with on-premise site by setting up inbound endpoint and outbound endpoint and outbound rules. The inbound endpoint allows DNS query from outside network to the Route 53 private hosted zone. The outbound endpoint enables DNS query from the VPC to other network. And this image shows the placement of DNS server in the hybrid environment. It resolves the query from AWS to on-premise name server across 2 availability zones for redundancy. Lastly, I'm going to introduce Load Balancer. Elastic Load Balancing is a service that distributes incoming traffic across multiple EC2 instances. It includes the health check feature that directs the traffic only to the healthy instances. With Load Balancer, you can switch EC2 instances without changing DNS settings, and this makes it appear as if there is only one instance from an external perspective. Currently, there are 3 types of Elastic Load Balancer: Application Load Balancer, Network Load Balancer, and Gateway Load Balancer. Now that EC2 classic network are out of date, it recommends to use Application Load Balancer, Network Load Balancer, and Gateway Load Balancer. The ALB works at layer 7, the application layer. It's used to control HTTP traffic and provide several security features. The NLB operates at layer 4, the networking layer. It's a high-performance load balancer and doesn't require pre-warming. The GWLB is primarily used with third-party intrusion detection systems. There are 2 key components in configuring the ELB: the listeners and target groups. A listener checks and received traffic at the load balancer. You can specify the protocol and the port in the listener, and set rules and actions. For example, you can configure it to forward to traffic from the specific source IP address to the target and respond with an error to other traffic. Then you can set multiple listeners on the single load balancer. The targets can include EC2 instances, ECS, IP addresses, or Lambda functions. You can also configure the health checks and the routing algorithms. Now I will introduce the security features of Elastic Load Balancer. The ALB works at the application layer, while NLB and the GWLB operate at the transport layer, which means they support different features. The ALB supports encryption through SSL, enabling the HTTPS communications. You can install SSL certificate from ACM or one you've obtained yourself onto the ALB. However, if you want to encrypt communication between the ALB and EC2, you need to install an SSL certificate on the EC2 instance. And since NLB and GWLB operate at the transport layer, they do not understand HTTP traffic and do not support SSL certificate. For DDoS protection, AWS Shield standard is automatically applied to all load balancers. ALB also supports a Web Application Firewall, WAF. And regarding the access log, all load balancers can automatically store logs in S3. However, the storage is not enabled by default, so you must manually activate it. Next, I will introduce some network-related features. The sticky session continues to process sessions from same user in the same EC2 instance. They are used when cookies are set and the temporary data within the same instances need to be accessed. The sticky sessions are supported only by ALB. The cross-zone load balancing is enabled by default on ALB, and you can manually enable it on NLB, but it's not supported on GWLB. And NLB offers very high network performance. It doesn't require warming up, and it can handle sudden traffic. The NLB has fixed IP in specific availability zones, meaning it supports static IP addresses. On the other hand, ALB loads traffic via DNS, and its IP addresses change dynamically. And if you want to fix IP address of ALB, it recommends to place a global accelerator in front of ALB and attach a fixed IP address to the global accelerator. For example, by fixing the IP address of the ALB, you can control the access through a firewall based on the IP addresses. And for reference, since NLB operates at the transport layer and doesn't access the application level information, it's important to understand that the placing the NLB in front of ALB may not fully leverage the capabilities of NLB. Next, I will introduce the health checks. As I mentioned the EC2 health checks, the ELB health check is the TCP three-way handshakes or HTTP status check. And this is a summary of the health check features of ELB and Route 53. While Route 53 provides a health check for any resources, both inside and outside of AWS, the ELB performs health check only on the registered instances. The Route 53 conducts the health checks based on the request timeouts and the failure rate. On the other hand, ELB performs health checks based on the HTTP code, the response timeout, and HTTP responses. And for cost, the Route 53 charges per health check, whereas there are no additional charges for health checks with ELB. Additionally, Route 53 managed DNS failover. You can also use Route 53 in conjunction with ELB. Next, I'm going to introduce database. The first, I'm going to introduce overview of the AWS database service. Let me introduce the types of database. The conventional table type database are called RDB or relational database, and are generally known as Oracle or MySQL. A relatively new type of data format is called a non-relational or NoSQL. The NoSQL includes a service such as key value, a document, and the graph types. And here is a list of databases provided by AWS. Aurora, RDS, and Redshift as the relational database, the DynamoDB as NoSQL, the Elastic Cache and the MemoryDB as in-memory databases, and DocumentDB is a document-oriented databases, and so on. So I will describe the general benefits of migrating your database from on-premise to AWS. The AWS databases offer the free managed support for patching server, the operating systems, and database management systems, as well as backups and snapshot. In other words, you don't have to manage the infrastructure and server. For example, on-premise, when a large number of requests are sent, that you must manually build more servers, and this requires a lot of overhead, but in AWS, you don't have to worry about it. Then also, it takes a lot of time to update the version of the database management system. In terms of to minimize the management overhead, the AWS has an advantage over on-premise. With AWS, you can easily create the high availability architecture. Imagine having a physical server in the multiple locations on-premise. It requires the management overhead. With AWS, you can build a master and replica or a master and standby server with just a few clicks. If a failure occurs on the master, the standby server is automatically promoted to the master server. AWS also supports synchronous replication and automatic failover. In terms of the performance, AWS database services support read replica. You can create a read replica across regions. In addition, it integrates with the reporting and monitoring tools such as CloudWatch, CloudTrail, and Cloud Logging. And AWS supports many security features such as encryption at rest and in transit, and access control by IAM, and the advantage of the pay-as-you-go pricing. So let me introduce database services one by one. The first one is Amazon RDS, the relational database service. I'm going to introduce the elements of RDS. The RDS offer multiple instance types like other computing services. And here is an example of RDS instance type notation. The notation is almost the same as for EC2 instances. And this table shows the instance family of RDS. The instance families are categorized into general purpose and memory optimized types. You can choose the processor as options. You can also choose your instance size. Generally, the larger the size, the higher the unit price is. The storage type includes a general purpose SSD, the provisioned IOPS, and the magnetic. The magnetic is HDD, then the others are SSD. The magnetic is used for legacy compatibility and is not recommended for usual use. In RDS, the storage is automatically scaled when the fee space remains below 10% for 5 minutes. Next up is RDS proxy. The RDS proxy is a free managed, high available database proxy that makes it easier to scale application by establishing a database connection pool to efficiently manage the connection to databases. The RDS proxy maintains a pool of database connection that can be shared among many application threads. This improves the application scalability by allowing a more efficient use of database connection and reducing the time and the memory overhead associated with opening and closing the connections. The RDS proxy supports IAM and VPC security group, which also improve security. You can also improve the read performance by caching the result of your queries. And this is an image of an RDS proxy. You can configure both the maximum number of connections and the connection timeout setting. If a multiple application attempts to establish connections, the RDS proxy handles these connections, result in the high performance and achieve high availability. The overall RDS proxy is designed to efficiently manage the database connections, reducing the overhead of frequently opening and closing the connections, and managing the connection lifecycle. Let's talk about the read replicas. A read replica is an instance that is replicated from the primary instance and is for read-only use. Read replicas are replicated asynchronously from the primary instance. You can create up to 5 read replicas with RDS. The read replicas are primarily used to offload application read processing. If you perform the write and the read operations simultaneously on the primary instance, the load of the primary instance becomes concentrated. Therefore, you should distribute the load by offloading the read processing to read replicas. The read replicas also asynchronously replicate the data from the primary instance, so they can be promoted to the primary instance. You can take advantage of this property and use read replicas for purposes such as disaster recovery, the migration, and the copying. I will explain some tips for read replicas. You can create read replicas in different regions. You can use read replicas for migrating to another region or for cross-region disaster recovery. A connection endpoint exists for each read replica. You can focus the connection only on the read replicas. The constraints for read replica differs by database engine. For SQL Server, it's currently available only in Enterprise Edition. Also, in the case of SQL Server, it's not possible to create a read replica in other region or multi-AZ. And for Oracle, it's only available in the Enterprise Edition. You need to use Active Data Guard to use of read replicas. Also, read replicas in mount mode cannot be read. In other words, the read replicas cannot be used for the purpose of distributing the read load, but only for disaster recovery purposes. I will explain the cost structure of RDS. The RDS costs on the pay-as-you-go basis, and which charges for instances, storage, and data transfer. I will introduce the cost element from the next page. The billing unit for instance is 1 hour. If less than 1 hour, you will be charged by 10 minutes. Additionally, you will not be charged while the instance is stopped. The larger the instance size and the higher the specs, the higher the unit price. The memory-optimized types tend to have higher unit prices than general-purpose types. The unit price also varies depending on the database engine. The Oracle is more expensive than other databases engine because it includes a license fee. In RDS, you can use reserved instances. Reserved instances offer a certain discount for long-term usage of 1 or 3 years. Also, the more you pay in advance, the bigger the discount will be. And for storage, you will be charged for the amount of storage and disk I/O. The unit price differed between the general-purpose SSD, the provisioned SSD, and the magnetic. The RDS support multi-AZ, and multi-AZ doubles the storage and therefore doubles the cost. You are also charged for the backup storage, but the unit price is lower because the backup storage is not hot storage but cold storage. When it comes to transfer, the data transfer to RDS are free and the outbound transfer are charged per gigabyte. The RDS support automatic backups, the manual snapshot, and point-in-time recovery. For auto backups, it performs backups once a day and retains for up to 35 days. You can also take a manual snapshot up to 100 at any time. The RDS also supports the point-in-time recovery. I will explain more details about backup. The retention period for automatic backup is 0 to 35 days. If you set 0 day, no backup is created. The default setting is 7 days. The first backup is a full backup, and the second and subsequent backups are differential backups. In other words, only the changes are backed up. The snapshots are stored in S3. The automatic backups are performed once a day. On the contrary, you can take a manual backup at any time. The snapshots are stored in S3, so they can be copied to another region or another account. When copying to another region, the KMS keys, the parameter group, and the option groups will not be copied. The KMS must be configured for permission at the destination region. With AWS Backup, you can specify the time instead of days, and AWS Backup offers migration automation. When restoring the snapshot, a new DB instance will be created. You cannot restore a snapshot to an existing DB instance. The connection endpoints are also newly created, so you will need to configure network settings such as DNS for new endpoint. For point-in-time recovery, the restores are performed using the transaction logs that are stored in S3 every 5 minutes. You can specify a time to perform a point-in-time recovery. The restoring from the point-in-time recovery also creates a new instance. In other words, you cannot restore a snapshot to an existing DB instance too. Next, I will introduce the monitoring of RDS. For OS-level metrics that cannot be got with the CloudWatch standard metrics, you can use extended monitoring. The extended monitoring includes the detailed OS-level metrics. For example, it includes the CPU usage, the memory usage, disk I/O, and so on. And if you want to get metrics on database performance, enable Performance Insight for RDS. The Performance Insight provides visibility into performance at the SQL level. The metrics that can be obtained with the Performance Insight include the SQL wait event and the database load. You can visualize the insight by filtering the specific period of time, so you can see which query affects performance. It can store metrics for 7 days by default and up to 2 years. Next is Amazon Aurora. The Amazon Aurora is a free managed relational database engine. It's compatible with MySQL and PostgreSQL, providing higher performance and availability at much lower cost. The Aurora is designed to be optimized for cloud environment and highly durable and fault-tolerant. The automatically replicating data across the multiple availability zones and continuously backing up data to Amazon S3. The Amazon Aurora has similar features as Amazon RDS since they both are relational database, but Aurora provides some unique features. From next pages, I'm going to introduce them. And I will introduce the architecture of Aurora. For Aurora, you can manage your instance and storage separately. You can scale computing and storage independently. The data volume are stored in 3 availability zones, 2 in each, for a total of 6, and this ensures the data redundancy. Aurora follows a quorum model, which means that only 4 out of 6 write operations and 3 out of 6 read operations will succeed. In other words, if 2 out of 6 write operations fail, the 4 successful data volume complements each other to preserve the data. In Aurora, a read and write instances is called a primary instance, and a read-only instance is called a replica. You can create up to 15 read replicas. The volume on which Aurora data is stored is called a cluster volume. The cluster volume are replicated to 3 AZs for redundancy. The unit of primary instance, replicas, and volume is called a cluster. The Aurora has endpoints for primary instance, replica, and you can set the custom endpoint. To distribute the read load, for example, when connecting to the BI tool, you had better to use the endpoint for replicas. I will explain the Aurora availability and failover. In the event of failover of the primary instances, the replica will be promoted to primary instance. In most cases, the recovery is in less than 60 seconds. In other words, in some cases, recovery may exceed 60 seconds. Recovery within the 60 seconds is best effort. If connected to a cluster endpoint, the endpoint is automatically switched during the failover, so you don't need to switch endpoint. If there are multiple replicas, you can assign recovery priority. If no priority is set or the priority is the same, the replica with the larger size will be promoted. If the new instance doesn't have the sufficient computing power and memory, the replica with sufficient capacity will be chosen because it will not be processed properly. This concept of the recovery priority is often shown up in the exam test. Normally, during the failover, there is a downtime before recovery. Then the cluster cache comes in. By enabling the cluster cache, the cache is synchronized to the replicas, reducing the downtime during the failover. The recovery time is often less than 60 seconds for Aurora, compared to 16 to 120 seconds for RDS, and less than 120 seconds for SLO. Now I will introduce the Aurora, the global database. The global database consists of the database across the multiple regions. You can have the one primary region and up to 5 secondary regions. The replication and failover between regions usually take less than 60 seconds. The global database is designed to route application requests to the region with the lowest latency. This means that when applications access the database from various global locations, they automatically connect to the nearest region in terms of the network latency. The global database enhances the fault tolerance by distributing the database across the multiple geographic regions. A similar feature to the global database is cross-region replication. With cross-region replication, you create a read-only cluster in other regions. The cross-region replication often has the higher latency compared to global databases, and it's useful for offloading, backups, and the geographical proximity. Additionally, the Aurora offers the capability of a multi-master cluster, which means you can have the multiple writable master instances. In the multi-master cluster, you can have up to 2 writable instances. The multi-master cluster are only supported with the MySQL. The multi-master may experience a lower performance compared to standard single-master clusters, especially when ensuring the right consistency across the geographically distinct instances. In addition, you can't enable backtrack feature for multi-master. The Aurora Serverless is a serverless option of Aurora, which you can use the Aurora in the serverless environment without preparing an instance. Since it's serverless, the CPU, the memory, and any other computing resources are automatically scaled. It manages the performance by increasing or decreasing the ACU, the Aurora Capacity Unit. The Aurora serverless are useful when you cannot predict the usage of a database. In addition, with Query Editor, you can execute a SQL directly from the console. Currently, there are 2 versions of serverlesses, version 1 and version 2. And version 1 has been generally available in 2018 and version 2 in 2022. The version 1 can be paused when not in use, has no cost when not in use. On the other hand, it takes longer to start up and is not suitable for applications that need to be up all the time. The version 2 has higher performance and availability. It operates at the minimum of the 0.5 ACUs, so it can be used all the time without warming up. The version 2 is more expensive. As for backups, Aurora offers more extensive backup capability than RDS. You can use the automatic backup for both RDS and Aurora. The Aurora provides a continuous backup, whereas RDS provides daily backup. The point-in-time recovery is a feature that you can recover database at any time within 5 minutes. And you can also clone your database instance, which copies the instance portion. And with Backtrack, you can rewind the database to any time within the 72 hours. The Backtrack is a feature to quickly move an Aurora database to a previous point in time without needing to restore data from the backup. With Backtrack, you can recover your database for up to 72 hours. With Backtrack, you don't have to recreate the database, and the recovery time is shorter than with backup. To backtrack a database, you may experience a temporary stop processing the database. The backtrack is supported for MySQL-compatible Aurora. It's useful for development and testing environment where changes are frequent and the potential for error is high. And it's also useful in the production for minimizing the downtime in case of errors. Next, I'm gonna introduce Amazon Redshift. I will explain the architecture, the performance, the scalability, the security, and the Redshift spectrum. The first one is architecture of Redshift. And this is an architecture of Redshift. The architecture is composed of the collection of nodes referred to as a cluster. Within a cluster, there are two types of nodes, leader node and the compute node. The leader nodes manage the query coordination, the create and the execution plan, and distribute the data among the compute node. On the other hand, compute nodes store data and execute assigned query component in parallel. Data within the compute nodes is organized into slices for processing, and the number of the slices is determined by the Redshift cluster node type. Then I will introduce the node type of Redshift. The DC, the dense compute, provides SSD-based storage and has compute-intensive performance. And it's suitable for data volume less than the 2 TB and for maximizing the query performance. The DS, the dense storage, provides the HDD-based storage and is an option for storing the large amount of data. The DS is suitable when you need to store large amount of data and want to minimize the storage cost. And for RA3, the managed storage provides the cost-effective storage by SSD to provide high performance while simultaneously storing the data on S3. The hot data will be kept on the local SSD storage, while cold data is offloaded to S3. The RA3 is ideal for scenario where a flexible storage solution is required, such as when the data is very large or data growth is unpredictable. Next, I will introduce performance of Redshift. In general, disk I/O accounts for 60 to 80% of processing time in database search operations. Therefore, the data warehouse achieves high performance by reducing the disk I/O. The Redshift uses the columnar storage, storing the table by column instead of rows. This allows data with similar characteristics to be stored in the same column, and by processing only the necessary columns, the I/O is reduced. The storing data by column also makes it easier to compress, leading to the storage savings and improved query performance. The Redshift offers 13 types of A coding for this purpose. The Redshift uses the technique called zoning. It divides data into multiple zones and improves the search efficiency by skipping the unnecessary zones based on the minimum and the maximum value in each zone. For example, the zones are determined by factors such as the date or processing patterns. To take full advantage of the zone maps, the data is sorted to enhance the search performance. In data warehouse that process big data, high-speed parallel distributed processing is used, known as MPP, the massively parallel processing. The Redshift uses a distributed system to process data in parallel across the multiple nodes and execute database queries. In an MPP system, the query tasks are broken down into smaller subtasks and distributed across the compute nodes to be processed simultaneously, and this speeds up query performance on large dataset. A Redshift supports 3 distribution styles: the key, even, and all. In Redshift, each workload is managed by a queue. Each queue has dedicated memory and a fixed number of query slots. When SQA, the Short Query Accelerator, is enabled, the Redshift uses a dedicated memory queue for the query that executes in a short period of time. This short query queue is added to the WLM queue and executed ahead of time. The SQA reduces the response time and simplifies the workload. Next is some scalability options for Redshift. The elastic resize allows you to quickly add or remove nodes in the Redshift cluster, helping you to adjust the changes in your workload. It returns to the active state faster than with cluster scaling. Unlike classic resize, you can change both node type and the number of nodes. And this is useful when you expect a workload increase and need extra capacity for a short time. The concurrency scaling handles the simultaneous processing by offloading and read query to the transient cluster. This ensures the consistent performance even when a large number of queries submitted simultaneously. And it's useful when you cannot predict when a lot of query will happen. The ROS3 instances are instance type optimized for Redshift. By using ROS3 instances, you can separate the compute from storage, which lets you adjust the size of cluster based on the compute scaling and scaling storage independently. In addition, you can use the Redshift serverless options, and this is released in 2022, and you don't need to manage any node at all. You can enjoy more flexible scaling with serverless options. The Redshift uses a shared nothing architecture. In shared nothing architecture, each node operates independently, has its own storage. Without sharing the resources with other nodes, there will be no conflict in the entire system. The opposite concept of the shared nothing is known as the shared storage. With shared storage, the cluster nodes share the storage area. While you don't have to replicate data among the nodes in shared storage architecture, and this is not cost optimal and can cause data conflict. Next, I'm going to introduce security features. Like other database services, Redshift provides encryption for the data storage, the network security with VPC, and the logging and the trail functions. Then you can control access to Redshift table, the databases, schemas, per function access control, and the per column access control for table views. In Redshift, you cannot directly encrypt an unencrypted cluster. Instead, you should create a new encrypted cluster and migrate data to new cluster. And this method is similar to Amazon EBS and Amazon EFS. To encrypt an unencrypted EBS volume, you need to create a snapshot of the volume, copy the snapshot with encryption enabled, and create a new encrypted volume from the snapshot. And if you want to encrypt an unencrypted EFS file system, create a new encrypted EFS file system and copy the data. The next and the last one is the Redshift Spectrum. The Redshift Spectrum is one of the Redshift's most important features. With Redshift Spectrum, you can execute queries directly on the data stored in S3 without any loading or ETL. Then you can work with the exabytes of data. It's the cost effective because you only pay for the query you execute. There are no initial cost or commitment. The Redshift Spectrum integrates with AWS Glue, allowing you to explore and catalog your data schemas. I will explain use cases for Redshift Spectrum. With Redshift Spectrum, you can separate your hot data from your cold data. You can optimize the cost by keeping frequently accessed data in a Redshift cluster and storing the less frequently accessed data in S3. You can also archive your infrequently accessed data with S3's lifecycle management. You can query large amount of data directly on S3 with Redshift Spectrum. It takes a lot of time to copy large amount of data from S3 to Redshift, so you can save loading time by querying the data on S3 directly from the Redshift. And you can also join dataset on Redshift and S3. Next is Amazon DynamoDB, the NoSQL database. The Amazon DynamoDB is a free managed key-value database. Like RDS and Aurora, it's one of the most popular database service by AWS. The DynamoDB is a NoSQL database that stores data as key-value pairs. The key-value database has a simple structure with keys and value of the same nature, which generally allows for the faster processing compared to relational databases. In DynamoDB, each item has a key and attribute. The key consists of the partition key and optionally a sort key. The data is distributed based on the partition key, and the items are ordered with the sort key. The attributes are fields that contain the data for the item. The DynamoDB is used in the wide range of use cases, such as content management, catalog, and user profile management. I will explain the future of DynamoDB. Since it is serverless, you don't need to manage servers, apply patches, or configure scaling. The DynamoDB has excellent scalability. When creating a table or indexes, you can specify the throughput to ensure enough resources for the stable operation. Additionally, you can adjust the disk capacity for storing the data, and storage is unlimited. Although it's NoSQL, but you can use the SQL-like query language called Particle to perform operations. And it also automatically stores data across the 3 availability zones, ensuring the high availability. I will explain DynamoDB's features by following items. Firstly, I will explain pricing plan and the capacity mode. DynamoDB's capacity mode is very unique and it will be appeared on the exam test. There are 2 types of DynamoDB capacity mode, the on-demand capacity mode and the provisioned capacity mode. In on-demand mode, the capacity is increased or decreased in response to a request. On the other hand, the provisioned mode is useful when you can estimate the amount of requests in advance. And this is a summary comparing the read and the write for each capacity mode. In on-demand mode, 1 kilobyte write operation considered 1 unit and charged at the rate per million operations. In read processing, the 1 million read with 4 kilobyte strong consistency or the 2 million read with 4 kilobyte eventual consistency are charged as 1 minute. In provisioning mode, the billing is based on the WCU, the write capacity unit, and RCU, the read capacity unit. I will introduce the calculation of the capacity unit again on the next page. And here is an example of the unit calculation. Assume that we are processing the 4 kilobyte items. A read operation with strong consistency consumes the 1 RCU. The read with eventual consistency consumes the 0.5 RCU, and the transaction processing consumes 2 RCU. The write operation consumes 4 WCUs. The transaction processing consumes double, the 8 WCU. By the way, there is no strong consistency in write operation. With the provisioning capacity mode, the WCU and the RCU can be scaled automatically. You can set the minimum and maximum usage for capacity unit. The image on the left is what it looks like when auto-scaling is disabled. The red line is the provisioned capacity unit, and the blue area is actually consumed capacity unit. If auto-scale is disabled, the extra capacity units are provisioned when the number of the capacity unit actually consumed is low. Conversely, if the amount of capacity unit consumed increases and exceeds 80% of the provisioned capacity unit, the performance is to be affected. The image on the right is what it looks like when auto-scale is enabled. You can see that as the blue area increases, the provisioned capacity unit is also increased. Conversely, as consumption decreases, the provisioned amount also decreases, which provides the necessary and sufficient capacity unit for optimal cost performance. On the other hand, it may not be able to keep up with sudden spikes in the request, so if a sudden spike is predicted, it's necessary to provision the sufficient capacity unit. Next, I will introduce the cost structure of DynamoDB. Similar to other database service, DynamoDB charges for read and write request, the data storage, and the data transfer. I will explain the DynamoDB specific cost on the next page. The backup and restore is charged for the storage per gigabyte. The point-in-time recovery is charged per gigabyte per month based on total size. There is also a per gigabyte charge for exporting to S3. The automatic backups are also charged per gigabyte per month, and the restore are also charged based on the size of data to be restored. The global table replication is charged per replicated write request. The billing unit differs between on-demand and provisioned mode. In on-demand mode, 1 million write requests are charged as one unit. In provisioned mode, the charge is based on the write capacity unit. On the other hand, the read request and the storage for global tables are billing along with the original table. This is because write process requires the processing to be consistent across the globally distributed table, while the read process reads the data from the one of the table. The change data capture is the ability to send the DynamoDB change data to Kinesis data streams or GRU Elastic View. The change data capture is charged per million change data capture unit with the maximum of the 1 kilobyte write as one change data capture unit. And DynamoDB's accelerator charges by hour per hour. The unit price depends on the instance size. The DynamoDB streams is charged per 100,000 stream read as one read request unit for each GetRecords API call. I will explain DynamoDB Accelerator and the DynamoDB streams again on later page. Next, I'm going to introduce keys and secondary indexes. In DynamoDB, the data is distributed into partitions. Actually, a partition is a storage area allocated on SSD. By distributing data evenly through the partitioning, you can improve the performance. Conversely, if the partition has some bias, it may affect the performance. Since the partition capacity management and the multi-AZ replication are managed by AWS, so you don't have to worry about them. However, you are responsible for selecting the partition keys. The sample table consists of the order ID, the product name, the price, the quantity, and the date. And we assume that the users will search for order information using the order ID as primary key. And therefore, we will set the order ID as the partition key. The data on the DynamoDB table is distributed based on the partition key. A sort key is a key for further sorting the attribute within each partition. It can be used as the composite primary key to accompany the partition key. In the same table as before, we set the order ID as the partition key and the product name as the sort key. The table will be distributed by the partition key. And furthermore, within the distributed table, the table is sorted by the sort key. You can then efficiently search for by order ID and the product name as the composite key. In DynamoDB table, the hash value generated from the partition key value determines the partition that will be distributed. It's recommended to design the partition to be random values so that access will be distributed. And if you use regular or sequential value as keys, such as date or item numbers, the accesses may be over-concentrated on certain partitions, which will affect the performance. And when specifying the partition keys, you can help balance access by sufficing or setting the random value to partition key. Next, I will introduce secondary indexes. In the key value database, you can improve the searchability within the table by adding indexes. There are two types of the secondary indexes: the local secondary index and the global secondary index. The local secondary index, or simply LSI, is an index that uses the same partition key as the main table, but allows a different sort key, and it must be created when the table is created. The global secondary index, or GSI, is an index that can use the different partition keys and the sort key from the main table. It can be created or deleted at any time after the table is created. And for key value database, it's not recommended to use index extensively, since a single primary key enhances the searchability of the database. Moreover, the heavy use of indexes affects the data capacity and cost, so if your use case requires heavy use of indexes, you should consider switching to relational database, not to use DynamoDB. The AWS best practice also recommends that only data of the same nature be placed in one table. So I will introduce the local secondary index. Then we have the table with order ID as the partition keys and the product name as sort key. And you can improve the query performance by setting the order ID as the primary key and the product name as a sort key. In this case, it is assumed that the users will frequently search using the order IDs and the product name as keys. In the local secondary index, you set a different sort key than the original sort key. The partition key remains the same. For example, if you specify the purchase date as the local index, you sort by the purchase date. In this case, it is assumed that the users will have the need to execute a query with the purchase date as the key, not just the product name. Then I will show you some tips on the setting up the local secondary indexes. The total size of the indexes in the table per partition is limited to 10 GB, and if exceeded, the item collection size limit exceeded the exception error will be returned. If the partition keys are biased, the sum indexes will become too large, resulting in the error. The partition key must be set so that there is no bias in the size of each partition. When writing, more WCUs are consumed as you write to the local secondary index. In general, it is a trade-off between the storage and performance, so you should balance between searchability and cost when setting secondary index. And you can set the local secondary indexes only when you create a table. In other words, you cannot add or delete local secondary indexes for existing table. To add a local secondary index to existing table, once make a backup and set it when restoring from the backup to new table. Next, I will introduce the global secondary index. Consider the same table as before with the order ID as the partition key and the product name as the sort key. In the global secondary index, we set a different partition key and sort key than the original partition key and sort key. In this example, we have set the product name as a new partition key and the purchasing day as the sort key. A global secondary index is beneficial when users query based on the different attributes. Unlike a local secondary index, you can set a global secondary index even after you have created a table, since a global secondary index sets a new partition key and sort key. The disadvantage of adding a secondary index includes the performance impact, the storage cost, and the read cost. As for the performance, when you make some changes to a table, you must also update the associated index, and therefore, if there are multiple secondary indexes, write costs tend to be higher. As for storage cost, having secondary indexes consume more storage. Creating the secondary index means storing another copy or subset of the data. As for read cost, reading from the secondary index consumes RCU. The secondary indexes speed up query operations that require full table scans but incur the read cost. So far, I have introduced the characteristics and the disadvantage of the secondary indexes. Actually, you need to design your indexes while taking into the account overall cost and functionality. This is because cost and functionality are trade-off. For some use cases, a relational database may be more cost-effective than DynamoDB. Next, I'm going to introduce DynamoDB streams. The DynamoDB streams is a function which captures a time-ordered sequence of the item-level changes in DynamoDB table. It stores changes for 24 hours. It captures records of the changes to items, the insert, update, and delete. The DynamoDB streams include the record and the shard ID. You can use the streams to replicate the item-level data from one table to another across AWS region. You can also analyze the data changes and feed them into other systems such as Amazon Redshift or AWS Lambda. With AWS Lambda, take some action in response to the streams in your table. With DynamoDB streams enabled, you can use global table. Next, I will introduce DynamoDB Accelerator. The DynamoDB Accelerator, or simply DAX, is a free managed in-memory cache strategy. It's designed to improve the read-intensive performance, offering the microsecond response time for accessing your data. The DAX offers an in-memory caching, which keeps frequently accessed data in RAM, making it unnecessary to access the original table. and DAGs take the write-through strategy. When you write to the table, the DAGs write both to the cache and to the DynamoDB. I will explain the behavior of DAGs. For request from the application, if there is a cache in the cache layer, the response is returned from the cache. On the other hand, if there is no cache in the cache layer, the request is forwarded to DynamoDB table. And you can set the time to live for the cache. The default is 5 minutes, and therefore you may not get the latest data of the original table. And if you request with the strong consistent read, the response is directly returned from the original table, not the DAGs. When you send the write request, the request writes to both the cache and the DynamoDB table, and this is called write-through. If both writes succeed, a success response is returned. The next one is global tables. The DynamoDB's global table lets you make copies of the table in another region. The global tables are called the multi-master, which means all the tables are for both read and write. If you change one table, all the other tables update the same way. I'm going to introduce some tips for DynamoDB global table. You need DynamoDB stream enabled to use global tables. The DynamoDB streams make sure that when you write data, it keeps the same data in all tables. You need autoscaling enabled or set on-demand capacity for writing data to use global table. All tables in different regions must have the same name, write capacity, the encryption, the time to live, and the global secondary index settings. Next, I'm going to introduce strong consistency and eventual consistency. I will explain about writing and reading in DynamoDB, as well as about the eventual consistency and strong consistency. When you send a write item request, the DynamoDB writes data to specific partitions. This data is usually replicated within 1 second across the table in 3 availability zones, and this ensures the eventual consistency among the 3 AZ. The eventual consistency means that the final result of the data is guaranteed to be consistent, but the consistency during the replication is not guaranteed. And therefore, when performing the read item, there may be some delay, meaning that the process has not been reflected in some AZ. The DynamoDB supports read request with strong consistency. When you make a read request with strong consistency, it returns the value only after all the data has been reflected, and this means that there is a possibility of an error being returned if the data is in the process of being reflected. And therefore, the read request with strong consistency tend to have higher latency compared to those with the eventual consistency. Moreover, compared to eventual consistency, there is a larger consumption of throughput. In the case of global secondary indexes, the read requests with strong consistency are not supported. I will introduce some APIs of DynamoDB. And first, I will explain the differences between query and scan. A scan is retrieve the entire table and return all the data. For example, you have a table and you want to retrieve all the users who live in New York, regardless of the user ID. In this scan operation, the DynamoDB reads through the entire user's table and filter out the item where the city is New York, potentially scanning the many items even if they don't match. And it recommends to opt for the query instead of scan in terms of performance, because The scanning all the table items can be time-consuming. If you scan, it recommends to filter only necessary data. The maximum response size for both query and scan is 1 MB. If the result exceeds the size, it will be paginated. The query is retrieving the specific item based on the condition. It returns an array of items. For example, you want to retrieve all orders from the table orders where the customer ID is AA111 and filter by a specific order date. In the query operation, the DynamoDB directly looks for an item with the customer ID of AA111 and the order ID of larger than the 2023, the 01, the 15, making it more efficient than scan because it uses the partition key to locate the specific item. In the query operation, the DynamoDB retrieves only necessary data with the keys and skip unnecessary data. It recommends to choose query instead of the scan in terms of performance because scanning all the table items can consume lots of time. If you want to use scan, it recommends to filter only necessary data. The maximum response size for both query and scan is 1 MB. If the result exceeds this size, it will be paginated. Next, I will explain the differences between batch and transactions. In DynamoDB, the batch operation is particularly useful for writing and reading the large amount of data. You can use batch write item and batch get item to execute a parallel processing. The batch processing continues until completion even if it failed. Any items that failed to write or read are recorded as unprocessed items. The transaction is also used for processing large amount of data with grouping the record. On the other hand, the transaction is based on all or nothing principle, which means that if any part of the transaction fails, the entire transaction will be rolled back and fail. You can make the entire database consistent with transaction. For example, let's take the hotel reservation system. When multiple reservation requests are sent for a room, the transaction should fail not to occur a double booking. Next, I will introduce backup for DynamoDB. The DynamoDB's backups include on-demand backup and point-in-time recovery. The on-demand backups are full backups performed at any time manually. Regardless of its size, it can be restored in seconds, so there is no performance impact. The backups remain until you explicitly delete them. The backup is saved even if the original table is deleted. The point-in-time recovery enables the continuous backup of your table, which provides the granular recovery from accidental operations. It can be saved for up to 35 days. You can retrieve and restore the transaction logs every 5 minutes. Therefore, the point in time that can be restored is from the 35 days to 5 minutes ago. The point-in-time recovery is reset once it is disabled. For both on-demand backup and point-in-time recovery, the new tables are created when you restore. In other words, you cannot restore to existing table. When restoring, you can configure secondary indexes, capacity mode, capacity unit, and encryption. Conversely, auto-scaling, the IAM policy, CloudWatch, the tags, the stream setting, and the TTL will need to be reconfigured after restoration if necessary. Lastly, I will explain security features of DynamoDB. For DynamoDB security, like any other database service, it includes IAM access control, encryption, and network isolation. And here I will introduce the things specific to DynamoDB. The DynamoDB allows access control using IAM. You can control access not only for table, but also indexes and the DynamoDB stream with unique ID. And this is an example of IAM policy allowing actions on the DynamoDB table. Usually actions on DynamoDB table are executed through API. You can control access to DynamoDB by IAM. Regarding the networking, you can use Gateway VPC endpoint. The Gateway endpoint you can use S3 and DynamoDB. And this is a summary of differences between interface endpoint and gateway endpoint. The gateway endpoint uses a routing table, so all you have to do is add an entry to the routing table. You can manage the DynamoDB with one endpoint, which simplifies the configurations. And next is Amazon Elastic Cache in-memory database. I'm going to introduce Redis and Memcache and the cost of Elastic Cache. I'm going to explain Redis and Memcache first. The Amazon Elastic Cache is a free managed in-memory database compatible with Redis and Memcache. The Redis and Memcache are open source in-memory databases. In-memory database store the data in RAM instead of the hard disks, which offer faster access speed. In-memory databases are useful for processing a large amount of unstructured data. This is a summary of the Redis and Memcache. The Redis support more data types and support availability, redundancy, and data persistence, whereas the Memcache has simpler data types and is multi-threaded, which improves the per-node performance. The Memcache is multi-threaded, so it has the advantage of being easy to scale horizontally, whereas the Redis is single-threaded. The Redis is highly fault-tolerant because it creates a read replica across the availability zone and failover in the event of failure. Redis also has data persistence, so it can also be used as the primary data store. The overall, Redis has more features than Memcache, and the Memcache is characterized by its simple structure and high performance. And here I have summarized the differences between MemoryDB and the Elastic Cache. Although MemoryDB is not covered in the Solution Architect Associate exam, it has been added to the Cloud Practitioner exam, so I will introduce it here. In terms of use case, the MemoryDB is typically used as a primary database, while Elastic Cache is mainly used for caching other databases. While there are slight differences in latency and data durability, the primary differences between the two lies in their use cases. Additionally, the MemoryDB supports clustering, which is equivalent to the enabling the cluster mode in Elastic Cache. Next, I'm going to introduce Elastic Cache for Memcache. I will introduce the architecture of Memcache. The Memcache has multiple nodes in the cluster from 1 to 20 per cluster. In the event of failure in the cluster, the nodes are automatically replaced to a healthy one. On the other hand, when you access a node, you need to select it from the list of nodes. Elastic Cache doesn't automatically manage the connections. And for example, you can get node information from the CLI by the command like this. Then you can access the appropriate node. Each node has its own endpoint, so you need to manage the connection whenever you scale in or scale out. The AWS SDK supports the Memcached client with auto-discovery, which periodically retrieves the endpoint, so you don't need to manually detect them. In contrast, the Redis in Elastic Cache can automatically manage the connection endpoint. To improve the processing performance in Elastic Cache, you need to increase the node type or scaling up. The Elastic Cache is an in-memory store and doesn't persist the data within the node, so when you create a new cluster, you only need to connect to different endpoints. Next, I'm going to introduce Elastic Cache for Redis. I will introduce the structure of Elastic Cache for Redis. The Redis consists of node groups that are made up by multiple nodes. A shard contains a primary node and replicas. The replicas are read-only. And you can set 0 to 5 replica in the shard. Redis has endpoint for each cluster, shard, and node. However, the cluster manages read and write operation to the node, so you typically use cluster endpoint. And once you connect to the cluster endpoint, it automatically determines which nodes to connect to, so you don't have to manage it. A node endpoints are often used to maintenance to each node. And you can configure cluster mode in Redis. When you disable cluster mode, it becomes the single node, and Elastic Cache has no redundancy. When you enable cluster mode, you can use the multi-node, and Elastic Cache divides your data into up to 500 nodes. The Elastic Cache has a maximum of 500 nodes when the shard has only one primary node. If we have a shard with one primary node and 5 replicas, or 6 nodes per shard, the number of the shard is 83. So 6 times the 83, you can add up to the 498 nodes. And this is a summary that shows the feature which cluster mode is enabled and disabled. By disabling the cluster mode, you can use only a single node. You can still create read replica even if you disable cluster mode. So you can promote a read replica in the failover configuration in the event of failure. The performance is limited to a single node. If cluster mode is enabled, you can create up to 500 nodes. The data is partitioned across the multiple nodes. However, because the data is partitioned across the multiple nodes, the backups and the restore tend to take longer. In terms of performance, by enabling the cluster mode, it will increase throughput due to load balancing. For larger dataset, enabling the cluster mode is a better choice. Next, I will explain scaling. If cluster mode is disabled or if you have only a single node, you will have just one primary node. In this case, to improve performance, the only option is to change node type. You have two options for applying the scaling. You can scale immediately or during the maintenance window. You can add or delete replica node using the console or CLI. If cluster mode is enabled with multiple node groups, you can scale not only vertically but also horizontally. In other words, you can add and remove the shards. With Memcached, you are required to select node yourself, whereas Redis automatically redistributes when you scale out. You don't need to worry about which nodes they connect to. I would like to introduce the global data store. For Redis, you can create clusters in different regions. You can create one primary region and up to 2 secondary regions. The primary region is used for read and write. The use case for global data stores includes the failure handling the and improving the performance through the geographic proximity. The conditions for global data store are like these. The Redis version 5.0.6 or higher is required. Also, the node version must be the R5 or M5 or higher. The global data store are available only in the open source editor of Redis. The primary and secondary have the same configuration. Additionally, the same feature may not be able on the global data store, and there may be latency in replication between the regions. And next, I'm going to introduce cost structure. The elastic cached cost element includes the price of the node, the data transfer, and the charges for backup storage. For node cost, you are charged hourly based on the instance size. The reserved nodes are available for 1 or 3 years with discount applied for upfront payment. The data transfer costs are only outbound traffic and you are charged per gigabyte. And for backup to the storage, one free snapshot is provisioned per Redis cluster. And if you take additional backups beyond the free snapshot, you are charged per gigabyte. And finally, I will introduce other database services. And these services are not tested in detail in the exam, so it's sufficient to familiarize yourself with the overview. And this is a list of other NoSQL databases that are introduced in the exam. The Amazon Document DB is a document-oriented database that is compatible with MongoDB. The Amazon Keyspace is a managed database compatible with Apache Cassandra and making it easy to deploy Cassandra in the AWS. The Amazon Neptune is a high-performance graph-oriented database service used for mapping the social media user relationship and credit data connections. The Amazon TimeStream is a time series database specialized in storing and analyzing data collected at a specific time interval. The Amazon QLDB is the distributed ledger database, notable for its data immutability and the cryptographic verifications. I'd like to introduce the MongoDB. A MongoDB is a document-based database. A document database in a JSON-like format that provides a flexible hierarchical structure. And this is a sample document, and the name and address are listed. And the address includes the street and zip. That is, the address is the parent hierarchy, and the street and zip are the children. The MongoDB also has the excellent scalability, supports rich queries, and is highly available. DocumentDB is currently compatible with the MongoDB version 3.6, 4.0, and 5.0, but you may not have the access to all features. You can use MongoDB's API and seamlessly migrate the existing MongoDB application to AWS. The document database are flexible and scalable and used in the content management system, the real-time analysis, and the mobile and web application, catalog, and more. The document databases are schemaless and flexible compared to relational database, and it's easy to scale horizontally. Compared to key-value type database, the DocumentDB have a hierarchical structure and multiple attributes. It has one entity as one document, so related data can be stored together. And here we have the sample data and the queries for DocumentDB. In the sample, the database called books contains the information such as book title and the authors. Although it contains strings and number, you don't need to define the data format in advance. Also, a single item can have multiple attributes. And we have some sample queries to define and update and remove. You can specify database items to execute flexible queries. Now I will introduce the structure of document DB. The document DB can consist of the up to 16 DB instances ranging from 0, and there is one primary instance capable of the read and write operations, and you can set up to 15 replica instances. The cluster volume can be placed across the 3 availability zones with a total of 6 copies, and this is similar to Amazon Aurora. And the maximum storage size is the 128 TB. Next, I will introduce Amazon Key Spaces. The Amazon Key Spaces allows you to run Apache Cassandra workload in the managed AWS environment. And it's compatible with version 3 of CQL and is backward compatible with version 2. Apache Cassandra is widely used as a backend for large-scale distributed applications. The key space is free managed, which means you don't need to handle patching, the backup, or disaster recovery on your own. It's scalable, so it automatically adjusts the throughput and the storage table based on the demand. With operating on AWS infrastructure, it provides a high durability and availability. Additionally, it can integrate with various AWS security services. So let's talk about the data structure of Apache Cassandra. The Apache Cassandra has a flexible data model that combines a key value store with a column-oriented data store, which is referred to as the column family structure. And in this example, the user ID is as the key, and it features as the wide column store, meaning it has an extensive column structure. Moreover, the collection of the table is known as a key space, which is where the name for Amazon Key Spaces comes from. Within the table, you have multiple key value structure nested under a primary key, which enhances the efficiency of query processing. And here user ID acts as the partition key, the grouping each record into a partition. And within each partition, you have the data structured in a key value format. Another feature of the Cassandra is that each row can have different attributes. In this example, the only user ID 102 has a phone number. Each partition can have its own structure of independent attribute. This allows for data flexibility that is unique compared to other NoSQL databases. In Cassandra, you can manipulate the data using a query language called CQL, Cassandra Query Language. The CQL will be written like a standard SQL. And here is an example of creating key spaces and a table with the CQL commands. Next, I will introduce the architecture of Cassandra. The Cassandra's node structure is called the ring repository, in which nodes are organized in the virtual ring structure. Data is distributed to specific node by hash function. Each node in the ring has hash range. For example, here is a sample ring structure with 4 nodes, A, B, C, and D, where node A is 0 to 25, node B is 26 to 50, the node C is 51 to 75, and the node D has the hash range from 76 to 100. And if the hash value generated from the data is 85, the data will be stored on node D. Additionally, the data is replicated across the multiple nodes for redundancy and data availability. For example, if data is written to node A, the same data is also copied to neighboring node B and C, and this makes Cassandra extremely scalable and fault-tolerant. And this is a simple example, but in reality, It can handle millions of simultaneous requests and replicate across hundreds to thousands of nodes. This enables large-scale request processing, such as in large-scale social media applications. However, Amazon Keyspaces is a free managed service, so you don't need to manage nodes. In Keyspace, you can set the capacity mode similar to those in DynamoDB. The on-demand capacity mode is suitable for workload where read and write traffic fluctuated. In on-demand mode, you are charged based on the resources you use. The provisioned capacity mode is better suited for workload where traffic can be predicted in advance. It also allows for the configuration for the autoscaling. In Keyspaces, the resource management is conducted using the capacity unit. For read, the Keyspaces offer both the strong consistency and eventual consistency. The eventual consistency consumes half the read request unit compared to the strong consistency. A write request unit, WRU, measures the capacity to write 1 kilobyte of the data. The pricing is a Keyspace based on the consumption of the capacity unit. Next, I'm going to introduce Amazon Neptune. Here is a sample database of Neptune. Here, for the nodes named Alice, Bob, and Charlie, the relationship between each node is represented by an edge. And these are a query sample of Gremlin and Sparkle, the syntax for graph-oriented database. And this is the structure of Neptune. The Neptune cluster are deployed within the VPC. A cluster contains multiple instances. The subnets are configured across at least 2 availability zones for redundancy. The Neptune consists of the primary node and the replica, where the primary nodes support read and write operation, and the replicas are read-only. You can add between 0 and 15 read replica. The read replica is promoted to the primary instances in the event of failure. You can set failover priority, and this rule are similar to Aurora. The replica with the lower number will be promoted to the primary instance first. If the priority are same or the no priority is specified, the one with the larger size will be promoted to the primary instance. Any replica will be promoted if it has the same priority and size. The Neptune storage automatically scales in 10 GB increment up to the 64 TB. A total of 6 data copies will be created, 2 in each of the 3 AZ. The Neptune uses a column model similar to Aurora, allowing the write even if up to 2 out of 6 data copies fail. Also, it's possible to write even if up to 3 out of 6 have errors. The next is Amazon TimeStream. The Amazon TimeStream is a managed database service for time series data. The time series data refers to the series of data, the points that change over time. It has many use cases that handle the time series data, such as collecting the telemetry data from IoT devices, analyzing the financial transaction, and monitoring the IT operation metrics. The Amazon TimeStream automatically scales up and down, corresponding to the changes in the data over time. It can collect, store, and process a lot of time series data in real time. The TimeStream has a feature to manage the data lifecycle, where the frequently accessed data is stored in memory and the older data is automatically moved to disk storage. This minimizes the storage cost. The TimeStream supports querying time series data using the SQL. It offers a lot of built-in functions for data analysis, such as the moving average and the rate of change. TimeStream can be integrated with other AWS services. For example, it can collect data from Amazon Kinesis or Amazon IoT Core. For data visualization, you can use Amazon QuickSight or Grafana with TimeStream data. And this is a summary of the differences between TimeStream and DynamoDB. The DynamoDB can also process a time series data by having a timestamp as attribute, and the TimeStream includes more optimized features. The TimeStream has been generally available in 2020. Before that, DynamoDB was used to process the time series data. The comparison is based on the data type, the performance, storage and the cost, the query language, the compatibility and integrations. The TimeStream is specialized for time series data, whereas the DynamoDB is widely used for applications that require consistent with millisecond latency. The time series data refers to the sequence of the data points arranged as the function of time. Typically, it is recorded at a regular interval, every minute, every hour, or every day. The TimeStream has function specialty designed for time series data, enabling the processing just by calling the functions. Since the time series data is acquired regularly, it allows for time-based aggregations, the time series analysis, and the calculations such as anomaly detection and the moving average. I will introduce the structure of TimeStream. The TimeStream consists of a database and a table, and each of which stores multiple time series data. The time series data consists of the set of records, each with a matrix measured by the timestamps. And the time series data is described by the metadata and the dimensions. And this is an architecture of TimeStream. Starting from the top, there is the data ingestion layer, the storage layer, and the query layer. By separating the layer, it's possible to scale independently according to the processing load of the data ingestion, storage, and the query processing. There are two types of the storage layer, in-memory and magnetic. The TimeStream guarantees 99.99% availability. The TimeStream is designed using the cellular architecture to achieve unlimited scale while guaranteeing the availability. The TimeStream scales by simply dividing it into cells. Even if a failure occurs in one cell, the processing continues in another cell, minimizing the impact. Each cell has endpoint and is seamlessly connected to the SDK and the TimeStream side. Next, let's explore Amazon QLDB. The QLDB is a free managed distributed ledger database that offers the data immutability and the cryptographic verifications. It's used in fields that need to track and verify transaction data, such as finance, manufacturing, insurance, and supply chains. The feature of QLDB includes the data immutability, which prevents the data tampering and ensures the reliability. The QLDB records the entire transaction history, providing detailed logs for each SAM, and which allows for complete traceability of how items have changes. With QLDB, you can cryptographically verify data integrity, assuring that the data has not been tampered with. It delivers high performance and low latency, enabling the quick processing of large volume data of the transactions. As a serverless service, the QLDB scales automatically, so you don't have to manage the infrastructure. Now I will introduce a component of QLDB. A ledger database consists of journal, history, and the stored data itself. The journal means a record of entity. The journal records a history of changes and it remains immutable. Once you make changes, they cannot be modified or deleted. The journal maintains a history of data changes with indexing, allowing history to be referred to through the SQL queries. The QLDB maintains near real-time values, which means that once the journal is committed, it can be streamed to Kinesis data streams. And this allows for almost real-time integration with other AWS data stores. And this is a summary of the differences between the blockchain, the distributed ledger, and the QLDB. The QLDB differs from the typical distributed ledger technology as it operates under centrally managed by AWS. Unlike blockchain and the distributed ledger that don't require central management and transactions through a peer-to-peer way, the QLDB centralized around AWS, offering the transaction verification, asset property, and a higher performance compared to distributed ledger technology. Next, I will explain data verification process of QLDB. The QLDB's immutability is achieved using the SHA-256 cryptographic hash functions. The QLDB creates a new hash combines the hash of each block with the previous block's hash. This change ensures that if anyone tries to make changes to a part of the transaction, it will cause a cascading mismatch in hashes, then it can detect the changes. The SHA-256 produces a fixed length hash value from any given data. The same input always generates the same hash value, and the different input generates different hash values. The data validation is performed by getting the ledger's digest and the block address, and then combine these with the retrieved digest. You can get and verify the digest through the console or SDK. You can get the latest blockchain digest for the target ledger. By comparing the digest, you can verify the ledger's immutability. If there is any discrepancy between the hash value, thereby indicating the compromise. Next, I'm going to introduce application integration. In this chapter, I'm going to explain API services, the messaging services, the workflow, the front end, and the web and mobile application. The first three, I'm going to introduce API Gateway and AppSync. Amazon API Gateway is a service that acts as an interface for web application. It's a free managed service that makes it easy to create, secure, publish, and monitor APIs. The API Gateway supports HTTP APIs, the REST APIs, and WebSocket APIs. API Gateway receives events from the client and creates requests for the API. It's often used with Lambda, which sends requests to API Gateway to be transferred to AWS resources. I will introduce the component of API Gateway. The API Gateway is associated with endpoint. Through these endpoints, the client can access API resources. The endpoints are created for each stage. The stages are used to separate environment, like development and production. And you can set quotas for each stage by combining the usage plans with the stage. And there are three types of endpoint. The edge-optimized API endpoints route through the global edge locations, making them useful for users around the world. The regional API endpoints are useful when users are concentrated in a specific region. The private API endpoints are used when accessing the API from the specific VPC. Next, I will explain some metrics of API gateway. The throttling is the maximum number of the request API gateway can handle. If this limit is exceeded, the request will be throttled. The throttling means controlling a request when they exceed the threshold. By default, the throttling is set to the 10,000 requests per region, but you can apply to increase this limit. You can also set quotas for each API key. Additionally, you can track metrics like error rate and latency. With monitoring these metrics, you can adjust your architecture design. Now I will explain how to integrate the front end with the back end. The Lambda is the most commonly used integration. A Lambda function handles the request from the client and sends them to the backend. It also returns the response from the backend to API gateway. The HTTP integration is used when the backend is based on HTTP. The private integration is used to send the request to HTTP resources inside the VPC. The mock integration doesn't connect to an actual backend resource. Instead, it returns a fixed response and is mainly used for testing. In API Gateway, you can customize the mapping definitions. If the request format is different, you can customize the mapping template to convert it into formats that the resource can accept. And this is an architecture where the client sends data through API Gateway and Lambda to write into DynamoDB. Then you can convert the query parameter into JSON to write into DynamoDB. Similarly, you can convert the response from JSON to XML. And here are the setup steps for API Gateway. The first, select the type of API Gateway. You can choose from the HTTP API, WebSocket API, or REST API. Next, specify the API name and endpoint type. And for the API method, you can use the common method like the one listed here. Then you can also set the integration type. A typical service to integrate with API Gateway is Lambda, which can handle the request it receives. Before deploying, you can run a test by specifying the query strings for the API. And finally, when you deploy, an endpoint URL is generated. I will introduce the usage plans. A usage plan sets the number of requests and the throttling limit for each API key. It is used to give different access levels to multiple applications. For example, you can allow free plan users to make 1,000 API calls per month, while pet plan users can make 10,000 calls. This helps prevent excessive use of the resources and maintain preset usage level. Now I will talk about improving the performance in API Gateway. And you can improve performance by enabling the caching. And this allows API Gateway to reuse responses from the backend for the same request. And this reduces latency and offload on the backend. And however, you will be charged based on the caching capacity. The API Gateway supports encoding, which compress the data size and reduce latency during the data transfer, and it automatically compresses response payload using gzip. Next, I will introduce the security feature of API Gateway. That you can install the client certificate in API Gateway, and not only that, you can also create and verify this certificate. Additionally, you can set resource-based policies. The authentication method in API Gateway includes the IAM, the Cognito authorizer, and the Lambda authorizer. you can restrict the execution role of API to specific IAM user. With the Cognito authorizer, the client includes a token obtained through the sign-in via the Cognito user pool in the authentication header when making the request to API gateway. The Lambda authenticator allowed for the customer authentication or the use of third-party authentication. The pricing is based on the number of API calls received and the amount of data transferred. There are no charges for data transfer with private APIs. To understand how API Gateway works, I will explain serverless architecture using API Gateway, Lambda, and DynamoDB. For example, assume we are building a book-selling application. Through this app, you can add and get information on books in the database. First, the client application input data for a new book. The application converts the data format and sends it as a POST request to the API Gateway. API Gateway receives the request and routes it into the Lambda functions. The Lambda function passes the JSON data from the request and creates a new record in DynamoDB. The first client will create a JSON file. The book information includes an ID, which is considered as the primary key, and the book title, the author, the genre, and the price. And there is an empty table in DynamoDB at initial state. The client will send a POST request and the API Gateway received it, and this includes the endpoint of the API Gateway. The JSON object also includes the request body. And once the request is sent, it will route to DynamoDB from the Lambda function, and the data is written into the DynamoDB. Next, assume we will get information about a book from DynamoDB. The client will get information about a specific book through the application. The application sends the book ID to the API Gateway as a GET request. Upon receiving this request, API Gateway routes it to the appropriate Lambda functions. The Lambda function passes the book ID from the request and fetches the book record from DynamoDB. And finally, the data is returned to the client via the API Gateway. The client will send a GET request to the get the information with the book/the get/123. It means the get data with the ID of 123 from the DynamoDB table named the books. Once DynamoDB receives the request, it sends the response back to the client. Now I will explain the security feature of the API Gateway. It's a common practice to include the security token in the request. This allows the server to associate each request with the appropriate client. And this is an example of HTTP request with API token. The API Gateway is highly scalable. When a large number of requests are sent from the client, normally the 429 error is returned, but API Gateway automatically scales to handle the request. The API Gateway has maximum processing count called the throttling. By default, it can handle 10,000 request rate per second and a burst of 50,000 requests. Moreover, you can increase this throttle count. And here I will introduce the exponential backup. The exponential backup is used to handle the throttling of API requests. When throttling error occurs, it's designed to automatically retry sending requests from the application to the server. The SDK natively includes the exponential backup as its retry logic, so you don't need to manage the retry logic yourself. exponential backup works by waiting a certain amount of time after detecting an error before sending the request. If an error is detected again, it increases the wait time before resending, and this helps to reduce the unnecessary request as much as possible. Then I will also introduce the definition of API. The API, or Application Programming Interface, that refers to the exposing the part of the application to the Internet, which is shared with third-party applications. By using API, you can eliminate the developing the application from scratch, which leads to cost reductions. In addition, API can enhance security and enable retrieval of the latest data from external applications. Additionally, I will introduce REST. The REST is a set of design principles suitable for coordinating the multiple software components in distributed system. It has the characteristic listed here. The API gateway supports not only HTTP API, but also REST API. Next, I'm going to introduce AWS AppSync. The AWS AppSync is a free managed GraphQL service. It centrally manages the access to data, manipulation, and real-time update from the applications. A key feature of AppSync is that you can use GraphQL on AWS. While API Gateway offers less than the HTTP API, the GraphQL offers an API with more detailed data definitions. The GraphQL supports real-time data synchronization and the offline operate. It also supports offline operations. It can be integrated with other AWS services. Additionally, it supports security features like IAM and Cognito. Then I will introduce GraphQL. The GraphQL is an open-source data query and manipulation language developed by Facebook. Compared to traditional REST APIs, you can manage more detailed format of the data. On the next page, I will explain the process flow. So I will demonstrate using a sample flow of API with AppSync. In here, I will explain the process using a real-time live score application as an example. First, we define the mutation to receive a score update from the media and the subscription to get the update in real time. The client sends a query using the GraphQL subscription to get the score update. Through AppSync's GraphQL resolver, the data is sent to DynamoDB. The game score is then stored in the DynamoDB. And this is a sample of a mutation for accepting the score update from the media and the subscription to receiving the update in real time. And in this schema, we use the mutation called the update score to update the score. Then we use the subscription called the store update to subscript to score update in real time. A mutation refers to the changes in data, including operations like creation, update, and definitions. And this is equivalent to the post, put, and delete method in RESTful API. And next, here is an example of GraphQL subscription query that the client sends to subscribe to the score update. And this query instructs the server to send the updated game's ID and the score when the score of the game with ID 1 is updated. Finally, we send the data to DynamoDB through GraphQL resolver. The GraphQL resolver fetches data in response to the client query. When the update score mutation is invoked, it creates an item in the DynamoDB, the table named Game Table. The item's game ID is obtained from the mutation. The GraphQL resolver receives the data from the multiple sources and storing it in the DynamoDB. Also, the code here is a sample of AppSync to the VTL language, and you can make the similar code using the Lambda. So that's all for the process of the AppSync and the GraphQL. And next is Amazon MQ. The Amazon MQ is a message queuing service. It's based on the Apache MQ and the RabbitMQ and support protocol like JMS and MQTT. For reference, the JMS stands for the Java Message Service and MQTT stands for Message Queuing Telemetry Transport. They both are protocols for message queues. And this is a comparison for SQS and MQ. The SQS is a service developed by AWS. So when deploying the system on AWS, usually SQS is a suitable option. On the other hand, when migrating from on-premise to AWS, the MQ might be used for compatibility. After migrating, it's recommended to switch from MQ to SQS because it's a free managed and AWS native service. Next, I'm going to introduce messaging services. Firstly, let me introduce monolithic architecture and Microsoft architecture. In a monolithic architecture, systems are tightly coupled and run as a single service. Therefore, if any one of the systems spikes, the entire architecture must be scaled. Because of the high interdependency, there is a risk that a single failure affects the entire system. In a monolithic architecture, the systems are built as an independent component. Each component executes the independent process as a single service. Therefore, each service can be updated, deployed, and scaled with the minimal impact on the entire system. Recently, it's trend in the shift from the monolithic architecture to microservices. The Amazon SQS is a free managed message queue service. It is the oldest service released before AWS was founded. The SQS is used for loosely coupled and asynchronous connection between the systems, such as microservices. If a producer sends a large number of messages to a consumer, the consumer may not be able to process the messages, and it may overload the system. Therefore, by queuing for the messages, the process can be offloaded. The SQS is the most important in integrating the applications. SQS is used for the loosely coupled and the asynchronous connection and offloading. It can also be used with Lambda to set a threshold on the number of the queues and trigger event when the thresholds are exceeded. From this page, I'm going to explain how to manage the queues. And here is a summary between standard queue and the FIFO queue. For sequentially of the messages, the standard queue offers the best effort ordering. In other words, sometimes the message cannot be delivered in an order. The FIFO queue offers the guaranteed ordering. The messages are delivered in the exact order. And for delivery, the standard queue supports at least once delivery, but there is a possibility of duplicate messages. The FIFO supports exactly once delivery. It ensures no duplicate. For throughput, the standard queue supports unlimited number of transactions. The FIFO supports up to the 3,000 messages per second. The standard queue is widely used for the application where message order and duplicate are not important, and use case of FIFO is where the order is critical and no duplicates are allowed. Next, I'm going to introduce message polling. There are two types of polling, short polling and long polling. The short polling returns the message immediately even if the queue is empty. The long polling waits for a message to become available for some time, up to maximum of 20 seconds. And for response time, the short polling returns message immediately, and the long polling is slower. The short polling may increase the network traffic due to frequent empty responses. The long polling decreases the network traffic by reducing the number of unnecessary responses. A short polling has the advantage of its simplicity, but is disadvantage of lower network efficiency. The short polling is set up by default, and if you set long polling, you need to specify wait time seconds. The short polling is suitable for scenario where the immediate response is required, even if it results in the empty responses. And long polling is useful for the queues with the low message volume, or for cost saving in the scenario where the immediate response is not a top priority. Next, the visibility timeout is the duration that the message remains invisible to other consumer after a queue has been polled. And this means that once a message is retrieved, it is not immediately removed from the queue, but is hidden for a specified period. During this time, the other consumers cannot receive the message. The message is to proceed only after the receiving consumer has finished processing it. The visibility timeout can be configured from 30 seconds up to 12 hours. The use case of visibility timeout is to provide a buffer for reprocessing the messages in the event of failure, and this allows the consumer to process the message again. And it also prevents a duplicate message delivery, where there is connection failure, as the message will remain invisible to other consumer for the duration of the visibility timeout. Next, a delay queue has a delay period for message. And this delay period is the amount of time between the message is sent to the queue and when it becomes visible to the consumer. The use case for delay queue is where the application on the user side requires time to process messages before new ones are received. Additionally, in situations where a certain message should be processed in a specific order, ensuring that some messages are not processed before others. And this is an image of the differences between the delay queue and the visibility timeout. When a message is sent with a delay queue setting, it is added to the queue immediately. If a delay queue is set, the message sent during this period will not be returned even if a certain request is made, meaning during this time, the messages are invisible to the other consumers. With the visibility timeout, the message will not be returned only during the period of visibility timeout is set, and even if a receive request is made by the consumer. The conversely, and before and after the visibility timeout period, the consumer can receive a message. At the first glance, the delay queue and the visibility timeout may seem offer the similar functionality, so I will explain the differences between them on the next 2 pages. The delay queue controls when a message is first received. In contrast, visibility timeout controls when a message, once received, becomes visible to other consumers. For example, if there are multiple consumers, the visibility timeout is designed to prevent the message from being retrieved again by other consumers while it is still being processed. The dead letter queue is a queue to get the message that failed to be processed to the source queue. The example use case of dead letter queue is to move another queue when limit of visibility timeout is exceeded, and isolate the problematic message to investigate the cause, accumulated message during the failover. This is just for your reference. I will introduce some of the typical APIs for SQS. The operation on the SQS can broadly be classified into actions on the queue themselves and actions on the message within those queues. Additionally, it is possible to perform operations on the attributes of the queue. Next, let's discuss Amazon SNS. The Amazon SNS is an event-driven messaging notification service. With SNS, you can push low-volume messages such as mobile push notification to a large number of subscribers. It's primarily used for mobile push notification, the fan-out messaging, the system alert, and sending email or text messages. SNS is typically used for simple text message in a one-way direction. It is not suited for rich text or bidirectional interactions. For a wide range of applications, it supports various protocols and can integrate with many AWS services. The pricing is pay-as-you-go basis, and it is cost-effective when sending a large volume of topics. SNS is used for pushing notifications to millions of users or monitoring a large number of IoT devices. In SNS, the party sending the message is called the publisher, and the party receiving them is called the subscriber. Please note the differences from SQS, where the term uses the producer and the consumer. One of the use cases for SNS is fan-out. The fan-out suggests spreading out in the fan shape, and this allows one message to be pushed to multiple subscribers and processed in the parallel. And it is useful when you want to trigger a single message to write to multiple database tables simultaneously. Then I will introduce some basic features of SNS. With filter policies, you can filter messages. The filtering is possible for each subscription. The messages are pushed only if their attributes match their filter criteria. Additionally, you can set the topic policies. Like IAM policy, the topic policy can be written in JSON format, and these are in the same format as SQS queue policy. And also for your reference, I have listed some of the typical APIs of the SNS here. The SNS uses the publisher and the subscriber model, while SQS uses the producer and the consumer model. In the publisher-subscriber model, it delivers messages on the one-to-many basis, where a message is distributed to multiple subscribers at once. This is useful for message distribution or when many components need to update simultaneously. In the producer-consumer model, the messages are generally delivered on a one-to-one basis, and the consumer actively retrieves the message. And this is useful for when message needs to be processed in the sequence or asynchronously. Additionally, the term "the message" does not necessarily refer to the content like email, but is often used as a trigger to start applications. Next, I will introduce Amazon Simple Email Service or SES. Although SES is not included in the Solution Architect Associate exam, it's often compared with SNS and Amazon Pinpoint, so I'll introduce it for your reference. The SES is a service that sends and receives email using SMTP, the Simple Mail Transfer Protocol. It's for various email protocols and is commonly used for sending the marketing campaign using template. With SES, you can send a templated email, and it provides a record of successful delivers and rejections. And it also supports SPF and DKIM, ensuring the security. For received email, SES supports security features such as the virus and malware detection, and it can store received email in the S3. And you can send email from the console via API or through an SMTP interface. The console is mainly used for the testing purposes, while you can automate email sending via API or interfaces. And this is the summary differences between SES and SNS. SES specializes in sending and receiving email, while you can specify email addresses as target in SNS. It is generally used as one-way notification. Next, Amazon Pinpoint is a multi-channel communication tool that uses the SMS, email, the push notification, and voice. It enables the large-scale customer communication across all channels. It allows you to segment the customer list by attribute and preferences, and send a tailored message to each segment. Additionally, you can analyze whether messages are read by tracking the open rate. The pricing varies by channel, and it's set on the per message basis. And this is a summary of the differences between SES and the Pinpoint. Compared to SES, the Pinpoint is designed for targeting the communication at a larger scale, while SES allows sending up to 50 emails at once. The Pinpoint can send over 10,000 emails. Additionally, the Pinpoint provides the capability to analyze open rate. However, the Pinpoint does not have the receiving function. It's suitable for one-way communications. Next, I'm going to introduce workflow services. The AWS Step Functions is a state machine service designed for workflows for distributed applications and microservices. It visualizes each service as a component within the workflow. By combining it with the serverless services, you can build a flexible workflow. It makes the microservices loosely coupled, which enable independent scaling. While SQS is useful for serial workflow in the process of decoupling, the step function can be utilized for parallel workflow as well. And this is a sample state machine. It's possible to build a complex workflow, including the parallel processing through the conditional branching. Now I will explain the component of a step function. The activity worker is a component that executes a specific task. It is the piece of code that works with a task. And activity state is to delegate the specific task to activate the worker. It's a way to represent a unit work to be performed. And these are the type of activity state. The wait state means a waiting period. In this state, the process waits until the specified time, and it is often used when you need to synchronize the timing within the system. The choice is for the conditional branching. It directs the workflow to different branches based on the specified condition. The fail is used to express the name and the reason when there is an error within the state machine, and it effectively stops the state machine and returns an error. The parallel state allows for concurrent execution of multiple branches. Once all branches have completed, the workflow will proceed to the final state. And the map state is designed for the parallel processing on dynamic array. It contains an array called the item path and iterates the process within the array. With activity state, you can create a complex workflow. In step function, not only can you make graphical workflow, but you can also use JSON-based language called ASL, Amazon State Language. And here we have the sample of activity state that was referenced from the technical blog. Within the ASL, you can specify the details such as the name of the state, parameter, retry, the result path, and more with precision. The step function offers two types of workflow, standard workflow and express workflow, and here is a brief summary. There are differences in terms of the duration, the pricing model, logs, and history. And the key difference is execution duration. The standard workflow offers up to 1 year. On the contrary, express workflow offers up to 5 minutes. In addition, standard workflow offers more action available than the express workflows. In the context of application integration, SQS and step function are often compared and asked in the exam test. SQS is messaging queue service used to decouple and scale applications. The step function is a service to coordinate multiple services into workflow. And here is a comparison chart. SQS integrates application in a linear fashion, whereas the step function by forming the complex workflow includes the parallel processing, iterative processing. And this is a sample question from AWS exam. A mobile application company has developed an application that extracts metadata from user uploaded photos and creates a photo catalog. The application is hosted on AWS, and the Lambda function extracts metadata from the photos to create a catalog. The metadata is categorized and sent to Amazon Elastic Cache. In this scenario, the answer is to use the SQS, not step functions. The image of the scenario goes like this. The multiple users are uploading the photos, which are processed in the parallel, but one by one in the linear fashion, so to use SQS is better choice. Considering the scenario, the process is executed for each number of photos. If the number of the user increasing, the higher the cost is. The step functions are built based on the number of state transitions. On the other hand, SQS is cost-optimal even for large number of requests and is useful for simple processing. The differences between SQS and the step function is frequently shown up in the exam. Next, I will introduce Amazon Event Bridge. The Event Bridge is a serverless event bus service that facilitates the connection of applications with data from the variety of sources. It's an extension and a higher-level replacement of CloudWatch Event. While CloudWatch Event supported only AWS, Event Bridge supports broader event sources from the third-party SaaS application. Currently, Event Bridge offers three types of services: Event Bus, Pipes, and Scheduler. The Event Bus acts as the central hub through which all the events are routed within the Event Bridge services. It collects events from the variable sources. And once collected, these events can be filtered and routed to different targets such as AWS Lambda, SQS, and Kinesis streams based on the rule defined by the user. And this allows for flexible, scalable event handling mechanism tailored to specific operational workflow. The event bus helps in decoupling the services and application by providing a unified pipeline for event ingestion and processing. Event Bridge pipes enable simplified event routing between the event producer and the consumer. And with pipes, you can define the source and the destination with minimal configuration. The pipes makes it easy to configure the direct integration and handle the transformation of the event data. Event Bridge Scheduler is designed to facilitate the scheduling of any AWS service action. You can create, manage, and execute scheduled tasks that trigger service at specific times or at regular intervals. The Amazon AppFlow is a fully managed integration service that enables you to securely transfer data between SaaS applications like Salesforce, ServiceNow, and Slack and AWS services. It simplifies the process of creating and managing the data flow, supporting both event-driven and scheduled data transfer. AppFlow is designed for scalability and can handle large volume of data. Additionally, AppFlow provides a built-in error handling and the ability to encrypt data both in transit and rest, ensuring the data security and compliance. In the context of data transfer, we compare AWS Data Pipeline and Amazon AppFlow. The data pipeline orchestrates data-driven workload and moves the data between AWS services. On the other hand, the AppFlow manages the data flow between SaaS applications and AWS services. I will introduce the AWS data pipeline in the next chapter on analytics. Next, I'm going to introduce front-end web and mobile application. I will introduce AWS Amplify. The Amplify is a platform service for building, deploying, and managing the web and mobile applications. With its user-friendly UI and managed features, it simplifies the process from development to operation. The Amplify is commonly used for deploying and hosting the static website or single-page applications (SPA), and it is well suited for deploying the relatively simple applications, but may not be ideal for the large-scale applications. The components of Amplifies are the Amplify CLI, which is used to configure resources and the project via the command line, and Amplify library that integrate frameworks like Vue and React with AWS backend, and Amplify hosting for hosting applications, and Amplify Studio, the visual editor for building both the application UI and backend. And this is an image of Amplify Studio. At this point, you can create a simple application in the sandbox. From the quick start in the center, you can choose to create a blog or to-do list. The left menu bar provides access to application hosting, authentication, API integration, and analytics. Next is AWS Device Farm. The Device Farm is a free managed service to test mobile apps on real devices, and it allows for physical testing in environments that closely resemble actual mobile conditions, and the pricing is based on the test execution time for each device. I will introduce the features of the Device Farm, and you can simply upload your mobile app to AWS and execute a real device test. And it supports a wide variety of test environments. You can test on the multiple operating systems and select CPU, memory, the data location, and network. It also supports common open source test frameworks. And you can capture a screenshot of the test operation, as well as gather evidence like operation screens, the execution logs. And this is just for reference, and this is a list of the open source testing frameworks supported by the Device Farm. And so far, I have introduced the frameworks for mobile and web applications, but they are not often appeared on the exam test, so it's sufficient for you to know the service overview. Next, I'm going to introduce data analytics services. And these are the area, the analytics service that are covered in the Solution Architect Associate exam. The data pipeline involves the data ingestion, the processing, the visualization, and the analytics. For data lake services, there are lake formation and S3. As a data warehouse service, the Redshift is available. For ETL service, there is a Guru. And the Athena that serves as the data analytics tool. The OpenSearch advanced search capability. And for real-time data processing service, there are Kinesis, SQS, and MSK. Additionally, for data visualization services, there is the BI tool QuickSight, the marketplace service, the data exchange, and the machine learning and AI services. The data pipeline as the series of the process for the data analytics, and the EMR provides the Hadoop ecosystem as a data analytics platform. I have introduced S3 in the storage chapter, the Redshift in the database chapter, and SQS in the application integration chapter. And I will introduce the machine learning and AI service later. I will introduce the real-time processing service, the Kinesis and MSK. In the data collection steps, there are two primary methods, the streaming and batch. The streaming processes data quickly, typically within the second or minutes, and is commonly used for the video streaming and processing data from IoT devices. On the other hand, the batch processing takes longer, ranging from minutes to days. It is often utilized for tasks like the daily synchronization of the enterprise systems. For streaming, the data is processed in real time, which includes the tasks like the formatting, aggregation, and storage. The real-time analysis of the data is also necessary. Moreover, the streaming processing must be equipped to handle the sudden spikes in the workload efficiently. The Kinesis is a collection of the services that handle the streaming data. In the context of the data processing, AWS offers the Kinesis Data Stream, the Kinesis Data Firehose, and the Kinesis Data Analytics. The Amazon Kinesis Data Streams, or KDS, collect and process streaming data in real time. The KDS is scalable and durable, and it can capture gigabytes of the data per second from hundreds of thousands of sources. The Amazon Kinesis Data Firehose, or KDF, delivers streaming data to data lakes, the data store, and analytic tools. The KDF captures streaming data, transforms it, and loads it. In 2024, it was changed to Amazon Data Firehose. The Amazon Kinesis Data Analytics, or KDA, is a service to analyze the streaming data. It supports SQL and Apache Flink. On 2023, the KDA changed to Amazon Managed Service for Apache Flink, but in this course I call it KDA. I will explain the Kinesis Data Streams, KDS. The KDS works as a producer and consumer. For data ingestion, the records are divided into data blobs and partitions. And based on the partition key, the data is divided into partitions. The partition key has a hash value, which determines which shard to be added to, based on the hash ranges that each record has. The consumers read data from streams. The Amazon Kinesis Client Library, or KCL, makes it easy to read data from multiple shards in parallel. the records are retained within the shard for 24 hours to 365 days. And during this period, the consumers can read the record as many at a time they want. Now I will summarize the quotas of KDS. Each shard can fetch up to 1 megabyte and 1,000 records per second. The number of shards is determined by the amount of records fetched and read per second. Shards can also be reallocated amongst the shards. In other words, it supports resharding. Data retention period is the 24 hours by default and can be extended up to 365 days. However, there is an additional charges for the data retentions. In terms of the performance, the data latency is less than 1 second, and it can also read up to 2 megabytes of the data per second. In the context of the real-time processing, the KDS is often compared to SQS. And here is a summary of the differences between KDS and SQS. The SQS is used for the message queuing services. The KDS is used for streaming data processing. Please keep in mind that generally KDS offer more advanced features such as ordering and throughput. Next, I will introduce Amazon Data Firehose. The Data Firehose delivers data in groups of a certain size or time interval, and this increases the efficiency of processing large amounts of data. It supports compression and encryption to increase the data security and transfer efficiency. It has the built-in Lambda function for data conversion. It offers many blueprints of Lambda functions. It also offers buffering, setting the timing before data is delivered. You can configure buffer size for maximum 128 megabytes and the buffer interval up to the 900 seconds. This is a comparison table of the data stream and the data firehose. The data streams require customization for both producer and the consumer. Additionally, it requires manual management such as sharding. On the other hand, the data firehose is a free managed service and you don't have to manage the infrastructure. And it offers near real-time processing with a minimum buffering time. It's natively equipped with the serverless data conversion with Lambda. The Amazon Managed Service for Apache Flink, the former Kinesis Data Analytics, is a free managed analytics tool for streaming data, and in this course I call it KDA. With KDA, you can analyze the streaming data using SQL, the Python, and the Scala. The analysis results can be sent to specified destinations. You can specify the data to be streamed by KDS or KDF as a data source. And this is a sample SQL. You can use the standard SQL for streaming data so that you don't need to run a new language, reducing your learning cost. The Kinesis Video Streams KVS allows you to collect the video stream in the AWS and perform real-time video analysis. It can handle streaming video from the millions of devices. And you can stream live or recorded videos and analyze them using the machine learning techniques. The videos streamed through Kinesis data streams can be analyzed with the recognition videos. I will discuss Amazon recognition further in the machine learning chapter. The Amazon KVS is categorized under media services. The exam guide includes the KVS and Amazon Elastic Transcoder as a media service. The Elastic Transcoder is a service for transcoding the media. For example, it can convert Windows media file to MP4 format. However, the Elastic Transcoder is released in 2013, and it is now common to use AWS Elemental Media Convert instead. Therefore, I believe it is unlikely the Elastic Transcoder will be appeared in the exam, so it is sufficient to simply remember the service name for reference. The Amazon Managed Streaming for Apache Kafka, or MSK, is a free managed service that allows you to build and run Apache Kafka in AWS. Apache Kafka is a distributed streaming platform designed to handle a large-scale streaming data quickly. As MSK is free managed, it reduces the operational overhead. You can focus on creating the streaming applications. It automatically manages Apache Kafka clusters and Apache Zookeeper node. And you can use Apache Flink, an open-source streaming processing framework. And this includes running the Apache Flink application created in the SQL, Java, and Scala. The MSK supports security features such as VPC, IAM, and encryption. The pricing is based on the size of the broker instances and straight on the pay-as-you-go model. Apache Kafka is a producer and a consumer-based message queue services, and this is an architecture of Kafka. The Kafka is highly scalable and can process a large number of messages. The messages sent by the producer are distributed across the broker, which allows for the processing of a large amount of data. You may notice this architecture is similar to Kinesis. In the following page, I will explain the differences between Kafka, the Kinesis, and MSK. And this is a summary of the MSK, the Kinesis, and SQS. Both MSK and Kinesis can process the streaming data in real time, so the use cases and the functionality are similar. The MSK makes the Apache Kafka available on the AWS, so it features Kafka function and APIs. The Kinesis is the AWS original service and supports high scalability and auto-scaling. SQS is most likely to be used for decoupling of the applications. The throughput of SQS is lower than MSK and KDS. I will further explain the differences of MSK and Kinesis. The MSK provides a configurable Apache Kafka option, which you can fine-tune the Kafka. The MSK retains the messages for 7 days, so you can reprocess the past data. Additionally, the Kafka's consumer groups allow the multiple consumers to access the data simultaneously. The Kinesis is a service provided by the AWS, so it offers the AWS native functionalities. It integrates with Kinesis Data Firehose and the Kinesis Data Analytics. The Kinesis allows you to extend the data retention for up to 365 days for the additional fee. I will introduce the data lake. The AWS Lake Formation is a service that simplifies managing data lakes. A data lake is a centralized repository. You can store both the structured and unstructured data at any scale. The lake formation defines which S3 bucket to be stored and automates data ingestion. The lake formation is often integrated with the analytical tools. The lake formation is integrated with ETL tool for data cleansing and transformation. Lake Formation integrate with IAM and offer more fine-grained access control. You can set permission at the table or column level, not just at the bucket level. Data is ingested into the data lake, the lake formation, and catalog it. In lake formation, the data ingestion process are built using the blueprint. The blueprint includes the definitions of a workflow for the data ingestion, the crawlers, jobs, and the triggers. And you can set access permission to the data locations. Additionally, you can grant permission per databases and table. In lake formation, you can set access permission at both the row and the column level. For example, you can grant permission access only to specific rows. Additionally, you can establish the access permission at the cell level. Next, I will introduce AWS Glue ETL service. The ETL stands for Extract, Transform, and Load. The ETL is traditionally used with the batch processing systems where the transformation before loading. But recently, the ELT has become increased due to advances in cloud-based data warehouse like Snowflake, the Google Cloud, and BigQuery, and Amazon Redshift. And these platforms can manage the heavy workload for the transforming data after it is loaded. The AWS offers services for both batch and streaming ETL. For batch ETL, AWS offers Glue and EMR. On the other hand, for streaming ETL, AWS offers Kinesis and Lambda. The AWS Glue is a free managed ETL service which extracts data from data sources and transforms it into the format suitable for target systems. It supports S3, RDS, the DynamoDB, the Kinesis data streams, and the DocumentDB as the data sources, and the S3, RDS, and the DocumentDB as data target. The AWS Glue features a component known as the crawler and the catalog. The Glue crawler analyzes the data source. If S3 is a data source, an incremental crawl can be used. The incremental crawl will only crawl the data that has been added since the last crawler run. The Glue data catalog serves as the repository for table definitions. It maps the source definition to the target and automatically generates Python code. I will introduce Amazon Athena, the data analytics services. The Athena is a tool for analyzing data stored in S3 using standard SQL. The S3 is an object storage without a structure, making it difficult to search objects, especially for use cases involving the storage of the large amount of log data. Therefore, the SQL analysis is useful the scenario. I'm going to introduce the Athena's workgroup. The workgroup segments your environment. With workgroup, you can specifically configure data access and the resources limitation and so on. The workgroups are used for separating the environment. For example, you can allow an IAM user to access production environment. And each workgroup has ARN, so you can grant permission for IAM policy. I will introduce OpenSearch service. The Amazon OpenSearch service is a managed service that makes it easy to deploy OpenSearch cluster in AWS. The OpenSearch is an open source search and analytics suite derived from the Apache licensed Elasticsearch. The OpenSearch is integrated with OpenSearch dashboard and visualizes the data. I will explain the architecture of OpenSearch. A document is the smallest unit of data. It's similar as a record in relational database. A document is usually formatted in JSON and contains information about a specific entity. An index is a collection of documents. It corresponds to the table in a relational database where each document can be correspond to row in that table. The index is where the data is stored. And the index is also made up of the one or more shards. A shard is a self-contained index. Each shard contains a subset of the data of the index and function as independently. There are two types of shards: the primary shard, which holds the original data, and the replica shard, which contains a copy of the primary shard's data for redundancy and load balancing. Each document has unique document ID. During the sharding, a hash value calculated from the document ID. Next, I'm going to explain node type. The data nodes actually hold the data and handle operations such as create, read, update, delete, and search data. Each data node contains several shards, both primary and replicas. The buster node, or administrator node, is responsible for cluster management tasks such as creating or deleting the indices, keeping the track of which nodes are part of the cluster, and deciding which shards to allocate to which node. The master node itself doesn't hold data. When determining how many number of nodes, you need to take the volume, the redundancy, the query load, and the read load into consideration. Next, I'm going to introduce storage tier of the OpenSearch. The ultra-warm storage is a storage tier for warm data. In other words, it works as a storage for between frequently accessed data and infrequently accessed data. Its purpose is to manage the data lifecycle, result in the cost-effective storage tier. It provides up to 90% cost saving than hot storage. For less frequently accessed data, you can store them EBS or local storage or S3. You should take into balance between cost and performance into consideration to determine which storage to store the data. By the way, if you store data in S3, you cannot change document, but delete by index. Next, I will introduce QuickSight. The Amazon QuickSight is a free managed BI, the business intelligence tool. The QuickSight is designed to deal with the hundreds of thousands of users without managing infrastructure. Based on analyzed data, you can create dashboards and reports. The QuickSight features a wide range of graph and reporting capabilities. It supports not only AWS services, but also third-party tools. The Spice in-memory database can perform the fast analytics without overloading the data sources. The next is the data exchanges, the marketplace service. The AWS Data Exchange is a marketplace service. You can subscribe the data from provider and store it in S3 and connect it by APIs. You can import and export the data to your data pipeline. Regarding the cost, the price varies between the provider and the subscriber, and you are charged with subscription and the amount of data. Next, I will introduce Amazon EMR. The Amazon EMR is a large-scale distributed processing platform that uses Apache Spark, Apache Hive, and Presto. The EMR can handle petabytes of data. As the name Elastic Map Reduce suggests, it can be connected to the variety of data sources for scalable processing. The computing and storage can be scaled independently for cost-optimal operation. And not only S3, but HDFS is provided in the cluster for data persistence and works with the big data such as S3, the Kinesis, and the DynamoDB. To understand the EMR, you need to understand the Hadoop ecosystem. On the next page, I will introduce the Hadoop ecosystem. The Apache Hadoop is the de facto standard for large-scale data distribution platform and is collectively known as the Hadoop ecosystem, along with its main related tools. The Hadoop utilizes the MapReduce algorithm to perform the parallel processing on data stored in HDFS, a distributed storage system. Apache Spark is also a framework for processing the large-scale data, which is faster than that of Hadoop. By performing the computation in memory, it improved performance. The Hive provides a SQL-like query language called HiveQL on Hadoop, enabling the execution of complex query on large dataset. The HBase is the distributed, column-oriented database on Hadoop that allows for real-time reading and writing on the large table. Both Apache Hive and Apache HBase typically run on Hadoop. The Presto is a distributed SQL query engine capable of quickly extracting information from various data sources. You can start analyzing and processing big data immediately without the need to set up and manage the framework yourself. Now I will explain Hadoop configuration. The YARN plays a role by managing the resources, including the CPU and memory, which ensure that the cluster operates efficiently. The MapReduce framework is designed to execute distributed data processing. In the ecosystem, HBase and HDFS work together to handle big data. HBase is a column-oriented database and suited for the operation on large amounts of small data. The HBase offers flexibility and efficiency for handling the various data types. On the other hand, HDFS is a distributed file system and used for persistent storage. The MapReduce is an algorithm for processing large amounts of data in parallel. It consists of two main steps, the map and the reduce. In the map step, the model input and transform data into the smaller set into the pairs of the key and value. During the reduce step, the model output from the map step aggregates the data for each key and generates the new pairs of the key and value. And here is a simple sample data flow. First, count the word at initial state. In the map step, convert the word into a key and the number 1 as a value. In the shuffling step, grouping the same word. And finally, in reduce step, aggregates the value of data with the same. And this is a simple sample, but in practice, the MapReduce to be applied to terabytes and petabytes of data. With EMR, you can use standard SQL to execute the MapReduce process. Next, I will introduce data pipeline. The AWS Data Pipeline is a web service that automates the movement and transformation of data between AWS services and the on-premise data store. Its workflow of processing data using ETL operation across the AWS services. It allows for scheduling of workload and tracking execution history. At this time, it has been announced that data pipeline will no longer be available to new customer. The access is now limited to existing customer, and there has been mention of transitioning to other services. Next, I'm gonna introduce migration and transfer. In this section, I'll introduce migration management assessment tool and the migration tool for server, application, and databases. The services highlighted in the blue color are the ones that are tested on the Solution Architect Associate exam. However, I will also cover other services to give you a complete understanding of AWS migration tools. As a reference, some of migration services have long names, so for convenience, I may use abbreviations throughout this course. First, let me introduce the categories of the migration from the on-premise to the cloud. The lift and shift involve the moving application to the cloud without changing their configuration. Since the system remains the same, the workload for migration is minimized. Improve and move makes changes to optimize the architecture for the cloud after migration. Because the system specs and operation change, the migration workload is relatively larger. A rip and replace replaces the existing system with completely new configuration on cloud without using the image of the old applications. And the modernize refer to the optimization the system for the cloud after migrations. When creating the migration plan, you might come across the term 7 R's. The retire means shutting down or deleting the systems that are no longer needed. The retain means keeping the system in the current environment. The relocate involves the migrating systems that were running on-premise to AWS. For example, you move VMware to VMware Cloud on AWS without making any changes to existing system. Rehost means migrating the system to AWS without modifying it. And the repurchase is switching from the existing product to a different one, such as moving from the licensed product to SaaS solutions. The replatform involved partially optimizing the system to take advantage of the AWS feature. And refactor is about making changes to the application's code to fully leverage the cloud-native feature during the AWS migrations. And this is an image of the 7 R's. The left side represents the on-premise, and the right side represents the cloud. Retain and retire stay on-premise as they are. The process for migrating the cloud include relocate, rehost, replatform, repurchase, and re-architect. And this is a reference from the AWS blog providing the overview of the AWS migration tools. The migration hub serves as the dashboard for managing the migration process. The AWS Application Discovery Service collects data from on-premise data center and helps plan migration project. The AWS Server Migration Service is used for migrating the virtual machines. The Database Migration Service handles the database migrations. Data migration tools include the Storage Gateway, the AWS Transfer for SFTP, the AWS DataSync, and the Snowball for transferring the large amount of data from on-premise to AWS. There is also Direct Connect, a dedicated line service. Now let me introduce Migration Hub, ADS, and CARD. The AWS Application Discovery Service, or ADS, helps evaluate the configuration and the performance data from on-premise servers to support AWS migration planning. And you can store the information collected by ADS in S3 and analyze it using the Athena. The method for collecting data varies depending on the operating system. For Windows and Linux, an agent-based method is used, while for VMware, there is an agent-less options. The actual assets within the company are often not centrally managed. For this reason, ADS can be necessary. The ADS provides two methods for collecting the server information, with agent and without agent. Each method supports different operating systems and features. For the agentless option, there is the agentless discovery connector, and this uses a connector for VMware vCenter to send the virtual machine information to ADS, but it only works with the VMware virtual machines. For the agent-based option, you install an agent on the target server to send the detailed information to ADS. This supports Linux, Windows, the virtual machine, and the physical server. Additionally, you can integrate with Athena to analyze the collected on-premise data. The AWS Migration Hub is a service that tracks and manages the progress of the migration between AWS and its partners through a single dashboard. It allows you to monitor all migration tools in one place. The Migration Hub dashboard provides visibility into various aspects, such as data analysis with Athena, network visualization, integration with other migration tools, and migration across the multiple regions. While the service itself is free to use, but there may be charges for the migration tool and the AWS resources you use. The AWS Cloud Adoption Readiness Tool, CARD, is the preparatory tool for transformation from the on-premises to AWS. And once you complete the CARD assessment, you can create a detailed plan aligned with the AWS best practice. The CARD allows you to receive an assessment report by answering the question across the 6 perspectives: the business, the people, the process, the platform, operation, and security. Additionally, by using the Migration Evaluator service, you can perform the total cost of ownership (TCO) analysis of your existing environment and after migration to AWS. The TCO calculates the overall cost of the cloud investment and maintenance. And for your reference, the service was known as TSO Logic until 2020. Next, I'm going to introduce data transfer services. So let me introduce to the Snow family first. Snow family is a service that uses physical devices to transfer terabytes of data. It also supports data transfer from on-premise to S3 and data export from S3. The Snow family is useful for transferring the large amount of data from network-restricted environment to AWS. Conversely, if you want to transfer a small amount of data in a good network environment, it is better to transfer it over the network. You can place an order for Snow devices from the console. It takes 1 week to 10 days for the data to actually be transferred, depending on the region. The secure transfer is possible because of the highly durable physical devices and the data is encrypted. And this is a list of Snow family specs for your reference. And the specs is current one, so please refer to the official AWS document for the latest information. You can migrate 1 petabyte of data in a month or 2 petabytes of data in a month using the 210 terabyte Snowball Edge. For reference, assume we transfer 10 terabytes of data with AWS Direct Connect connection is established. And this is an example calculation, which takes about 30 hours. The transfer with Snow family takes more than a week, so in this case, uploading via the network might be a better choice. Generally, it is recommended to use Snow family for transferring the large volume of data from on-premise to AWS. The data transferring via network not only takes time, but there is a risk of data an incomplete state due to communication errors. It's important to consider not just time, but also data quality and cost. The next is AWS Transfer. The AWS Transfer family is a service for data transfer to S3 and EFS using the protocols such as SFTP, FTPS, and FTP. It's possible to use either public endpoint or VPC endpoint. For authentication, you can assume IAM role to grant permissions. And you can also use the AWS Directory Service or Employer Customer Authentication Service via API Gateway. The AWS Data Sync is a data transfer service to automate synchronization data between on-premise and AWS storage. It supports S3, EFS, or Amazon FSx for Windows file server. The data sync is designed to automate transferring the large amount of data. It can be used for migration, data processing, backup, and archiving. This is the comparison table for data migration service. The transfer family is primarily used for the migrating data to S3 and EFS. You can use transfer protocol like SFTP, FTPS, and FTP. The data sync offers a high-performance online data transfer. It's optimized for migrating the large dataset over the network, and it's useful for continuous data replication. The storage gateway offers a hybrid cloud solution. It supports file gateway, the volume gateway, and the tape gateway. And it mainly used for backup, disaster recovery, and so on. The next one is server migrations. The AWS Server Migration Service, or SMS, migrate on-premise virtual machine instances to EC2 AMI. It supports incremental replication, which minimizes the service downtime. In contrast, the VM import, another virtual machine migration tool, that doesn't support incremental replication. Thus, SMS is currently recommended. Additionally, SMS can be used without an agent, but require the connector. And here the differences between the VM import and AWS SMS. The VM import is an older service released in the 2010 and it offers limited functions. On the other hand, AWS SMS was released in the 2016 and provides the broader range of features. For a larger scale server migration, AWS SMS is used. For smaller and manual migration, VM import is used. Next, I'm going to introduce Application Migration Service. The AWS Application Migration Service, or MGN, is a service for migration application from the on-premise to AWS. The AWS acquired the Cloud Endure and released it as the native service. Upon migration, the MGN replication agent is installed and used on the source server. Since some operating systems do not support the agent-less migration is also supported. By performing the block-level data replication, the downtime is minimized. Even during the replication process, the system can continue to operate as the source system. The migration process allows for modernization, including the disaster recovery and the conversion of the OS and the licenses. Although MGN stands for Application Migration Service, it is not limited to just application, and it can handle the wide range of migration. It serves as the successor to the Server Migration Service. And I have summarized the differences between MGN and SMS. The MGN is used in the scenario that require more advanced capability, such as data synchronization, the minimal downtime, and the migration from the other cloud platform. On the other hand, SMS uses the snapshot for data transferring and is typically used when the migration of a single server or a subset of the server to AWS. For migration between different cloud platforms or inter-cloud migration, MGN provides the support. And this is the history of the migration services. Generally, the more recently released service offer richer. The AWS Import and Export and the VM Import and Export released around 2009 to 2010 are rarely used today. From exam purpose, it's sufficient to focus on the service released after 2015. Lastly, I'm going to introduce database migration services. There are several methods for database migration. The simplest method is to transfer all the data from the source to the destination at once. If it's difficult to migrate all the data at once, you can start by migrating a portion of the data, followed by the remaining differential data. And another method is to continuously synchronize the database between the source and the destination. And in this case, you can use the direct connect to quickly transfer data over high bandwidth connection. So I will introduce AWS DMS. The AWS Database Migration Service, or DMS, is a service that migrates the database from the on-premise to AWS. It supports Oracle, MySQL, the PostgreSQL, and so on as source and target. Mostly, DMS supports the latest DBMS versions, but you should check the supported version from the document. It supports full migration, incremental migration, and change data capture. You can migrate the existing data and replicate ongoing changes with minimal downtime. And once the data migration is initiated, you can also monitor the migration status. I'll introduce the migration process the simple way without the schema conversion. First, create a replication instance via the console, and here you will configure the instance type, VPC, the subnet group, and storage. Adjust the instance type and the storage capacity based on the volume on the migration task. The image shows the replication instance, the source database, and the target database all within the same VPC and subnet. but you may need to set the port in the security group's inbound rules to allow connection as necessary. And next, create the endpoint for both the source and the target databases. And it is recommended to the test connection from the replication instance to the endpoint beforehand. And if you are using RDS, the connection information is automatically populated. For other database service, you will need to enter connection details like IAM or user password. Once the setup is complete, you can create the actual migration task. And this task allows you to adjust the migration method such as the full or incremental migration. And after the migration task is complete, they evaluate the migration and perform an additional migration of differential data if there are discrepancies. Next, the AWS Schema Conversion Tool, SCT, is a tool that converts the schemas, the views between the different database engines. The DMS alone does not support schema conversion, so if there is the differences between the schemas of the source and the target database, use SCT to convert the schemas. You need to use the specialized software between the same database engine and SCT between different database engines. The SCT agent is installed on each client OS. The SCT also supports converting not only schemas, but also code objects such as stored procedure and functions. To give you a clear image SCT, I'm going to provide the example of the schema conversion and the stored procedure conversion. And here I will introduce a sample of the schema conversion from MySQL and Microsoft SQL Server. The image shows the conversion of the table schema, and in this conversion, the identity has been changed to auto increment, and the data type of price has been converted to decimal. Due to the different data types and the keywords available in the Microsoft SQL Server and MySQL, the conversion is necessary. And the next is an example of the stored procedure. Unlike SQL Server, where parameter name require preceding the @ the MySQL doesn't need it. Also, the conversion of a parameter for the data type is necessary. The declaration and the termination of procedure differ too. However, sometimes SCT doesn't fully support specific database engine, and in such scenario, you need to manually convert the schema. Just for reference, the many migration tools are either free or very inexpensive. The cloud provider makes it easy for customers to migrate to the cloud, allowing them to continuously increase the revenue from the resources usage afterward. On the other hand, fees for the migrating data to different cloud providers are typically set higher, and this effectively locks the customer into the cloud provider. Therefore, it's important to carefully consider which cloud provider to select when planning your initial migrations. Finally, I'm going to introduce the machine learning services. Here is a list of machine learning services provided by AWS, which I will introduce in this chapter. For exam purposes, it's not necessary to know the detailed function of these services, as machine learning topics are not frequently covered in the Solution Architect exam, but are more relevant to the machine learning exam. And first, the Amazon Polly is an automated text-to-speech software that converts text into spoken voices. It supports real-time voice generation, enabling the interactive responses in applications and live audio streaming. The Poly supports over 50 voices and 25 languages. And utilizing the markup language called SSML, it can perform the annotation-enhanced speech. Additionally, by registering the terms in the lexicon, it can also read specialized terminology. The voices generated from the Amazon Poly can be saved and reused, making them suitable for podcasts, gaming, and other audio products. The Amazon Transcribe is a tool that converts audio file into text. You can perform the real-time text conversion by speaking directly into the microphone or by uploading the audio file to S3 for conversion. It allows you to add custom vocabulary to recognize specialized terms and proper nouns. It supports 16 different languages. It is also capable of distinguished conversation involving between 2 to 10 speakers. The generated text includes the timestamps, making it possible to identify when specific words or phrases were spoken. Amazon Translate is a translation service provided by AWS. It offers an API that allows integration with applications to achieve real-time translation. Utilizing the natural language understanding (NLU) and deep learning technology, it delivers high-quality translation. It supports major languages with additional language added each year. Amazon Translate is ideal for real-time translation and translating the large volumes of content. It supports multilingual capability for websites and applications. The translator user review, the automates the customer support, and the facilitates the international business communications. The next is Amazon Comprehend is the advanced text analysis tool that utilizes the natural language processing. By reading relatively lengthy text such as the blogs and news article, it can identify the word within the text as a feature, extract the important key phrases, and perform the language detection and sentiment analysis. It recognizes and extracts the entity within the text such as the people, places, and things. It also performs key phrases extraction and sentiment analysis. In the sentiment analysis, it can categorize the sentiment of the key phrases in the text into 4 categories: the positive, a negative, neutral, and mixed. The Amazon Lex is a chatbot service that uses conversational AI. It employs the same technology used by Alexa. With Alexa for Business, you can use Alexa for business applications such as the booking meeting rooms or explaining how to use office equipment like a copy machine. Additionally, Alexa for Business Blueprints allows you to customize a private skill specific to your company. Amazon Lex can integrate with Lambda to execute business logic and use Amazon Cognito for user authentication. Amazon Kendra is a high-performance search engine. In addition to traditional search results, it utilizes the machine learning to optimize the outcomes. It supports various data sources, not only S3, but also SharePoint, ServiceNow, the Salesforce, and OneDrive. It allows for filtering information based on user permissions, enabling the secure searches tailored to individual users. The Amazon Kendra is often used for resources searches within the large organizations. Amazon Forecast is a tool that makes future predictions based on the historical data. For example, it can read the sales data and forecast the future demand. By uploading the past and related data to AWS and selecting the model, you can get the computational result. And furthermore, you can optimize the result by tuning the forecast target, the time period, model, and the percentiles. Amazon Personalize is a recommendation service that suggests the optimal product to users based on the past purchases history and the promotion, and it is also used by the Amazon.com. You can upload files to S3 or fetch data from external sources via API connections to automatically analyze data, select a model, and get a result. And you can choose the type of recommendation result from the various recipes, which includes the product recommended based on what is best for the user, and the most popular recommended product, the product recommended based on the specific behavioral changes, and on metadata, and item similarities. The Amazon Fraud Detector is a service that detects the fraudulent access based on the historical communication logs. You can store past event data in S3 or import data via API connections. It automatically identifies the suspicious behavior pattern based on the IP address, timestamp, and user information. You can also adjust the sensitivity of the detection rules. Amazon Code Guru is a recommendation tool that uses machine learning to identify code vulnerability and improve the performance. It's used in the integration with the development tool. It automates code review and continuously monitors application performance. It also provides a recommendation to improve code quality and application performance. The Code Guru has features called the Code Guru Profiler, Code Guru Reviewer, and the Code Guru Security. The Code Guru Profiler identifies the most costly line of code and removes them, thereby improving the performance and reducing the cost. The Code Guru Reviewer uses machine learning to improve application security. And the Code Guru Security is the static application security tool that detects a common vulnerability based on the WASP Top 10 and CWE Top 25. Amazon Rekognition is an image and video analysis tool. By uploading video or image file, it can detect what objects appear in them. By uploading images of two individuals, it can recognize if they are the same person. And lastly, the Amazon SageMaker is an IDE for AI, machine learning, and data analytics that operate within the AWS ecosystem. It features the Jupyter Lab-like interactive interface with pre-installed library related to the AI and data analytics, allowing developers to save time on setting up their environment. For users without machine learning expertise, the SageMaker's Autopilot can automate everything from the model selection to evaluation. With Autopilot, you can simply upload the data such as CSV file and receive insight. And so far, I have introduced the AI and machine learning services that may appear on the exam test. For exam purpose, it is sufficient to just be familiar with the names and the summarizes of the services. Next, I'm going to introduce the practice questions. In this chapter, I'm going to explain the services and their frequency of appearance and the requirement stated in the questions. The first one is the services and the frequency of appearance. This is the number of the services covered in the Developer Associate, the Solution Architect Associate, the SysOps Administrator Associate, and the Data Engineer Associate exam. And at first glance, the Solution Architect Associate covers the most services and making it appear more difficult. And however, the Solution Architect exam tends to be the covered topics broadly but not deeply, so it isn't necessarily more difficult. On the other hand, the Developer Associate and the SysOps Administrator and the Data Engineer exam ask deeper into their expertise. And this is the number of services covered in the exam. The Cloud Practitioner covers 128 services, and the Associate covers the 132 services, and the Professional covers 158 services. As the level increases, the number of the services also increases. As of now, AWS offers over 240 services, so more than half of these are included in the exam scope. The current exam, the version is C03, which has been in effect since 2022. In the previous version, C02, the number of the services tested was 64, so the exam scope has significantly expanded, more than doubles. In addition, the number of the services tested in all level exam also increased with update. The number of services continues to grow each year. You can check the detail of the services tested in the in-scope AWS services and features of the exam guide. And this section lists the services that may appear on the exam with a total of the 132 services. However, not all the services will necessarily appear in the question set, and these are simply the services that have the potential to be tested. Based on our research, about 40 to 50 services appear in the single exam set. Moreover, many of these services are repeatedly appeared in every exam. For example, EC2, S3, the VPC, the Lambda, the RDS, and the DynamoDB often appear in the exam. Therefore, as a study strategy, it is more efficient to focus on the learning the main services and the future rather than trying to memorize the minor ones. And here is a summary of the 132 services that appear on the exam, as well as the frequency asked services, and we will go into detail on each category. And first, let's look at the management and the governance category. The services marked as the frequently asked are those that appear multiple times within the single exam set. On the other hand, the services that are rarely asked might only appear once, if at all. In this category, the monitoring tools like the CloudWatch, the CloudTrail, and the Config are commonly tested. In the context of the operational automation, the AWS Systems Manager's automation and the Patching Manager are frequently tested. Additionally, in the context of security, the parameter store is also commonly covered. And just for reference, in the professional exam, the multi-account setup are main themes, so the AWS Organizations with Control Tower, IAM, the Transit Gateway, and Service Catalog are frequently asked. but not often in the associate exam. While there's a lot of services in the security, identity, and compliance category, the most frequently asked ones are the IAM, the KMS, and the Secret Manager. The AWS WAF, the Web Application Firewall, often appear in the question about the DDoS attacks in mitigation, particularly regarding the database rules. The IAM Identity Center and the STS that commonly appear in the exam relate to the managing the permissions for external accounts. Additionally, you may occasionally encounter the question about the firewall-related services and the other security and threat detection services. The storage services are comprehensively tested. In particular, you will be asked about the detailed features of S3, such as bucket policy, encryption, S3 endpoints, and the transfer acceleration, so you need to be well prepared for S3. For EBS and EFS, you will be asked about their use in multiple AZ environment. EFS is more commonly used in the multiple AZ environment. And you will be also occasionally asked about the use of EFS and FSx for Linux server and Windows server. The EFS is used for the Linux server, while FSx for Windows server is used in the Windows server. For high-performance computing, HPC, FSx for raster is used. Additionally, you may encounter the AWS Backup and the AWS Storage Gateway. The Storage Gateway is used in the hybrid cloud. In the compute and the container category, the EC2, the autoscaling, the Lambda, ECS, the Fargate, EKS, and load balancer are frequently asked about. When the question about that includes the requirement to minimize the operational overhead, you should choose the serverless services instead of EC2. If you launch an EC2 instance, you will need to manage the server, which increases the operational overhead. And you will often encounter the question involving the EKS and ECS in the context of the operational overhead. Generally, the EKS, the Kubernetes, has more operational overhead. A serverless architecture with ECS and the Fargate is very common in the exam test. Regarding the load balancer, the ALB, the application load balancer, and the NLB, the network load balancer, are frequently asked about. The ALB operates at the application layer, and it can control HTTP traffic, making it frequently tested in the context of the security-related feature. All the services in the network category are frequently asked about. The Amazon VPC includes the security groups, network ACLs, the VPC endpoints, the IP prefix list, and more. Regarding the security, you will often asked about the differences between the direct connect and the VPN and the private link. When the question requirement specifies the traffic should not be exposed to the internet, you cannot use the VPN connections. Regarding the database, RDS, Aurora, and DynamoDB are the most frequently tested. In other words, the other database services are rarely asked about, so I recommend the comprehensively learning the features of these core database. For RDS and Aurora, the questions often cover offloading by read replicas and the promotion of read replicas to the primary instances for disaster recovery. Additionally, in cases where the strict RTO is required, there are options such as the Aurora's global databases. The DynamoDB is also frequently tested. For DynamoDB, the question often involves the DynamoDB Accelerator, DynamoDB Streams, and the differences between the DynamoDB's on-demand mode and the provisioned mode. In the Application Integration category, the SQS, Step Function, and the Event Bridge are frequently tested. In particular, SQS and the Event Bridge are often tested with the Lambda as part of event-driven architecture scenario. Additionally, SQS is also tested on the queue management, such as dead letter queue, so it is important to understand the basic feature of SQS. The Amazon MQ is sometimes tested in the comparison to SQS. Amazon MQ is used when you want to use an existing message queuing services like RabbitMQ. For example, if the question specifies minimizing the operational overhead, you should choose SQS. If it states already using the RabbitMQ and wants to avoid the hassle of implementations, you should choose Amazon MQ. In the front-end and web application category, the API gateway frequently appears. The API gateway is often tested integrated with the Lambda. Additionally, the features such as usage plans, API keys are also commonly tested, so it is important to understand these detailed features as well. In the Analytics category, the Athena, the QuickSight, the OpenSearch, and the Kinesis are sometimes tested. In particular, the patterns of the analyzing data stored in S3 with Athena are visualized with the QuickSight that frequently appears. The combination of S3 and Athena is easy to use because it is serverless and can be executed with a simple query, making it more convenient than implementing the analytics tool like Redshift. If the question specifies the minimizing the operational overhead or implementation effort, the combination of S3 and Athena is optimal. Additionally, the Kinesis data streams and the Kinesis data firehost are occasionally tested for processing streaming data. The Kinesis is often tested in combination with Logstream or IoT. Regarding the migration and transfer, all the services are tested well. Especially for database migration, the DMS and SCT are used. The SCT is a service that converts the schemas between different database engines, while the DMS is a service that performs database migration. Additionally, the DMS has the feature called CDC, Change Data Capture, allowing you to migrate running a database with minimal downtime. The AWS Snow family is a service that uses the physical devices to migrate a large amount of data to AWS data center. From ordering the devices to completing the migration, it takes about 10 days of the lead time. And if you want to minimize the downtime, it's better to upload the data via the network or use the AWS Data Sync. And regarding the AWS Application Migration Service, you will be asked about the differences between agent-based and agentless migrations. It is important to know that using the agent provides more detailed data, but it requires more effort for installation. And finally, the categories such as media services, machine learning, the developer tools are not frequently tested. Therefore, as long as you understand the basics, you should be fine. And so, that's all for the explanation of the services tested and their frequency of appearance. By prioritizing the frequency tested service in your study, you can efficiently improve your scores. Next, I'm going to introduce the requirement stated in the questions. In the exam question, you often encounter the requirement to choose an option with a minimal operational overhead and cost efficient. In the following pages, I will summarize the requirements that are frequently asked about. The graph shows the requirements and their frequency. Requirements such as the highest cost efficiency, the minimal overhead, and the high availability, the enhanced scalability, and the improved security are frequently tested. Additionally, these requirements are sometimes combined in the questions. On the next page, I will introduce the details of each scenario. First, you are often asked to select the services or architectures that operate at the minimum cost. For example, choosing the S3's storage classes or EC2's instance purchasing options are relevant. The requirement for minimal operation overhead is also a common topic. You choose the services and automation tools that minimize the management tasks. There are also frequent questions demanding the solutions that achieve the highest availability, like designs that ensure the system operates continuously without downtime, such as multiple availability zone configurations. The fault tolerance requirements also frequently appear. For example, the redundancy in Amazon S3, the multiple availability zone deployment for RDS, and the using elastic load balancer are relevant. And the requirements for a system to automatically scale up or down according to load are also a common topic. Auto-scaling, for example, would be applicable. The question demanding the best security practice using IAM, the security groups, and the VPCs are common. The questions on the encryption, access control, and the management of audit logs are frequently featured. For performance optimization, you are asked to select the services and design that improve the overall system response time and the data processing speed. The data durability often requires designs that prevent data loss. In data migration, the questions are posed about the migrating data from on-premise to AWS and between the different services. The AWS Database Migration Service, or simply DMS, AWS Snowball, and the Direct Connects are commonly referenced. And finally, the multi-region support question about the involved scenario that require distributing services across the multiple regions to provide the global services. So please keep in mind these frequently asked patterns, and it will help you understand the relationship between the actual exam requirement and their response more easily. In Chapter 4, the summary of this course, I will introduce the pricing calculator, partner network, support plans, and the marketplace. The AWS Pricing Calculator is a tool to help you estimate your cost. You can input your resource usage, such as the number of EC2 instances, and the calculator will provide a detailed breakdown. You can estimate the cost, save and share the estimation, and get the recommendations. And for your reference, the image shows the pricing trend for EC2 and S3. The prices of cloud service have been going down over the years because of the competition between the cloud providers and the improvement in technology. these prices are expected to keep dropping. The pricing and the services from all cloud services change often, so it's important to stay tuned. The AWS Partner Network, or API, is a global program whose purpose is to identify AWS partners who can assist the clients. The APN consists of two types: the consulting partner that help the client design, architect, build, migrate, and manage their workload on AWS. The technology partners is independent software vendor that develop and offer software solutions optimized for AWS. They provide the services such as SDK, APIs, and other tools to assist in the integration of the client's application with AWS services. The partners in the APN can get benefit, including the training and the certification program, and the marketing and the sales support, and technical support, and access to AWS resources. The next one is AWS Support Plan, and this is a list of AWS support plans. By choosing the pet plan, you can receive more comprehensive support. The further to the right you go, the more extensive the support becomes, including the technical support from the terms and the faster response time. The AWS Repost is a Q&A community where the members can post questions and the members of the community provide the answers. With AWS Marketplace, you can purchase software and the services from the third-party vendors. You can utilize the marketplace to discover the solution tailored to your specific need. For example, in EC2, you can purchase the machine images with the software from the third-party vendors. And here are the official training resources. While I've covered what's on the exam, I recommend for you to check the official document. AWS also has a training site called the Skill Builder with sample questions. And AWS announced new services at the event like re:Invent and the AWS Summit. If you use AWS often for work, it's good to attend these events. So, thank you for staying with me throughout this course. I also offer courses on AWS, Google Cloud, and Microsoft Azure. Stay tuned, as I will expand my offering in the future. With that, we've come to the end of this video. I hope the content has been valuable to your learning journey. Thank you for dedicating your time with me, and I wish you success.